My mic was muted. Sorry. Hi. Hello, everyone. I'm so excited to see all these our people today. Yeah. React Global Summit 2023 by Geekle is being open. Ladies and gentlemen, I'm happy to greet more than 300 people in our stream and coming up more and more. Now we have more than 4,000 registrations, and people come more and more, and most people watch this content recorded. And we have lots of speakers. We have like lots of people writing in our chat, and I'm so excited. I hope you are too. And I want to invite here our team is Anna and Nick. Hey guys, jump to the stage. Share this excitement with me. Yeah.
Hey, everyone.
Hello,
That
everyone.
excitement that you are sharing with us is even motivating us as well. Like, listening to you, we also get, okay, let's start. You're working so hard.
Like finally, like I always say, right?
Indeed
Yeah.
it is. And yeah, I'm glad to be here and also showing our chat that is running on our platform. So people, you are also a part of this event already. Thanks for
And
joining today, everyone.
sorry, Anna.
Yeah, I'm just also so happy being here. We can tell more about the event that we'll have today and tomorrow, about amazing speakers, program committee members, our community partners, and amazing topics that we prepared for you.
Cool, but the most important thing is happening right now in our chat, and I read people from Romania, from India, from Brazil, and Paula says 6 a.m. in Brazil and Chilo 5. Man, I admire. That's cool. Hi from
Nice.
Ukraine, React Rules, someone say from Switzerland, from Istanbul, from Brazil, Turkey, Macedonia, and I see it from all around the Europe and not only, but yeah, from all around the world. People, please keep writing where you now because this is something in Greek I see in chat. I don't read Greek, sorry about that, but I'm with you, Theodosis. Hi, and everyone. Yeah, just keep writing where you're from and what's going on there, what's your expectation, and saying hi in chat because this is what excites our team. So this is our sixth event, and we have Anna, tell us about speakers, about tracks, days, all these your magic you prepared.
Yes, of course. So we have in six event. It's really tough to believe and even tough for me. I've been preparing most of them. Yes, we have two tracks as usual. Today we have a junior track, and everyone from all over the world can just join us and watch live, or can watch tomorrow, day after, or when they want to upgrade something later, they also still can come and watch on YouTube. So yeah, we have our YouTube channel. Who is watching us on our platform, you have to know that we still have a YouTube channel. Please follow us and you will get updates and notification about our other events, also not only about React, TypeScript, JavaScript, Vue, and so many others. Okay, it was just some kind of advertisement, but let's come back to the junior track. Junior track today has 4 blocks, and we will have like 4 hours and 30 minutes of amazing speeches that's related for junior developers. Some of them can be also useful for senior developers as well. So just share this link with your colleagues, with your friends who are also React developers. Maybe they can, not maybe, I'm definitely sure they can find something new for themselves and they can learn. So today we have 4 blocks. We have breaks, we have Q&A session. You can just jump and ask speakers some questions that you have, and they will give you answer. So just amazing opportunity to ask anything that you want. Some speeches will be recorded, so yeah, but speakers still will be with us. They will join for Q&A, or you can read them on social media, as they will definitely give you the answer for your question. Tomorrow we have a senior day, mostly for senior developers, and you still can join us for tomorrow. You still can buy a ticket. It's paid event, and content there is more advanced level, so feel free to check our agenda. I'm really sure that you will like topics. Most of them will have live coding or use cases, so it's not just a series that's updated, or if you use it, will happen. You can see it in real cases, use cases, how people were doing this in their own projects, and you also can do it in your own projects as well.
Thank you for this overview, and it sounds really nice. It sounds tasty, but I believe right now it's a time for more chat because I see Zimbabwe, Egypt, I see Brazil, Moldova, UK. Lots of people from Ukraine. People, my heart are with you. Heart is with you. From Canada, from Bakhmut. No, we don't say it. Don't mention it here. It's our pain. Yeah, and yeah, lots of people who are greeting us in chat. But this is the time for thanks, for appreciation. Thank you to every speaker who contributed to this event. Thank you very much for your time. Thank you very much for your passion to give back to the community, for your innovations, for your ideas. Thanks to program committee. I know you guys helped Anna a lot, and that's significant. Like your contribution, and I appreciate that. And Anna wants to say something about that, right?
I still don't know how they can handle me so long for so many events, and they still helping me. I'm still trying to, guys, please, one more topic, 10 more topics, 20 more topics. Please take a look and give me your feedback. And yeah, at these times they were really strict. It's first time when I saw that people program committee members were really strict with their marks and their comments. I've never seen such let's call behavior that comments and evaluation before. So yes, they helped me a lot. I really hope that you will like the topics that we prepared, and and speakers who spend their time submitting the form, preparing the presentation, preparing recording, or joining us today and tomorrow, they invest a lot of their time just to share their knowledge and their skills and what they learned with you.
Yes, and Anna, how many experienced speakers versus beginners speakers? Because I know the Geekle is a platform where new speakers come up, trying their like first time speech and everything. So do we have new people, or all are super experienced? And you know what I mean?
We have speakers who were with us almost from first our event, and I know a few of them literally like maybe skipped one or two, but they are all our event. They love us and they prepare their speeches and presentation. We have new one, and we have those who are speaking at other events, but now they all decided to join us as well. But definitely every time I'm giving a chance to those who never had an experience, never spoken in any other events, or maybe they were just presenting something in their company. But yeah, this is what's happening, and always feel free to pin me or send where can I submit, what events are now available for. So yeah, always we are sharing list of even now our speakers and other attendees who are watching us. If you want to present and if you want to share your knowledge, if you want to share your something that you've done and you're sure that less people know about that, or maybe no one knows about that, feel free to pin us. We'll definitely tell you for which event you can go, where you can submit, and where you can speak, and we'll give our honest feedback about your
Absolutely.
topic. And,
just if you have any idea, just shoot short, I don't know, 1 minute selfie video. Find any one of us, I mean, from the team, and send this selfie video saying, "Hey, I have an idea of a talk I want to share with the community about that." And the program committee will decide, or community will decide. And once you do, we'll like be happy if you do this. So yeah, kind of that. Nick, what else we have to mention before
let me wrap up this intro with some necessary comments on our live stream and on our upcoming days and events in general. So first of all, everything will be recorded, and as Anna mentioned, this will be also available on our YouTube channel as the entire junior track, as an entire recorded live stream. It'll also be available right here on the platform, which you can see, the same place you'll be able to watch, and the same goes for the senior track if you already have the ticker. Of course, we're so happy to have so many active attendees here writing in the chat, as you can see literally right now on the screen. And also, if you don't have ticket for the senior track for tomorrow yet. We know the price could be a bit high for some of the attendees, so we have an offer for you. So first 5 tickets for tomorrow's senior track are only for $99. So I'm going to paste the link right now in the chat with the promo code. It should work, but yeah, this is you will get the link, and it'll give you a promo code. It's only for first 5 tickets. And we are looking forward to seeing lots of you tomorrow, because today we have nearly 8 hours of talks, and tomorrow have 9 more. So we have lots of stuff. And of course, we want you to be active. We want you to be active during Q&A sessions. We have speakers joining live, and we'll be ready to answer your questions. But of course, there will be a recording, so you can catch up later with the talks you missed. And of course, this is our 6th React event, and we are already have planned for the 7th later this year in November. I'm going to provide the link in a moment as well. So React 2023 Volume 2 will be held this fall of 2023. And yeah, please don't forget. Yeah, Ed, you're still muted.
Sorry, just to mention, people, it's when it's an online event, it's complicated. You don't feel the audience, and it's really important for us when you rate these talks, when you comment anything, just saying hi, man, or guys, do it more. Like you inspire speakers, and that's about community. That's about we really need it, because it's online. We need to touch you and to feel you. And now I see Germany, Florida people. It's night there. India, Greece, South Africa again, Ukraine, Florida again, Mars. How is it possible? Hello from Italy, and from from Germany, Australia, Czech Republic again. People from United States, all around the world. I'm so happy that wide community, and we head into 400 people in the live stream now, and coming more and more, I believe. And okay, I think we should get it out.
Yeah, we can just call our first moderator to the stage. And he's really amazing. He decided to support us all today. So you can see his face today and tomorrow.
Hey.
Hello.
Hi.
He decided to contribute 2 working days just to be with us. So, hi,
Hello,
Daniel.
everyone.
How are you doing? Tell us just a few words about yourself, and we can start.
Yeah, really excited to be here. I'm Daniel Afonso. I'm working as a developer advocate at OLX. This is like my 5th or 6th event with you guys. So super excited for the opportunity to be here once again in this scenario, to be moderating all these amazing talks and listening to all the amazing speakers we're going to have today. So excited for it.
Wow. Absolutely. So if we mentioned everything we had to, Nick, you know about that? Or
Yep.
and
Yep.
yeah,
Happy
then
to
we'll
have
leave
you.
the stage and give the Daniel, because he's pro now, as we know.
Yeah. Happy to have you back with us. Yeah. Please start. Go ahead.
Have great time. Give us your feedback, comments, shares, likes, and we will start.
Let's do it. See you.
See you.
Okay, everyone. Thank you for joining us once again. We are really excited to start. So we're going to start today with our first speaker, and with an amazing topic, and probably one fun thing about React, which is state management. So from the title of the talk is called From Chaos to Control, Mastering State Management in Your React app. So our first speaker is Ebenezer. He's a software engineer, is a founder of newdev.io, which is a new learning platform focused on helping developers learning to code and collaborate with one another. So I'm going to invite Ebenezer to join me here on the stream. So let me just add him. Hello, Ebenezer. How are you doing?
Hi, Dario. Yeah, I'm doing really great. It's so good to be here. Can you hear me?
Yeah, we're hearing you very good. We're excited to have you.
Cool.
To have you. So
I just want to confirm: is the audio good? Is there any buzz? It's
I can
good,
hear
right?
you very well. Let me see if anyone is mentioning anything in the comments, but everything seems good as well from that side. So,
Okay, cool.
where are you talking to us from right now?
Yeah, I'm talking from Lagos, Nigeria right now. So
Okay.
yeah.
What time is there right now at this?
Well, this is 10:21 a.m.
Oh, okay. So we're on the same time zone. Okay, cool. So without any further ado, give you the virtual stage. I'm going to start. I'm gonna add your presentation here, and yeah, we'll talk at the end for a Q&A session. So excited to listen to
Also,
your talk.
thank you very much. Yeah. Hey everyone. It's so good to be here. The title of our talk today is From Chaos to Control, Mastering State Management in React. I'm sure you can see my beautiful slide and how maybe chaotic it is. But what we want to do is, you know, move away from all of this chaos and get into some kind of control when working with state management in React. And that's because state management in React for many people is just a big hustle. Most developers, when they start with React, they start working with state, they're not even sure what to do. Local state management not working so well many times, and then they try global state management. They are wondering which tool should I use. Local state management, for example, is it use state? Should I work with class? Should I work with hooks? How do I transfer data from this component to the next component to the next component, and all of that stuff? So it can be really chaotic, just like our opening slides right now. And I added a puppy there for people who love dogs. And then in case your deal is cats, you can find a cat somewhere there. And then so that's what we're going to be doing today. We're going to see how to take a state management game and move it from chaos to control, make it look so good, so simple, straightforward, and all of that. My name is Ebenezer. I'm the founder of newdev.io. NewDev is a learning platform for developers and a place where you can find developers, collaborate with them, learn also, and all of that. Really cool platform. You can check it out at newdev.io. I'm also the author of Simplified JavaScript for very important programmers. It's a JavaScript book that is not going to make your head spin. So I simplified every essential part of JavaScript. I broke it down into the simplest of terms. Yeah, that's what I published this year. The feedback so far has been really awesome. So that's what I've been up to. Building new data. Are you interacting with the developer community, helping developers, and yeah, getting my book across to devs. Oh, you can also check me out on YouTube, and you can see my social links. newdev.io/Ebenezer is going to give you every information about me. So, and today we're going to be working with a code base. I'll try as much as possible not to code live to avoid unprecedented or to avoid unaccounted for issues. But I'll walk you through my code base. I'll show you what state management is all about with my code base. And you can find the code base right here, github.com/Ebenezer/React Redux hook state shopping cart. So I'm going to be walking you through React, local state management with React, use state hooks, but then we'll focus on Redux. You probably heard of Redux for state management. Redux toolkit. So the code from the most of my code from this talk is going to be from this code base, React Redux hook state shopping cart, which is also from my LinkedIn learning course. I'll talk about that later on. And yeah, so let's start with this one. How we handle states normally in React. You know about local state management. Um, I wouldn't advise anyone who's starting out right now to go and start working with classes with React. You want to do class-based React, and then it's just a hustle. Use the React hooks, the React use state hooks, for example, came to make state management easy. But I've always wondered, why can't global state management be as easy as local state management? And with local state management, why do we still have to go through so much trouble in setting up our application and in using it? So there are still restrictions that we have pushed with the use state hooks. But in terms of state management, there's usually hooks that I advise everyone learning React to go for instead of working with classes. And that's just because of the difficulty level, because hooks are a lot simpler than classes, in my experience. And I've been working with a lot of developers, so that's what I've seen too. Yeah, prop drilling can be an issue too. Prop drilling can be an issue. I'm focusing mostly on Redux toolkit, but I want to believe and I want to assume, make the foolish assumption that you know about prop drilling in React. If you're struggling with state management, you likely know about prop drilling and how when working with React state management, you're trying to handle data. You want to pass data from one component to the other component to the other component to the other component, just so that it's accessible in your application. And then you pass it as props, and then you go to the next component. You pass that same data as props so that you can transfer it to the next component, and then as props to the next component and the next component. That's so much work, and it's because of this prop drilling, because there is no way to handle state management in a straightforward way in React right now. React has the context API, but that's so much work. I don't know if you know about the context API. You can read up on it. It's too complex. I don't know why most of these things just have to be so complex with React. So there's no simple way to handle global state management in React. And that's what introduced us to prop drilling, passing data from component to component to the next component to the next component, just so that I can get to the 10th component. And we're passing data down. So that's a problem, prop drilling. And that is why when Redux came, we were all happy. Everyone was like, wow, Redux is here to save the day. We set up Redux. I don't know if I've talked about Redux. If I have global state management here, there's global state management with Redux. So when Redux came, we were all happy, like, yeah, finally we have like one global state that all components can access data from. And so everyone started using Redux. It became the go-to state management solution. Build a React application, as long as you're a serious developer, or it's Redux. If you're not using Redux, it means you've not started yet. So everyone started using Redux. But the problem with Redux is that did I mention it here? The problem with Redux is that it's the boilerplate code is just too much. It's too much work also. I mean, it's much better than what React provides by default when we talk about prop drilling or the context API. But the boilerplate code is just too much. There's a lot of setup that has to take place to use Redux. So you write, do so many setup. I don't have the Redux code base. I'm going straight to the solution to Redux, to this Redux toolkit, and that's when I'm going to take it to my code base. But Redux was just too much work, and people started complaining, looking for simpler ways to work with state management in React, because every time we thought of using Redux, there's so much setup, there's so much code we have to write. What if we can just put all of that code into one simple library and say, hey, okay, you can use every important thing about Redux here, but it's going to be much simpler and straightforward. And look at this. We have the principles of Redux right here as the single source of truth. The state of your whole application is stored in a single place. And that is why we were all happy, because Redux is finally here. State is read-only. The only way to change the state is by dispatching an action, so that we don't mistakenly update our store, update our state, and then make things go haywire in our application. Changes are made with pure functions too. So that's the beauty of Redux. And what if we can take all of this stuff and put it in a library that's Redux based, but we just don't add all the extra boilerplate code? We just make it simpler. And that was why that's how we came to Redux Toolkit right here. I think I'm ahead of my talk. Yeah, Redux Toolkit right here. So I added this link to my Redux Toolkit course on LinkedIn Learning, because in the course I broke everything down from the beginning. It's a course. A course is different from a talk. So in the course, it's a step-by-step process I'm following. And then I also want to mention that it's from Redux. That from LinkedIn. This is my course on LinkedIn Learning. In case there's any issue, like, oh, Ebenezer done. That was your course on LinkedIn Learning. You gave us as a talk. Yeah, this is my course on LinkedIn Learning. Where I broke down Redux Toolkit step by step. But that's why we have Redux Toolkit. So everyone that wants to go into that wants to use state in React, and they're thinking about Redux right now, like, why use Redux? Redux Toolkit is by the Redux team. Why use Redux when there's Redux Toolkit? Just go straight to Redux Toolkit. So that's what I advise people to even learn instead of Redux, because when you learn Redux Toolkit, you're also learning, in case the reason many people want to learn tools like Redux and Redux Toolkit is because of the fact that when you go and work in companies that use like legacy code bases, it's usually Redux. If you join a company that has a large React code base, it's usually tools like Redux. So that's why as someone learning React, it's advisable to learn stuff like Redux and Redux Toolkit. And the beauty of it is that when you learn Redux Toolkit, you're learning all the fundamentals of Redux, so you shouldn't have a problem. So that's why we have Redux Toolkit. With Redux Toolkit, we have less boilerplate, we have consistent patterns, and improved developer experience. So Redux Toolkit is consistent because everything is just provided for you. You're not trying to patch things up. Like with Redux, this whole library, and you can take it and do whatever you want with it. Redux Toolkit says, okay, this is what we've provided for you. Use it this way. So it's consistent. And then the developer experience is much more, or it's much more improved, or much improved, or whichever one. So that is it. That is it. Then now over to my code base right here. I think I have to stop sharing my screen and then share everything. So I'm just going to stop sharing my screen and then I'll share everything right now so that you can see my code base. So let me see. I've seen the option right here. The problem is that it's just I did not connect my external monitor, so I won't be able to see your comments for now until I stop sharing my screen. Yeah. So I'm just going to manage this. I don't want to go through the hassle of connecting my monitor right now, but I hope you can still see me. The problem is that if I go out of this screen to check if you can see me now, you're going to see my own view of everything. So this is my screen right here, and I'm going to make sure that everything is set. So this is my screen right here, and this is an example of my Redux Toolkit application. So this is me using Redux Toolkit, and right now I'm in the navbar. So this is a shopping cart right here, and I can add items to the cart. So this is just a shopping cart that shows how state management works. I can add items to the cart, I can remove item, and you can notice when I'm adding and removing an item, everything reflects right here. The number of items in the cart reflects right here on the top right of the navbar. So add, remove, and all of that, add items to the cart. And then I can visit the cart, and then I can see all of the items I've added to the cart. And I'm doing all of this stuff with Redux Toolkit. So the data that when I add or remove item to the cart, that data is going to a single store that every other components can access. So the cart can access that store. If I remove an item from the cart and right here in the cart, that also reflects right here in the product page. So that's how simple our application is, and that's what it's all about. I can check out to clear all items. So that's what it's all about. And I'll just take you through the Redux toolkit code and how Redux Toolkit makes this much simpler than if we had to use bare Redux or prop drilling in your application. So first of all, we start with a cart slice. So a slice is like a slice of what? A pizza. If you know pizza, for example, a piece is a piece of pizza, or I should use a loaf of bread, a slice of a loaf of bread. So different parts of something whole. So a slice of the store. We have the cart slice. We can have slices for many other things in our store. Maybe the user slice, slice for this part of the application, and slice for this part of the application. So this is the cart slice, and the cart slice is accessible to every component, so that this guy can partake in the cart slice as well as the cart component. So that's the cart slice right here. And then we have so I started with naming the cart. So we have the create slice from Redux.js/toolkits. I'm going to make this bigger just in case you can't see it. Yeah, so I'm importing the create slice method from Redux.js/toolkit, which you'll have to install if you had to use Redux Toolkit. And then I'm creating my cart slice right here. I have the name as the cart initial state. This is the state that this cart slice is going to start with. And I provided it with this data, cart product IDs. And then we have the reducers. And inside of our reducer, so the reducer is what we're going to use to tell our store what to do. The reducer right here. And inside of our reducer, we have the action, and then we have the action, and then we have the reducer, and we have the action inside of the cart slice. Now the action is what we are using. It's a pure function that we're using to tell our store what to do. It takes in the state, the current state, and the action again. Redux Toolkit can be complex like this, but this is what it was. This is what it was with Redux. Redux, for example. So Redux, okay, the terms are jumbled up. But Redux, for example, had reducers, had the main thing. We had reducers, then we had actions inside of it. But right here, we are seeing reducers right here, and then we're seeing different pure functions for add to cart, remove from cart, and clear all items. So these are we're just going to call these pure functions. And the reason is that we're going to use this reducer to generate our action, and that's what we're doing right here from line 3 to line 18. And the actions are what we're going to use to tell our state or our store what to do. So right here, we have this pure function add to cart, remove from cart, clear all items. And once we've created this, we can use it anywhere in our application, and that's going to affect this state right here. So add to cart right here, we're just taking state action, state.cart product IDs is equal to, this is just JavaScript, action.payload, and then we are spreading and getting all the other IDs. Remove from cart, same thing, this is just JavaScript, and then clear all items, we're setting the state.cart product IDs to an empty array to clear all of the items. And now we have our cart slice. Now, what do we do next after we have a cart slice? We're going to index. First of all, we're going to our store.js file. And inside of our store, we have the configure store method from Redux Toolkit. And this is how we get our central reducer. And why we have this central reducer is because we can add other reducers of different slices in it. So from this cart slice, we have a reducer right here. So right here in the cart slice.js file, this is called reducers. But for this cart slice now, we're going to get the reducer and the action. That's cart slice. We'll have cart slice.reducer, and then we'll have cart slice.action. And then look at our reducer right here inside of our store, cart and cart slice.reducer, and then we can add whichever other slice reducer we have. Now, stay with me. In case this is getting complex, I still have another solution for you. But imagine if this looks complex to you, how complex Bare Redux would have been. So this is very simple compared to Bare Redux. And then this is all we need to do. We come over to our app, that's index.js file, and then we have this provider component, which is going to make the store available to all the components. This provider component wraps the app component. And then over to the either the cart home or nav, but this is how we're using the cart slice. So first of all, we have the use dispatch hook and the use selector hook from React Redux. And this use dispatch hook, we get the dispatch method from it by calling the use dispatch hook. We get the dispatch method from it, and is this dispatch method on line 12 that we can use to dispatch actions. Remember, our cart slice has actions. We have the remove from cart action, declare all items action in cart slice.js right here on line 10 and right here on line 14. Now back to the cart slice, we get these actions, and then we use this dispatch hook to dispatch these actions. So look at the button for removing an item right here. So this is the button for removing an item. Dispatch right here, we're dispatching this remove from cart action. And remember that the remove from cart action expects product.id. Back to cart slice.js, remove from cart action expects state.cart product IDs right here. Remove from cart right here expects state.cart product IDs. And then we have state, we have action. So back to our store, back to our cart.js file. That's it. That's basically how we can remove from cart, clear all items, get add to cart. Now stay with me, because I still have another solution. Redux Toolkit is much simpler than Redux itself, but sometimes the best solutions are the simplest. Some people might think that the best solution is the one that's the most complex, the one that's going to make you struggle, and you'll be like, yeah, that's hard work. So I'll advise, if you want to choose between Redux and Redux Toolkit, I'll advise to choose Redux Toolkit, because Redux Toolkit is much simpler. But there's a simpler option, and which I'll show you right now. But this is how we're able to use our store in the cart component, in the home component. And I'm gonna be honest with you also, it's been long I use Redux Toolkit myself, because I've been using the simpler option, which I'm going to show you. So this is how I use components in cart. I use components in the home page. I use I use the state or the store, the Redux store in cart, in the home page, in the navbar. Same thing. I'm using use selector to get the state, state.cart right here, cart product IDs, and all of that, But remember, if you want to learn Redux Toolkit step by step, my course is right there. Now, the thing is that let me stop sharing my screen again so that I can see you all. Sorry about this. I should have set up an external monitor from the start. So the thing is that there's another solution for you right now. I'm going to check the comments if there are any any things. There's another solution for you. Redux Toolkit is there. You want to choose between Redux and Redux Toolkit, go for Redux. But what if there was a simpler solution? And this solution is what we're using in newdev.io. If you go to check newdev.io, we're using a simpler state management solution than Redux or than Redux Toolkit. And why I say it's simpler is because it's just like the states. It's just like the regular state management, So I'm going to try to share my slides again right now. And right here, I think I should see it right here. Yeah. And the solution is hook state. Hook state is what we currently use at newdev. And the reason we use it is because it's straightforward. You want to work with state management in newstate, you just use it like the way you use your regular components. And hook state is simple, it's flexible, it's lightweight. Hook state, it might sound similar to the use state that you know currently, hook state, use state, because it works like that. And let me try to share a comparison between the dependencies that you get for hook state, for use state, for Redux Toolkit, and for Redux right now. So this is the, I think I should be able to find it somewhere here. So let me share my entire screen again. And then I'm right here. So this is Redux. This is bare Redux. Now you want to install Redux into your application. You're bringing in 17. Oh, okay, yeah, this is 17,122 dependents that depend on Redux. And Redux currently has 9 million weekly downloads because it's the most popular option right here. Redux is the most popular option, but Redux has so many other if you install Redux into your application, you're installing so many other things with your Redux code base. Now, pack size shows 176 KB right here, which is little. I don't know where I can find the the pack size, but this is it. This is it for Redux. This is Redux right here, and this is Redux Toolkit with 2.4 million weekly downloads. When I started using Redux Toolkit, it was still new, it was fresh, and it became my own go-to when I started using Redux Toolkit. Redux Toolkit on pack size is currently 12.9 MB. I don't know why it's so high. And then we have hook state right here on pack size as 496 KB, and just 22,528 of us that are doing weekly downloads for hook state. But the thing about hook state is that it's just flexible and lightweight. You install hook state, you know that that's what you're installing into your application, and then you just go ahead and use it. So I'm right here again about to share. Yeah, I think I should just go straight to sharing. I'm going to do this again. I'll go straight to sharing my hook state solution. So this is currently with Redux Toolkit. And if you go to the code base I shared earlier, the GitHub repository, you can get the hook state version by going to the hook state branch. So main right here, and then I have the hook state implementation. So remember, this is currently Redux Toolkit, much simpler than Redux. We have the cat slice and all of this. Let me go to the hook state implementation right here. And the difference now, we don't have the cat slice anymore with hook state. We don't need the cat slice anymore. We have just the store.js file with hook state. And it just works like regular JavaScript. You don't have to start memorizing use reducer, create slice, actions, dispatch, and all of that. You just use it like your regular JavaScript. First of all, I import hook state from @hookstate/core. And then I export my card first, but create this my card. And this is how I'm creating my global state. This is just me creating my global card state. Const card is equal to hook state, and that's it. Hook state, you call the hook state function, and then give it whatever value you want to give it. And then you can import this card and use it anywhere. That's just it. I don't even need to wrap my application in a provider. I just create my state and I use it. And this is similar to the way Solid.js works. If you use Solid.js, state management in Solid.js, you don't even need an external library. You just create your state and you use it. Why is React not like this by default? If React was like this by default, that would have been really awesome. So you just create your card state and you use it. And people might be wondering, why is it so simple? Are you sure that it's the real deal? Well, it's what we're using at newdev, and it's working well for us so far. So you just create your card state and export it right here, and I use it. And then what I also did, remember I said hook state is flexible. So what I also did was like create the different functions, just like we did with slice and actions in Redux toolkit. The add to cart function, remove from cart function, clear all items function. I just created it here. You can decide to create it wherever you want. Even if you don't want to create this here, you can just create your global state and use it anywhere you want to use it in your global component. So right here we have the add to cart function right here, and it's a regular JavaScript cart dot this cart right here dot this cart product IDs, and then hook state has the merge function, merge method, which comes with the state or its properties. So we can have cart dot merge, and that means I'm going to add something to my carts right here, or I can even have carts dot the property cart product IDs, and then that property is also going to have the merge function. So it has the get function for getting the value of the state. It has the set function for setting the value of the state. And it has the merge function for appending values, so merging. So we have cart product IDs dot set right here. And we have cart product IDs. So that's for add to cart right here. And then for remove from cart is regular JavaScript. So let me remove this part so you see it in full. So this is regular JavaScript. Remove item from cart. We get the ID of that particular item. And then what we're doing is filtering it out. So this is regular JavaScript. All you need to know with hook state is, how can I create the state? How can I use it? How can I get from it? How can I set? So .get, .set, and then we can have .merge if you want to append values. So that's it for hook state. Basically, for clear all items, I have cart.cart.ids.set, and that's all we need to do with hook state. I come over to my cart.jsx file. I import the use hook state hook from hook state /core, and on line 8 const, I'm getting cart product IDs from. So I have to call this use hook state and then the cart's global state that we exported from store.js file. This one right here on line 3, and then on line 8, I'm getting cart product IDs from these carts, and I just use it. That's all I need to do. So cart product IDs right here. We have the cart product data is a JSON file. So for cart product IDs right here, this is how we're using it. That should be this one right here, where I'm filtering all the items in the cart, and all I need to do is call cart product IDs.get. That is all. That's all. Like, that's all we need to do with state management. Every other thing is your regular JavaScript that you know. Just get the state and then use it .get to get. And then if you want to set the value, cart product IDs.set, and that is all. Same thing I did in the notepad.jsx file. Get cart product IDs from the cart, and I want to get the value, the length, the number of items in the cart. Cart product IDs.get and .length, and that's it. Like, state management doesn't have to be complex. It doesn't have to be hard. All we need to do is to create our state and use it. So that is why I recommend simple solutions like hook state. So I'm going to stop sharing my screen again, and then I'll go back to the, I'm sweating, my fan just went off. So I'll go back to the slides. I'm done right now. Go back to the slide. And that's all. That's it. Like, state management doesn't have to be difficult. You know, you get your state, you create your states, and then you use it. If you've used another framework like Solid.js, you see that life is supposed to be easy. It's not supposed to be complex. You don't have to be handling so many different variables, so many different parts of states. Like, state doesn't have to be complex. Create your state and use it. So if you have the option to choose a simple solution or a complex one, choose a simple solution like hook state. So this is hook state right here, and I'm done. I'm looking forward to your questions. You can get my JavaScript book on Amazon, on Seller, or LeanPub. So that's a state management from chaos to control. Remember what I'm saying. You create your state, you use it. That's all you need to do when handling state. It doesn't have to be chaotic. It doesn't have to be a hurdle. Just create your state and use it. So that's it. Let's keep in touch. This is my YouTube channel. This is LinkedIn right here, GitHub, and Twitter. You can follow me on Twitter and just tell me, hey, I'm from React Global Summit, and I'll respond. So that's it. I'm done. I don't want to take more of your time, but that's it. Looking forward to your questions. Thank you very much, everyone.
Great presentation, Ebenezer. Really like it. How are you feeling right now after the presentation?
Oh, I feel it great. I feel it great. I want to stand up and turn on my fan, but that means I'll
Mhm.
have to stop my camera just for a bit. Yeah, but
Okay.
I'm feeling great. I feel like I've done a good job of introducing a simple state management solution for everyone working with React.
Definitely, I fully agree with you. So we have a bunch of questions from the chat. So I'll start sharing a couple of them, and I would like to see your feedback on it. So there's one question here that says, "Hey, even ZooStand uses something similar approach to this, which seems more simpler than Redux Toolkit. What are your views on it? Have you ever used ZooStand? Do you have any comparison of sorts?"
Yeah, so I've seen like Zostant's code, and I think it's similar to hook state. So yeah, like go for it. If you have a simple solution, use it. It's the performance is great. There's no downside in performance. Might even be much better. So that currently we use hook state on new.io. There's no need to use complex state management solutions when the simple ones are there. Life, React and life and code in general is supposed to be straightforward and simple. So use the simple solution if that's the option you have.
Yeah, really like your approach there. Like, try to simplify everything for developers. I think it's sometimes we can get lost into the confusion and everything. I think like from that perspective, it really helps. So let's go to the next question. So let's see here while we opt for the next question. So go with this one. Let's just give Ebenezer a couple of seconds to get his camera back on. Okay, it's back. You have your fan on right now?
Yeah.
Amazing. So we have one other question here that says, does updating one state in store cause re-renders of other components which are using other states from your store?
No, I've not. No, that's what we currently use at New Dev. I've not experienced that. Like, if it affects the component, that component that it affects is what's going to be rendered, not every other component. It works like your regular global states.
Okay, amazing.
So wait, but although, oh wait, maybe I didn't understand the question correctly. If the state affects like all the other components, if all their components are supposed to update, yeah, they are going to update. Yeah. I think maybe I understand the
Okay.
question better now. Yeah.
Okay. And another question here is, does Hook State have integrated TypeScript support?
I don't know about integrated TypeScript support right now with Hook.js, so I'm going to say I'm not sure. I'm not sure on that, but I think yes. My answer tilts towards yes. I don't use TypeScript a lot in on newdev.io, and that's because I have to make it simple for people we're working with. And I have TypeScript support turned on VS Code, so we get all the basic TypeScript support without using the TypeScript language. But my answer tilts towards yes, but I'm not exactly sure on that.
Okay. On a follow-up question, do you have any examples that interacts with any backend API? For instance, as guessing it is simply a separate function call and we had to wait on use effect, but is there an interface or anything that we could use with, I suppose we took state for that?
So I know that with Redux Toolkit, there's the middleware. I think it's the create thunk middleware that you can use to like have all the other stuff. What's it called? I've forgotten the exact function for that with Redux. So Redux Toolkit has that. Hook states is just flexible, is a global flexible state management that you can choose to handle states however you want. So what we do at New Dev is like I created hook one hook for handling fetch requests, which is called the use fetch hook. And I created
Okay.
that and I did everything that we needed to do that has to do with fetching data and interacting with APIs. And then whatever component I need, and I just import the hook and I use it. So you have the option to handle state however you want, handle API requests however you want when using hook state.
Okay, yeah. So that kind of answers one follow-up question that we have here, which is it possible to use with asynchronous functions? So I think the
Yeah.
answer is probably the same one.
Yes.
So another question that we have here from the chat is, have you used Hook State with Next.js?
Yeah.
So what can you talk a bit about what's your experience? For instance, in this scenario that they say they could use Next.js together with Next Redux wrapper.
wrapper state hydration. Oh, what exactly is state hydration? I'm not sure I've heard that term in particular, but
So
in terms of Yeah, go on.
Yeah, so I assume here, which is something that where everything runs on the server, but the state is iterated on the client side, so you have it working on the client and on the server. That's what I'm assuming. I might be wrong here as well, but
So I've not heard the state and hydration together. I know of hydration, I know of state, but we currently use Next.js. If you go to newdev.io, Next.js we're using, and our application is as a newdev.io is as a server-side rendered also. I don't know if that answers your question. Whereas in hook states Next.js and it's server-side rendered, so we can use hook state with Next.js, and there's no state management problem at all.
okay, that's amazing. So let me look at the questions here. Anything that might fit into here? Okay, there's a good one here. So does hook state use the immutability paradigm that Redux Toolkit uses? Or so how does it fit in this scenario?
Yeah, I'll say yes. It works with. I'm not exactly sure on that, but it works with proxies. Yeah, I think it works basically immutability paradigm. No, I would say because I'm not exactly sure what that means, what that term means on its own. But my understanding is that with Redux and Redux Toolkit, you cannot just update the states directly. You have to go through actions. Yeah, but I've demonstrated how we use hook states, and basically every state and every of its property has the set method. So if you want to update the state, you can't just say this is equal to this. You have to call the set method and use that to update the state. So I don't know if that answers your question.
Okay, thank you. Let me see a couple of other questions with hook state. Okay, so there's a question here that asks, so how does hook state handle page re-rendering when state changes? So what's the behavior here?
It's same way the use state hook works. It's the same way the use state hook works. Hook state was inspired, so from what I've read from the author of the library, it was inspired by the React use state hook. So it's the same way it works.
Okay, cool. So let me see if we have any hook state, because we have a bunch of Redux Toolkit questions here, but I'm trying to make sure we have all the hook states first before we go into that one. Okay, so there's one here that says, can hook state become complex for very large applications in any scenario? Because Redux has its own architecture, but hook state seems more flexible.
Yeah, that's the thing. The flexibility. That's the thing about flexibility. Also, if you don't handle flexibility well, you can start doing a lots of patches, and that's why I showed you how we have that one store.js file, just the same way that Redux Toolkit or Redux has its own store and all of that, and then we can create the. Normally, you don't even need to have the store.js file. You can create your store anywhere, your global state anywhere, and then just export it and use it, but you'll have to find a way to handle all of these things yourself, so that I don't get too complex. So from the start, just structure your application where you can have the store.js file, have your global state there, and then export it. You can even create the functions like I showed you, just the same way the actions and we use as work with Redux Toolkit, export them and use it in whatever component you want to use. So no, if it's getting, I think it even gets, it's much simpler with complex application than when you're using Redux Toolkit or Redux, in my own experience.
Okay, cool. So we have a question here. I don't know if this is about your code. So what's the difference between set and merge?
Yeah, set and merge. So with hook states, set just, I think something like that in my head. With hook states, set just replaces the data. So set replaces the data. If I'm saying this state does set equal to this data, I'm just replacing the data in there. I'm saying, okay, get this new data, it should be what's in you. Merge, what merge does is appends data. So it has, if you have an array as the current value of this particular state, and then you want to merge, you can merge another array with it, and you're just going to append that array so that you don't have to do dot set, and then you now call the state. So if you work with use state hook normally, or any other, or Redux Toolkit, yeah, you have to, if you want to add something to the state, you'll have to get the current value of the state, and then do that dot 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 for spreading, and then add a new one, and then say all of you are now. Yeah, but with merge, you can just say this state dot merge, and then just bring your new data, and it's just going to append it to what's already there.
Okay. Let me look at the questions here. So here's a question about Redux Toolkit that says, could you tell us any advantage of using Redux Toolkit, or even if you want to add hook state here over React context?
It's the complexity of React context. I've used React. I even have an article. I think I have up to 2 articles on using the React context hook. React context API, and then using the React context hook. It's complexity. Redux Toolkit is much simpler than React's context. So that complexity can introduce so many other things in your application. But the main advantage I see for Redux Toolkit over React context is that Redux Toolkit is, once you set up Redux Toolkit, that's it. You can just use it. It's much simpler than using React context. And I don't even think there's a particular guide, a specific guide like this is how you should use React context. The API is just there, and then you can use it however you want to use it. But it's just the complexity.
Yeah, on a follow-up to that, I think that the new React beta docs might have some cool stuff about using React context, but I haven't checked it, so don't quote me on that. So speaking about state, is an issue that sometimes happens, which is how would you manage state when there's any page reload? So do you have any solutions, and or specifically with web API storage? Do you have experience dealing with these scenarios?
So normally the way we handle state is usually with local storage or with IndexedDB. So the main way I handle state currently in new dev is with IndexedDB. I don't know if you know about the IndexedDB database. So you can use local storage. Local storage is quick, but IndexedDB allows to handle like so many types of data. I think there might also be a library that helps you persist data, but that's what works with local storage. But there's the IndexedDB database that's browser based. So you have your browser has the IndexedDB database, and you can just put your state there, reload your page, get it from there.
Okay. Yeah, that's a very good pattern, definitely. Let's look into the next question here. Let me see if we answered this one. We already did. Just double check here. So let's go to this one. Is a problem if I have a lot of different hook states? So here I assume it's different stores. Is this an issue, or how would you interpret this question?
No, excuse me. It's not an issue. It's just the same way you create variables in your application. Having like multiple variables is not an issue. But if you wanted to be inside of one store, you can do it the same way I did mine. You can just create the store global state and then make it an object and put all your other child states inside of it. And those states or whatever property you put inside of that, your global store object, is going to come with its own set method, its own get method, its own merge method. So if you want to do it that way, it's still fine. If you want to use different hook states, that's still fine too.
Okay, we're reaching the last two questions, I think, here. So in which case should we use Redux instead of hook state? Or any other simple solutions for what it's worth in this scenario?
Yeah, I can't say there's maybe in terms of preference. The only case I would say is preference. If you prefer the structure of Redux, and Redux, are you asking of Redux or Redux Toolkit? Redux, for example, I'm like, it's just better to use Redux Toolkit instead of Redux because it's the same thing, just that Redux Toolkit is simpler. But in terms of Redux Toolkit versus hook states, I'll just say it boils down to preference. If you like the structure, because Redux Toolkit comes with its own structure, the Redux comes with its own structure. You're used to, like, this is the way it works and this is the way it's going to work. You have your actions, you have your reducers. That it does what it says it's going to do. So if you're used to that structure and you prefer it, sure, use it. But if you just want to use state the same way you use states in your regular React application, then just go with hook states.
Okay. And on a follow-up to that, can hook state be integrated into projects where you have rather whole dependencies?
Yeah, it's just the same way you can easily use the React use state hook, unless the project structure has difficulty with working with hooks. But if your project can work with hooks, then you can just create your state and use it like regular variables.
Okay, so probably over React version 16.8, which is the one where hooks were introduced. So I assume probably there's no support for class components, right?
Yeah, I've not seen that support.
Okay, so let me see.
The name is hook.
Exactly. So let me see if we have any other comments showing up. I don't think so. Okay, so we don't have any, at least here on my Q&A session stuff, it's not popping up. So I think we can wrap it up for now. Ebenezer, it was a pleasure to have you. Learned a lot from your presentation. I think I'm going to try hook state after this. So I'll give you any feedback if anything goes wrong with me. So once again, thank you so much for joining. If anyone has other questions for Ebenezer, you can reach him out on the links that he shared on LinkedIn, on Twitter. You can check his YouTube channel. You can check his GitHub page. So once again, Ebenezer, thank you so much for joining us. It was a pleasure to have you.
Thank you very much for having me. The pleasure was all mine.
Thank you. Okay, so with that, we can go to the next presentation. So just a warning here, the next speaker won't have a Q&A session. So if you want to reach out Nivetha, you can send her a message on LinkedIn, on Twitter. You can check her links on the Geekle page here in the scenario. In this scenario, I think she has LinkedIn and Twitter. Yeah, definitely. So our next talk is about a topic that I would say is very dear to me, which is testing. And in this scenario, the topic is called Migrate from Enzyme to React Testing Library. So our next speaker, she's a web engineer with a working experience in multiple startups, and she's an ambassador for Google Developers Group and Women Tech Makers chapter for the past 5 years. And she's an international technical speaker and has given talks in various conferences around the world. So I would like you to give it up for Nivetha Maran.
Hello everyone, hope you're all doing good, and I'm really excited to meet you all in this virtual event. And before starting out, I wanted to thank the amazing organizing team for putting out this great event together, and also wanted to thank them for giving me this opportunity to share my knowledge. And before I dive into my talk, I would like to take a moment to introduce myself. So my name is Nivetha Maran, and I recently moved to Berlin from India to uh, pursue my passion for web development. And I currently work as a software engineer at a company called Delivery Hero, which is into uh, we are delivering delivering apps like Food Panda and etc. in all over the country world. Where I specialize in front-end development technologies like React and Redux, and have around 5 years of industry experience. And aside from my professional work, I'm also an organizer for GDG and WDM Berlin, which is a community supported by Google for fostering a sense of belonging in the tech industry. And I enjoy sharing my knowledge of web technologies through tech talks and other events. And as a newcomer to this community, I would really love to connect with every one of you on either on LinkedIn or Twitter. I have shared my details over here in the slide. So in today's talk, we're going to keep it really short and simple, just with like a very basic introduction. Uh, and what is the difference between Enzyme and React testing library? What is all about component testing in front end? And what are the different benefits of using Enzyme, and what are the benefits of using React testing library, and why we have to migrate right now into the React testing library from Enzyme in order to access like the future features of React 18, right? So it's going to be a little bit super short and a quick overview of how we are going to do that. And without much further ado, let's get started. So, in any web application, we know that testing is like the most important process in any development of an application, right? So, it basically ensures the application functions as expected and meets the requirements of the users. And there are like different types of testing that can be performed in the web application. For example, like we do functional testing, unit testing, and performance testing, also security, in order to make sure that the application kind of runs very smoothly and meets the users functionalities and requirements as expected. So among them, we are going to focus really in depth on component testing in web. So the component testing in web application involves the testing individual components or modules of the application in isolation, which means like we wouldn't be testing the whole entire flow of the user getting into the initial page and going through each and every flow of the web application. We test like very specific modules in the application, and we test them in isolation, so we make sure that they work correctly and properly as expected, right? So these components actually include features such as buttons, forms, and navigation menus, and database connection, and etc. So the main objective of the component testing is to identify and isolate any defects or issues that may arise within the individual components of the application. And it also ensures to each component of the application is working correctly as per the requirement. So it can be like the component testing which I mentioned right now can actually be performed either manually or through automated testing tools. So manual testing, like as we all know, that it involves a tester manually executing the test cases and going through the components and validating the behavior of each component, which is a little bit time consuming. But that is like the automation testing, which involves using tools like Selenium or Test Cafe to automate the testing process. So they are typically written to match components written in our own framework, for example, React or Angular, and they help us validate the user interaction with the UI components. So today we are going to see like specifically the like the top two most testing libraries or the testing utilities that we use specifically in React. So the first one being the Enzyme and the second one being the React testing library. So Enzyme has been a popular testing utility for React components for many years, but React testing library has been gaining popularity lately due to its focus on testing components the way the way the users interacts with them, and it basically simulates the user behavior, but in Enzyme we kind of artificially trigger it. So which doesn't make sense because like we have to test like the components how it will be behaving in the web application, right? So it doesn't make sense to artificially trigger the the component testing. So and React testing library comes into place and saves us in testing the components in more of a user simulation. So in this talk we will discuss like why you might consider migrating from Enzyme to RTL and the benefits and the challenges of doing so, and like what are the some of the best practices that you have to consider, like while doing the migration. So the first reason like why you have to migrate, right? So we have been using Enzyme, like as I said before, like for a lot of years now, and why right now we have to migrate. So there are different reasons, and like the topmost reason being is that right now the React 18th version doesn't have much support for Enzyme. So like if you have to test the components like in for the future React version, and if in future you're planning to migrate your React framework to the new version, the 18th version, then we don't have much support from Enzyme to support the same. So this becomes a really big blocker for us to migrate to the React testing library. And apart from this main blocker, there are different reasons that why you might have to consider to RTL, because Enzyme can actually shallow render or fully render child components, and it also exposes an API to interact with UI components and simulate user events such as buttons and like navigation menus and stuff like that. But developers can expect to use them and assert the behavior of the component. But all of these behaviors, like button clicks or navigation, are kind of done through the inbuilt functions from Enzyme, which are not very much like simulating the user behavior. But we just use the directly call the properties or the methods inside the component to make them available to the test component. So, for example, this is a very short example where you can find that we have created a component which is like a navigation button, and we are importing the shallow method from the Enzyme, and we are actually trying to simulate a click event on that navigation button. So we just simply added a class which is like name underscore button, and it basically clicks the button and checks if a function has been called. So Enzyme here actually uses the shallow method, and it provides full access to the React component, including props and states. So developers are able to set and read component internals inside test. So to demonstrate this also, we can pass a function to our component and call it by accessing the properties of our components directly. So by doing this, we have broken two rules of effective component testing. The one being we are not actually simulating a real user's behavior, and the two being like we are accessing the internals of the components to artificially trigger the handle click function, right? So like as I just keep reiterating before, this is basically the like not a very good way to test a particular component, like how it is being used in the web application, right? We are basically just trying to rewrite the component in a testing way, just passing whatever the properties are required to the component, and we're just trying to see if it behaves as we are expecting. And this does not like kind of reflects how it is going to behave in the real world scenario, right? So this is like two broken rules of effective component testing is what Enzyme has given us. So apart from that, there are other few challenges in Enzyme too. And there are other few reasons why you might want to consider migrating to RTL from Enzyme. So one reason is that like RTL encourages us writing tests that simulate use behaviors, as I said before, which can lead to more reliable tests. And Enzyme, on the other hand, focuses on the implementation details of the component. So this actually kind of like maps to the internal working of our code, not exactly the user behavior, and it makes our test more brittle and difficult to maintain. And RTL also has a very simple API which can make writing test easier and also more intuitive. And another reason to migrate is that the enzyme is no longer actively maintained, but while it still works for testing React components and testing the old versions of the React like before 17, but it is not actively maintained, and there are a lot of bugs for the new releases from the framework, and also there are not much bug fixes and updates from the enzyme team, and it is not actually maintained. So if we are going to arise into some kind of an issue with the enzyme, not basically on our component but on the enzyme library, it's going to be a like such a pain to fix it if it's not going to be actively maintained, right? So it is really advisable to not use that library. And also it is React testing library is maintained by the React team and is expected to be part of the ecosystem for the foreseeable future. So if any team wants to update the framework to version 18, there is no support in the Enzyme library. So I think these are some of the like very strong reasons why we might want to consider moving to React testing library from Enzyme. So yeah, we just saw like why it is very necessary to move to the RTL. So we just now see like what RTL is basically and how it is behaving in comparison to Enzyme, and why it kind of has a lot of benefits over Enzyme in different ways. So RTL is just basically like the implementation of the DOM testing library, which actually promotes querying the DOM nodes itself in a way that is similar to how the user finds the elements on the page. So, for example, like when on clicking like for example show model pop-up message or show model pop-up button on a website, on click of that we might be showing a pop-up message with a different like details and conditions, right? So this actually what happens in the background is like when the button is being clicked, that is like a re-rendering of the pop-up and it's being displayed. So that exactly what happens in the RTL2. Like this actually helps in querying the DOM and manipulates the DOM and exactly simulates the user behavior. So this approach of this library is able to encourage testing as if you were a user by interacting with the DOM, and therefore it actually simulates the real world usage of that component, and it also renders the components and child components. And as we have seen before, the enzyme just does the shallow rendering of the components. Like for example, when we had an example of clicking on the navigation button, it just does the shallow click of that button, right? So it's not gonna like simulate on the click event on the internal child components of that button. It's going to be really shallow. But RTL, on the other hand, it's going to render all the child components too. It actually does this using the environment, which the DOM environment called JS DOM. So apart from that, there are also a few more benefits on using RTL. So these are like I think one of the top 5 benefits why you might have to consider using RTL. So first of all, as I've said many times before, it promotes a user-like interaction in component tests, and it also encourages like the the interrogation of the DOM using text, roles, and test IDs. and we test what's the user experience when the page is rendered. It also actually promotes a very stable and meaningful test by hiding the actual implementation details of the component. So while testing the component, we just have to, as a developer, we just have to think that what this component's inputs are going to be and how it's going to, what kind of output it's going to just produce. We don't have to actually think about what are the different properties or what are the different logic that goes inside this testing this component. Whereas Enzyme, it actually allows access to components internals for with the properties or methods, uh, which is actually like writing out that particular component in React. And another main benefit is that the syntax is very clean and it's straightforward. So, for example, we have like different wrappers and updates like act or functions inside the RTL, which makes it very easier and very easy to understand and a cleaner code to write the component testing. And as also like since this React library is actually maintained by the document by the React team in itself, you know how great the documentation is already for the React framework. So you can expect the same good documentation for RTL2 since it's maintained by the React team. And that's like a sure go. And the last benefit would be like if we are using RTL, we still can actually use enzyme test um, in alongside RTL because it kind of provides backward compatibility. It also kind of provides you know it enables us to use enzyme alongside RTL. So it doesn't like you don't really have to just remove enzyme completely in the scratch and also just move to React or 18 and rewrite the whole testing suite for your application. So like I have this is like some of the really good benefits that RTL provides over enzyme. And yeah, we just saw the difference and main benefits of using RTL over Enzyme and the reason why I need to migrate, right? So, like in our company too, like we were just going through all of these like benefits, and we were just seeing like when is the right time to migrate to. And we just came up with a plan like how to actually migrate this whole so like we have lots thousands and thousands of testing unit testing for each components, and it is not really advisable to just remove completely the enzyme and just go into RTL like suddenly, right? So there should be a little bit of like a plan in place to do this like incrementally and achieve the final goal. So we just let's see like what are the different steps that we kind of kept in mind when we plan to migrate to RTL. So in order to make this whole migration smoother, like some of the practices that we kept in mind while doing this, and the top five most ones are like the one which I've stated here. So the very first being like just start small, right? So it just kind of start small, like just begin by writing tests for new components with RTL instead of rewriting all of your existing tests at once. So just like whenever you kind of create a new feature and whenever you create new components, just start using RTL instead of Enzyme. The one very really good thing is that React framework it kind of allows us a backward compatibility to use Enzyme alongside RTL. So whenever we write new components, we can still choose to use RTL and also have Enzyme like for the like in existing components or the old components. And also, as I said before, like make sure to read the documentation in detail and just get familiar with the new syntax and methods in RTL because in the way we call the components and wrappers in Enzyme is a little bit different when compared to RTL. So just make sure that you read the documentation, get familiar with the syntax. So it kind of helps you to map the functions which is present in Enzyme to like functions or the testing in RTL. And until you have fully migrated, it may be helpful to keep your Enzyme alongside. And Also, Jest and RTL works very well together. So just make sure you take advantage of the Jest features like snapshot testing and mocking. And also remember the goal of RTL is to test a user behavior. So focus on writing tests that simulates user interactions with your components. So I really wanted to emphasize on this point because this kind of case is like a different way of thinking when we used to write tests in Enzyme, right? So we have to write tests which actually mocks the user behavior and test the components in that way. So it's going to be a little bit of a shifting in way of testing the components. So like these are some of the like very top practices or the best practices or the steps that we followed during our migration, which helped us to successfully migrate like all the enzyme to the RTL like in a very good short amount of period and without running into much issues. So and in order to use RTL, it's very simple. Just use this particular command npm install testing libraries /react and /system. These are like two libraries which the React provides in order to use RTL inside our application or framework. So that's pretty much how why we migrate and how we migrated. Just to sum up, like we just saw what are the different kind of testings in application that we do in front end and why component testing is very much stressed in the application and how it is tested in isolation. And we saw what are the two different like testing libraries that we have popularly in React framework and how React have been behaving in a certain way and how it kind of started to like degrade in its functionalities to support future feature versions and how RTL came into rescue and how kind of what kind of benefits it provides, and also we saw how we migrated having some kind of a plan in place to migrate from Enzyme to RTL and how to install them. So that's pretty much the summary or like of how we can do the migration. And also in this link, it provides a great in-depth documentation for each user-simulated events and actions for each component. So whenever you just run into some kind of an issue, like while you're trying to migrate from Enzyme to RTL, this documentation provides a clear example for each of these simulated events, like each of the user-simulated events and actions. So I would highly recommend going through this particular link for in-depth examples and migration from Enzyme to RTL. And also there are other useful links that I have stated here, which you can just go through, like what are the different practices and different methods and actions that's being used during the migration, which might be really useful, like while you are migrating. So I think yeah, that's pretty much. As I said in the beginning, this is a very short and simple, lightning talk on migrating tests from Enzyme to RTL, and hope it was useful. And thank you again, and thank you again for having me here, and looking forward to the future events. Thank you.
Okay, so we're back. How did you like this last talk? I think it was very good. It's an experience that's very actual as well. I actually passed through the same process, so we had to go from Enzyme to the React testing library, and it was a very good overview that we just saw. Just a reminder once again that we won't be having Q&A for with Nivetha right now, but if you want, you can reach her out on LinkedIn, on Twitter. Just mention you watched her talking in React Global Online Summit and forward any questions that you have. So with that, we're about time to go to the next presentation. So the next presentation will be switching a bit gears. Now we'll go from testing to frameworks, and we'll be talking about Remix. So the title of the talk is called Build Better Websites. Is Remix the next gen React framework you should use? The next speaker is called Sebastian. He's a front-end tech lead at Northmill. He's a podcaster, mentor, academic lecturer, author of courses for one of the most important publishing houses in Poland and one of the largest IT job boards in Europe. I actually met this next speaker in person last year. We had an amazing chat. I fully remember it. And one of the things we actually talked about was Remix. So that makes me even more excited to watch his talk. So I'm going to bring Sebastian on the stream. Sebastian, how are you doing?
Hi, Daniel. So we even chat together before the stream that it is Alfonso's fault that I will do this presentation today because he was really convincing to try Remix, and yeah, I loved it, and now I want to share my experience with other people.
Super happy to hear that. So without any further ado, I'm going to ask you to share your screen and can start your presentation. We'll have a Q&A session at the end, so we'll chat a bit more after.
Okay, so I'm doing it right now.
Okay, so have a great presentation, Sebastian. See you in a bit.
Okay, so hello everyone. My today presentation is a Build Better website, as I have also said. React is one web development most popular and widely used libraries, and we can say that it revolutionized how we can build user interfaces and enable developers to create interactive and dynamic application. However, as you probably notice, mostly every front-end developers notice that the technology is constantly evolves, especially in JavaScript. So new frameworks and possibilities are constantly improve our work. So one of the latest framework to hit the scene is Remix. Remix is the next generation React framework that promises a better development experience, improved performance, and more straightforward development. Basically, I can just skip this slide because Alfonso introduced me. So let's go with the agenda. Before we dive into our discussion of Remix, I would like to introduce especially what is Remix, how it becoming the more popular framework, even the main competitor of Next.js. After that, we'll explore key features of Remix, discussing what sets it apart from the other framework, especially Next, and what benefits can bring us. Obviously, we need to cover comparison between Next and Remix, because this is the key question about why I should use Remix. After that, I will show you how you can get started with Remix, what Remix founders propose to set up a new project, and after that we'll go to the conclusions. So let's start with the first chapter. So Remix, what is it? Basically, it is a full-stack React framework gaining popularity on the web development community. It is a framework that, as I mentioned, promised a better development experience, improved performance, and more straightforward code base maintenance, especially maintenance. Remix was first introduced in 2020 by Michael Jackson, and Michael Jackson is creator of React Router, and Ryan Florence. At its core, Remix is server-side rendering framework for React that allows developer to build web applications focusing on the user experience and performance. It is designed to make it easy to create fast, reliable, accessible web application that can scale to meet the business needs and obviously needs of mostly demanding users. What is worth to mention, Remix is built on the top various technologies and tools like, obviously, React, TypeScript. Remix uses TypeScript to provide statically typed development experience, allowing developers to catch errors in early stage of development process. And obviously, TypeScript will improve our code maintainability. Under the hood, we can also meet Node.js, and in base configuration also Express.js, which will be our backend server. Remix apps can generally be deployed anywhere because Remix adapts the server request response to the web fetch API. It does this through adapters. For instance, we can switch our adapters to use for AWS Architect, Cloudflare's pages, Cloudflare workers, Express.js, Netlify, or even Vercel. But what is important, community also can does some adapters, and we can meet adapters like Fastly, or even to Fastify, or even we can deploy our Remix application on Google Cloud Functions. So basically, we can do something more than just deploy to a Node server. Looks good, but okay, how does it cost to use Remix? It is important to note that Remix is open source framework, and such as it is free to use and distribute. This means that anyone who use Remix for their personal or commercial projects without any licensing fees, especially this is important in enterprise solutions. And as of this presentation, Remix has over 23,000 stars on GitHub, which is impressive for a relatively new framework. This indicates a growing interest in Remix within the web development community. Another indicator of framework's popularity can be, for instance, number of contributors. So Remix right now has over 500 contributors on GitHub, a significant number for a project of its size. This shows that Remix has an active and engagement community of developers who are contributing to its development and helping to make it better. Especially when you go to the issues pages, you can see that this is a really active page, and people try to resolve problem as fast as it is possible. But what is core philosophy of Remix? One of the core principles of Remix is to embrace the server and client model, including separating source code from content and data. This means that Remix is designed to make it easy to build web application that will work seamlessly across both the server and client side, with the clear separation between them. This allows for greater flexibility and scalability in web development process. Another key aspect is to work with, not against the foundation of the web. Remix is designed to work with existing standards and technologies rather than trying to replace or introduce the new one. This approach helps to ensure that Remix applications are reliable, maintainable, and future-proof, and obviously accessible. Remix also believes in using JavaScript to augment the user experience by emulating browser behavior. This means that rather than relying on complex abstraction or sophisticated technologies, Remix leverage the power of JavaScript to create more intuitive and engaging user experience. Finally, Remix believes in not over-abstracting the underlying technologies. This means that while Remix provides a modern and powerful development experience, it doesn't not abstract the core of technology that underpin the web, such as HTML, CSS, and JavaScript. This ensures that Remix applications are accessible, performant, and reliable, regardless the user device or browser. Loaders and actions are two core concepts in Remix that can help simplify web application development. Loaders, basically, they are functions that fetch data from the server or an external API and return it to the component that needs it. Conversely, actions are functions that modify data or trigger a server-side action in response to user interaction. So loaders and actions are powerful tools enabling developers to quickly create dynamic and responsive web application by separating the data fetching and data modifying logic from the component and use them Remix allows developer to create cleaner, more maintainable code that it's easier to debug and test. So with that, our components will be cleaner to understand, especially if you want to introduce a new developer, or even after some time, I even don't remember my components. So it is easier when logic, especially UI logic and business logic, is split to separate function or even files. One of the key benefit of loaders and actions is that they make it easy to create complex interaction between components without worrying about underlying data fetching and modifying logic. This allows to focus directly to build user interface with great user experience, rather than getting bogged down with details of data fetching and modifying. So basically, in this example, you can see that loaders and action you can just define by exporting function with the same name, and Remix will catch what to do. Inside the loader function, I called API to download data, and as a result of loader function, I returned this data using provided JSON function from Remix. I just need to remember that every loader and action which I want to use with my route component should be exported, and after that Remix will catch what to do and invoking this function when it will be needed. In this example, we can see action. I define action to gather some information from the user. UI has implemented a form with two fields, email address and password. You can spot the difference. I use the form component instead HTML form tag. Remix provides this to improve experience for getting information from user. And after user hit submit button, Remix will call action function. And in this example, you can see that I invoke a function create user inside action function. So I will create a new user and new section, and voila! I don't need to care about anything else. What is important? Action function can expose, for instance, in this example, a request object, and from request object I can get more information about what is happening, why this function was invoked, and obviously I got the form data to my create user service. To better understand the topic of this presentation, it is necessary to delve into key features of Remix. Routing is possibly the most important concept to understand in Remix, because everything starts with the routes, the compiler, the initial request, and almost every user interaction afterward. Remix Run comes with the built-in routing system that makes it easy to define and manage your application routes. To add a new screen to your Remix application, just put the component into route folder and it will be attached to route automatically. Notice that route will have the same path as your component file name and obviously location in folder. You don't need to register screen manually like in typical React application, but what if you will want to make more complex paths and screens? Nested routes come with help. Nested routing is a general idea of coupling segment of the URL to component hierarchy in the UI. In almost every cases, segments of the URL determine the layouts to render on the page, the code splitting JavaScript bundle to load, the data dependencies of these layouts. In this screenshot, you can see the structure with the used nested routes approach. What is non-typical here? Index files. Index routes are often difficult to understand at first. It is easiest to think of them as the default child route for the parent route. When there is no child route to render, index will be rendered. Dollars. Prefixing a file with dollar symbol will make the route path a dynamic segment. This means that Remix will match any value in the URL for the segment and provide it to your app. Example, $invoice ID.jsx. Nested components also bring another feature. It is very important, especially if you want to handle properly user experience, especially in a fast way. If an error occurs while rendering a certain component, it doesn't affect the other nested parts of the page. So you can encapsulate the error just in the section where it happened, instead of getting a general page error. Let's consider a UI to help. Let's see how each segment of the URL maps to the three things: a component layout, JavaScript bundle, and piece of data. Let's focus on two things: highlighted part of the URL and highlighted component. This structure is from the previous slide. Every more nested components was rendered inside the parent. This is the idea of nested components and routes. How to achieve it? Your component should have imported the outlet component provided by Remix. You can also know outlet from new version of React router, and Remix will know where to render the nested components. One of key benefits of Remix Run is automatic server rendering. This means that your web application can be pre-rendered on the server before being sent to the client, which can result in the faster load time and very important SEO marks. Also, it includes automatic code splitting features that optimize the loading time of your application. So I recently laughed with my colleagues from work that it is really difficult to break Remix application to get really poor Lighthouse scores. And one of the other key benefits of Remix, it is extensibility. Remix is designed to be modular and flexible, which means that you can easily extend and customize its functionalities to meet your specific needs. Previously, I told you about adapters. Also, it would be the best if you remember that this is that Remix application. This is application based on React and, for instance, Node. Or we can also use Deno, for example. So you can easily extend any other frontend. You can easily extend like any other frontend and backend project. Remix exposes ways to achieve that, so you don't need to worry that you have no control about your project. Now, now let's talk about the main competitor of Remix Run. So basically, nowadays, this is Next.js. What are differences between Remix and Next.js? If we take a quick look, Next.js and Remix may seem like they are following the same goal, and probably they do. But if we analyze the features and approaches they offer, we can identify similarities and differences, and we can think about scenarios being solved in more suitable way with one of the other framework, especially in different projects. Both frameworks are React based. They support server-side rendering, but on the other hand, Next offers the possibility of pre-generating static pages and content at build time. So it is using static site generation, while Remix doesn't, but maybe it will change in the future. To serve content as fast as possible, Remix relies the style while revalidating caching directive instead of pre-generating static content. Client-side navigation brings some more differences. For instance, Next.js offers a smooth navigation to the users with prefetching. You can use link component to make a website preloaded. Limitation is that a link component from Next offers only prefetching for pages that were pre-built using SSG. Remix, on the other hand, uses HTML link tag, so it can prefetch not only links, but actually any page. And what I told previously, Remix also is based on web fetch API. So instead, depending on Node.js and instead of depending on Node.js, that gives possibility only to running Remix, only to giving possibility to deploy application on Node.js server. With Remix adapter, you can deploy in various types of technologies. Why Remix is so fast? There is a long article about that, and it is too long to tell you now about that. So basically, you can just scan this QR to visit blog post. The founders of Remix created a really long post when they describing how they achieved performance, and it is really nice lecture for the evening. And how to get started with Remix? Basically, the easiest way is to use provided Remix stacks. You have three to pick from: the blue stack, the indie stack, and the grunge stack. But what are these stacks? Each of these stacks includes pre-built components and functionalities that you can use to build your website, as well as convention, best practices for structuring your code base. By using these stacks, you can save time and effort during the development process and ensure that your web application is optimized for specific use case. And of course, it will save a lot of time. In just a few minutes, you can get your application ready to deploy with wired CI/CD pipelines, connected database, with basic data model, with Prisma, and with even user authentication. It also has tools for development setup like Tailwind, TypeScript, Prettier, Slint, Cypress, Mock Service Worker, Docker, vtest, testing library. So basically, before Remix, I mostly used all these technologies from this list. So you know how much time it can cost to set it properly. Remix developers made CLI, which can generate a new project. So you can just type npx, create Remix, and select which stack you want. But which stack to pick? The blue stack is designed for building web applications that require a lot of interactivity and dynamic content. It can be deployed to the edge with long-running Node.js server and Postgres database. This is mostly intended for large and fast production-grade applications serving millions of users. For instance, you can spot in this stack that it uses Postgres. It contains multi-region fly deployment with Docker and multi-region fly Postgres cluster. On the other way, you can pick indie stack. Indie stack can be also deployed with Node.js server. What is the difference? The difference is in database, because indie stack uses SQLite database. This is intended to get you going quickly with little complexity or prototypes and proof of concepts that can be later updated to BlueStack without much trouble. Mostly with my first project, I did this route. I generated indie stack project for prototyping, and after that I migrated to the BlueStack and started using Postgres. The last one stack, the grunge stack, was prepared to deploy application in AWS infrastructure. So it means that this stack will be easy to scale. Another difference from the previous stacks is database, because as you can notice, this stack use document database DynamoDB. And let's look how a generated project looks like. So basically, before a presentation, I type npx create remix. I pick template in the stack, and only I had to select in which language I want to write my code. It is TypeScript or maybe JavaScript. And after that, whole project were generated. And you can notice that we have here a lot of file, and we have defined a structure of our project. So we have configured, for instance, Tailwind. Also, you can notice that Remix use Vitess for tests. And what else? We can see fly configuration. So we just push our repository to fly, and it will be deployed because whole pipelines are prepared. What is important here? Prisma also is configured. It is prepared some base model for user for authentication. We have prepared a seeding function for testing, for instance. And what is the most important? Our app folder, which contains whole logic which we want to develop. Everything is starting in three most important files. Entry client, it will represent our front-end side of application. Entry server, this is configuration for our backend side. And root, you can notice that this is our HTML. We can attach here whole metas, whole links, and some specific option for our application. What is important, if you want to attach a new screen to your application, it Remix watches routes folder, and you can notice that in a base version of Remix application, we have implemented some examples, for instance, join, login, logout screens, and also we have examples how to use loader and action approach. So you can see that we have the defined join screen, obviously some extra stuff, inputs, etc. And just to invoke, after submitting button create account, Remix will know that it's time to invoke our action function. So it takes form data. From form data, we can grab this data from fields which user field. It is added some validation, and after that, session and user will be created. What is important? Actions and loaders. We have more function than actions and loaders. For instance, if you want to configure meta for our page, we can just export another function. It is called meta, and we can define, for example, title or anything else. So basically. It is really easy to develop. You don't need to create extra controller because your backend side action will be placed in the action function. Conclusions, or even making the right choice between Next.js and Remix. Both Next.js and Remix are powerful and popular frameworks that offers a lot of benefits for web development. Next.js, it is more powerful and future-rich because it is also older, while Remix is more focused on ease of use, speed, and minimal setup. To successfully implement either Next.js or Remix in your project, it is important to understand the specific strengths and weaknesses of these frameworks and choose the one that will be the best to fit your needs. I use Remix for a couple of months, even maybe 1 year, and I can recommend it. At first, I started using it for a private project. So in Mid.js Summit, I talked with about that with Alfonso, and he convinced me to let's try. So I tried, and after that, after a few months, when I rewrote my application, because previously I used Gatsby and Docosaurus, I had multiple deployment, multiple stages, so it was irritating to maintain. After that, when I rewrote my whole application to Remix, I joined to a new team which used Remix. So I had possibility to use Remix in production. We were building the NFT market, and my only regret was that Remix tags wasn't used on this project, because a lot of things would have been done well right away. So basically, I want to say that Remix tags are truly prepared for production, and it is easier to maintain application with using them. Of course, it should be remembered that Next.js has a much larger community, thus the amount of available content, additional libraries, and this may be the main argument for many developers. Why not try something new? But I can truly recommend Remix. And this is all. Thank you for your time. Feel free to contact me.
Okay, great presentation, Sebastian. Really liked it. It was an amazing overview of Remix, so you have my congratulations. Let's go over the Q&A, the Q&A, and then the comments and questions from the audience. If you have any questions for Sebastian, feel free to post them on the chat. Let's start with the first one, which I think you kind of gave an overview in your presentation, but what would you say are the advantages of Remix over Next? So if you have an existing Next application, what would you say would be the reasons to migrate it to Remix?
I think that there is no reason right now to migrate Next.js and migrate Next.js to Remix, because both of these frameworks are pretty fast, they are high quality frameworks. So basically, if you decided to Next.js, this is good choice. This is not jQuery that is pretty old and it's time to develop a new application. Probably your code base is also new. So I even won't think like that. I will think about picking Next or Remix before you start a project. Basically, as I mentioned, this is really similar stuff, but it can also depend on developer preferences, because I thought with a lot of mates, because a lot of my colleagues really loved Next.js, and they always asked me, why you pick this Remix? What the hell? Why? But after that, I said, let's try. Because I also used Next.js, I also used T-Stack, but after when I got contact with Remix, so it was irritating for me writing in Next, because I was thinking, why they did like that. This in Remix is pretty easy to achieve, and after a few months, my colleagues from work, they had to do a POC with Remix, and after that they said me, "Why I use Next? Remix is so easy."
So they changed their minds, basically. Yeah.
Yeah.
Okay, yeah, great answer. Let's go to the next question here. So, what would you say it's the best state management option to use with Remix?
So basically, you must, when you enter into Remix and understand the flow of Remix application, sometimes it can happen that you even won't think about extra state management because you will handle it due to loaders, session, and actions. And for instance, in a classic React application, I always use something. For instance, in mainly I use ZooStant or Tanstack query to handle some data and fetch data. And after that, when I firstly switched to Remix, what I was thinking, how to implement here Redux, ZooStant or something. But after some lines of code, I understood there is no need to implement that.
Yeah, definitely. I fully agree with you. And on a follow up to that, there's another question here that I think will interact with a bit of what we were talking about. So, considering that now everything goes to the loaders, what would you say that Remix needs caching to reduce the impact of long server side rendering on SEO ratings?
And this Remix need caching to reduce. I didn't think about that. So basically, even maybe you Alfonso, have opinion about that, because I don't want to just say anything. So basically.
So just very quickly answer. I'm not taking the spotlight from you on this part, but Remix leverages the browser, leverages the web, so you can use cache control headers to make sure that everything is done by the browser. So you just leverage the browser on this part to take care of the caching part. So that's pretty much how they recommend you to do it. So going back to you, what would you say on a follow up to that? Let me look in this question. Would you say that Remix is similar in any way to Solid.js?
I didn't use Solid.js. My colleague from work try pretty heavy to interest me with Solid.js, but I didn't have time for check it. But I heard that it can be a really nice competitor for React. So basically, after this presentation, I will deep dive into it. And you feel free to ask me, for instance, next week on LinkedIn what I'm thinking about that.
Yeah, definitely. So make sure that you go check Sebastian LinkedIn and connect with him, follow him, so you can learn a bit more about the experience in the next couple of months as he goes into Solid. So one question about Remix stacks. Would you say that elements within a stack can be interchanged with other tools? For instance, instead of having Tailwind, you could use Chakra UI, Material UI, or any other UI library?
It is designed to be modular application, so you can easily check technology which we want. For instance, in my commercial project where we built NFT market, we didn't use Tailwind CSS. But I regret that because I loved Tailwind. But first time when I met with Tailwind, it is really irritating for me. It was really irritating for me. But right now I really love Tailwind. We use Chakra, and you can use what you want, because basically you can generate new project with stacks and just change this library which you won't have to which you love.
Yeah. So and on a follow up to that, so would you say that, or are you aware if Remix has any adapters for Heroku for deploying to there?
But Heroku also use standard Node.js server, so basically I think it can be deployed.
Okay. And continuing on the stack, part, do you know if the Grunge stack will set up any AWS packages, Amplify, for example, that are needed for easier deployment for AWS?
I didn't use Grunge stack, but when I read the documentation, they wrote something like that just fills some config files and it will work. So probably maybe something is pre-configured. But the easiest way is just to run npx to generate Remix stack and see.
Yeah, exactly, and they are.
I think that probably it contains some configuration because, for instance, in Indie stack on Blue and BlueStack, we just had to change few things to deploy to Fly.io.
Okay, so it's pretty much well set up to make sure that you don't need to do a lot of hard work before the deployment. Okay. And on a follow-up question on that part, considering you're using this in your day-to-day, as it seems, do you think server-side rendering causes any major impact on server performance and on your network traffic?
Instead of sending only some data, for instance, in JSON format, you push whole site, whole page. So basically, it will increase size of sended data.
Okay. And did you notice if for you it caused any impact on your performance, or it seems to be working so far so good?
Performance obviously is better for the user experience because Lighthouse score is better, but about causing more bills on our costing, I don't think so. It is not a big amount.
Okay. Speaking here about something, if something uses Canvas heavily, would you say it's a good idea to move to SSR, or should you stick with just plain React? Or in this case, if you're using Canvas heavily, you should use Remix, or you should just stay with React.
I didn't use Canvas with Remix, so basically I don't know about that, but let me think. I don't know.
Okay, yeah. So just to add something here on this part, Canvas is if it is the HTML native Canvas, then it should work properly because Remix should support everything from the browser. So here I'm assuming it should work. I think I don't know if you agree, but I think it's a question of people to build a small demo and trying out to see how it fits for their day-to-day. What do you think on this? So on the follow-up, and I think it's the last question that we have here, can nested components interact and share state?
Can nested components interact and share? So basically, if you what do you mean about share state? This is something like context or something like that? If yes, obviously it will be set through whole tree because context will be on the higher level than this component. So you can interact and use it and share. Yeah, if you will interact with context or any other state manager, you have a setter function, so it will be move to higher component.
Okay, yeah, great answer. I don't think we have any more comments here or questions, so we can wrap it up. Once again, Sebastian, thank you so much for joining. Thank you so much for sharing your knowledge. It's a pleasure to be in your presence once again. And yeah, I loved your talk. So let's hope we get to meet and cross paths once again in the future. For everyone watching, you can add Sebastian, connect with him on LinkedIn. I think that's the link you shared here on the page. So, and any question that you might have for him, you can send him a message. So once again, thank you, Sebastian. Do you want to add any extra departing comments?
Thank you very much. It was really pleasure to share knowledge about Remix, about new technologies. What is most important? We need to remember that technology is changing almost every time. So don't fix about one technology. Interest with other technologies and obviously be updated, because it can help us. Not because a lot of people thinking that this is constant learning, but it can help us in various ways. For instance, in Remix, I don't need to set up extra backend application, make two deployments to projects. So that's all. Thank you very much. It was a pleasure to meet you, Daniel.
Likewise. Thank you, Sebastian. See you next time.
Bye.
Okay, everyone. What a great presentation that we had. We still have many other cool presentations to go throughout the day. Right now, I think we're gonna have a very short break. You can take this time to rest a bit, grab a coffee, catch some air for a bit before we come back with the next speaker, which is going to be Harsh. So yeah, see you all in a couple of minutes, and yeah, bye.
Hi there, this is Dmitry, and I have some awesome news to share with you. We're excited to announce our new event called AI in Software Development, happening on July 6th. You know how techs keep changing nowadays. Well, we believe that AI is the future of software development, and we want you to be part of it. And here's the best part. As a special thank you, we're offering a 20% discount on tickets. Just use promo code Geekle when you register. So don't miss out this great opportunity to learn and connect with like-minded professionals. Thank you for watching, and I can't wait to see you there.
Whoa, we're back. So, did you have a good break? No, I hope you did, because we're getting ready for a lot of more cool sessions. And yeah, I'm lucky to start introducing the next speaker. He's a CTO at Pedals Up. I can say he's a self-taught developer, he's a community builder, and has given more than 30 talks at several different topics. I can say I've watched him present live last year, so I can vouch for him because he's a very good speaker. So let me bring Arsh to the stage. Hi Harsh, how are you doing?
Hey, hi Daniel. I'm good. How are you?
Yeah, really great. Super happy to be seeing you again.
Yeah, same here, same here. It's nice to meet you again.
Yeah, exactly. So Ash will be speaking about simplifying data management in React with React Query, a topic that I really, really like as well. So I'll give the stage to you, and we'll chat a bit in the Q&A session. Thank you, Ash.
Thank you, Dan. Yeah. So hello everyone. So today I'm going to talk about like how you can simplify your data management in React with the using of React Query. So in here we are going to cover how React Query work and how you can do a better data management. So let's start. So this is a little bit about me. So my name is Harsh. I'm a CTO at a company called PaddleSub. I'm also a Polygon advocate. Uh, I'm a two-time G-Sucker. I still love to contribute on open source. And these are the other things which I do. Uh, quickly move to the React Query thing. Cool. So I think when we are building any React app for any client, or like have you tried to build any software in React or something? The major issue when you choose React is the two things is state management. So one is like global state management and the data fetching. These are the two major things when anyone can start React project. So when you're creating a global state management, the major issue people follow is how you can store the data, how you can globally handle the data, and when you are data fetching, how you can data fetching caching or mutation or that kind of thing. So we're gonna cover how these things can be solved using React Query. So yeah, so what is the React Query? So React Query is simple, helpful library which is help you to streamline your data management, help you to get your data fetching, caching in React apps. So when you use any kind of React Query, is more easy to handle fetching the like fetch or update, delete, or any kind of code operation when you are handling with the big data or handling API calls, and it's automatically handle a state of data fetching and the caching. So you don't need to add any other data caching library or any other caching like Radish or anything. So this can be a solve using simple this React Query. Also, this library comes with a lot of other really great wide range of hooks, which you can utilize and you can work with the React components. So let's talk about how basic React Query works. Okay, so when we work with like React Query as a developer, the first stage is loading or arrest is like when we are fetching any kind of data is ultimately how you can load the data, or if we give you any kind of error or something. Then the state is like prefetching. You can also prefetch the data and you can store into uh, temp variable or something. Also, like you can deduplication of requests. Right? Deduplication of requests is similar kind of like pre-flight API request. When you request any API twice, one for just for a check if API is working or not, and second is like you get the data. Also, the pagination and finite scroll, that is the one big use of React Query. Mutation is one of the things how you can mutate your data and how you can fetch a particular data from a big chunk of data. And return error, if like any kind of error coming from the API side, you can retry and you can fetch the data from like again calling the API. So this is the basic fundamental of React Query. Whenever you work with any kind of API, you know like this kind of basic stuff happen with the data. Okay, so let's understand what are the core concepts. So In React query, there is a four core concept, which is like one is like queries, which is we request the data and data come from the reward source or like an API endpoint, and we can manage the data using hooks called use query hooks. Okay. The again, the second is core concept is mutation. Mutation is like you can request to add a new data, or you can just modify the data on the top of the data which is provided by the API or a database. Uh, this can be more popular in the GraphQL database where you can add a new data or request a data, particular data. Mutation is one of the great tool hooks which help you to get new data very easily. The one thing which is great about React query is like caching. So caching is like basically a built-in feature in React query, and that store your cache data uh, in the sort of memory. So you don't need another library or another data storage, temporary data storage, or any Redis or any kind of library which store your data and handle your data temporary and give a seamless experience to your user. So, and the fourth one is like a query invalidation, which is like it is the process of making query invalid or slate, which is help to your query to more validative way. So let's move to the what are the main features in a React query. So you can fetch and catch the data. That's the one. Another thing is like use fetch data anywhere in the app, so you don't need any uh, global state or like global storage where you can store the data first and you can use anywhere. You can simply use this React query and you can fetch data anywhere into app using simply hooks. You can update your data in background, so you don't need to wait like your data is now like fetching from the API itself. You can update your data in background itself, and you can give your user to seamless experience life. Also, it's manage memory. So if you remove is automatically remove your data which is not used. So like if you're getting like 1000 data at a time, but you only need like 100 data, is automatically remove the other data, which help you to get query fast. Also give you the better response in the API, so you get a more fast response and you don't need to wait for a load of query or anything. Also, when you are using a pagination or lazy loading or infinite scrolling or that kind of thing in a, like if you're creating an e-commerce website or if you're creating a like NFT marketplace or something, this could be a great thing. It's help you to create a pagination or lazy loading very seamlessly. Also, these are the nodes, not the main feature. Like these are only not the feature which React Query provide. Also, React Query also allows some configurations, so such as like window focus refetching. So if you don't know what is window focus refetching is, like you are on a particular window and you want to refetch everything, you can rewatch you can refetch everything from the query itself. Also, you can put a delays in a query. Also, you can put a dependencies query. That's a also additional feature come with a React query. So let's start learning a basic feature of use query. This is one of the most common hooks which in the React query. So a React query so for using a React query, you need a React query client. For that, you need to use query client provider, and you need to wrap your app component. So I can quickly just show you how you can wrap your app component. So let me zoom it out. So this is I'm simply calling the query client provider from the React query itself. And this is my app.js. I'm simply wrapping my whole application using query client provider. And I'm simply calling my client query client. And this is how you can simply start wrapping your application here. Also, you can use other child component under the query client provider. So this is a good feature. Also, when you work with the use query hooks, there's the two basic requirements, which is optional, but there's the one thing is like unique key. and a function that return a promise. So you need to understand how promise works, because like most of the hooks which React Query provide is based on a promise. So this is the one common requirement. You understand promise and you understand how key and value works. Yeah. So this is how basic syntax look like when you work with a React query or like React query hook called use query. So you can simply create a variable called query. I'm calling the hooks. I'm calling the one function. I'm passing my key. I'm also passing my function, and I'm calling the promises like callback function. So in simple, like if I use query key is a unique key which is a latest stable version React query provide. You need to use array notation to specify the key. That is a must. So if you forgot to add this here, is like create issue. Also, the query function is callback function, basically the promises, and it is execute a query when you use a use query hooks, and when you call that, it's ultimately performance a specific task which you want. Like if you want to fetch like name or any particular point, like from the API, then you can certainly fetch all the data from the simply use query hooks. So this is the example, basic example, which is a code like. So simply I'm using use query from the React query. I'm simply importing the call. I simply write here the fetch. I want to just use fetch user. This is the common available open available API which I'm using, and I'm just passing this URL. I'm want a response. If something goes wrong, is give me the error. This is simple function I wrote here. So here what I'm doing is I create a const. I want a data of user, and I'm using use query, and I'm simply calling all the users from the API, which is this, and I fetch all the users. Uh, uh, also, so simply I'm using use query and fetch user, and you can simply map your users from like simply using a map function. So here what is like the first argument is user query, which is unique key to identify each query, and the second argument is basically you are fetching that function and this like solving promises and get all the data. If any error throws, is show you the simply error. So also I can show you the one example which we use in one project is basically we are calling. Okay, so this is the GraphQL query which we are calling, and here simply we are create a const. We are simply passing all the data which is we getting from the GraphQL query itself. We are using GraphQL like we use query. We are passing all the data which we want from this GraphQL query itself, and we just create a client, and we are passing all the data, and we get all the data here, and we are using data, and we are just mapping into our components. So you also use this query with API. Also, you can use this query with the GraphQL queries. So that is a major advantage which we feel and we are using in our all the client projects. So you can use multiple ways and use these hooks. So let's move to the another hooks, which is use mutation. So React query also allows you to perform like data update, and you can update your data on server, or you can update your data on database itself. You can change the data and all. So you can use mutation is a hooks which is help to create, update, and delete the data from the API endpoint or on server. So this is like amazing hooks which can help you to you don't need to go to a backend developer or any other guys who to if you want to update or your data or delete something from your data, you can simply use this hooks and you can simply call your API endpoint or server and you can update anything. Also, the use mutation hooks require at least a one option, which is I can show you like what are the options available. So the simple syntaxes look like we are creating mutation variable use mutation hooks, and we need to call muti basically function, and we are mutant function. So this is simple syntax. Use mutation basically it's a return object, and object contains several properties and methods which allow you to interact with mutation and you can handle the result of that. So let's quickly go to the examples. Okay, so what are our example look like? So basically I'm creating one add user function. I'm using use mutation hooks here and I'm passing the function. I just want to fetch users from this open API which I'm also using, and I just want to update that users. So I'm using the post method, and this is how you simply update your users using this mutation. Or you can also uh, update a user or update a database itself. So to mutate a function that you can call to execute any kind of mutation, and you can pass an object with like all the necessary variable or the argument, and you can update uh, data from the API itself. So we are moving to another hooks which is provided by uh, create query. So it's like query catching. So query catching is one of the like coolest feature which I personally love. Like when you are calling any kind of API or anything, you need to catch your data, or when you're working with a larger scale application, you need to catch your data and store your data when because it save your user time and it not show your user like something is wrong in backend side or something. So use query hooks to like when we use query hooks, it's ultimately fetch all the data from the remote itself, and when we use query catching, it's ultimately save this data on a catch side, and you can quickly retrieve in data while we are requesting other data at the time. So by default, use query will mark as this data as a catch data when you are using query catching with the use query hooks. And the other two options you can need to be aware of, and which is like stale time and catch time. The other two parameters or the other two catching options available in React query. So how it's work is basically when you so in stale time, you need to determine the time it take query result to be considered as stale, and so you can specify the time in milliseconds. So here the example like when I'm querying using use query hooks, I'm passing my key, I'm passing my function, and here I'm just passing the value of time which I want to consider as a stale time. Okay, so it's hold is remain stale, like it's about empty for the 5 seconds, and then after it's like give me the data. This means data will be safe or like will be stale after a 5 seconds. On top of them, you can also use a catch time, which specify how long you want to query the remain in the catch. So if I firstly I stale the data, and if I want to catch my data remain for like 60 seconds or like more than a 60 second or something or like 10 second, anytime I can give an specify here, and data will be catch here for like in this example is like 1 minute, so you can catch the data for at least for 1 minute. So this is like amazing example which help you to like steal your data, and also you can catch your data at the same time. So we are moving to like last section of like React query. So query invalidation, basically query invalidation is like query client object, which is provide the invalidation query method, and this method is ultimately used to mark all specific query as like stale. So you can also mark query as a stale using a unique key. So this query invalidation, which is overrides of any stale time, which we provide in our previous example. Like if you're providing any stale time either like 5 seconds, it you can override and you can configure which we configure in use query, so which we can also override. If the query is currently being re-render, like if we re-render all the time, use query or related hooks, it will be like running reflected in background. So this is one like example. So I'm importing use query client, and I'm just passing all the query client to use query client, and I'm using query client to invalidate all the cache or any steal time. I can also pass a particular key which I want to invalidate, or uh, like I don't want a steal time to like hold my data or anything. So invalidate query API is like you can use very flexibly, uh, and you can configure however you want to. Also, you can invalidate query that you don't want more variable or subkeys. Like if you have a very complex nested object structure or any kind of structure, you can also use this. Also, you can pass like exit true option, which is also true or false. Both options are available. So this method can help you. So this function ultimately this is how you can pass except true or false, and this function will ultimately receive each query instant from the query cache, and it's allow you to return like true or false methods and whichever you want to invalidate from the query itself. Uh, so yeah, this is like the last. So React query is like a robust library that allow you to like efficient management server state. It's basically use React hooks such as a use query to retrieve data, use mutation to modify your remote data or from the API and endpoint or the server. Additionally, React query features which we already talked like caching or invalidation, which can help you to in-memory caching or stay up to date with the remote data sources. Also, you can leverage React query. You can specify the reduce core complexity, enhance the performance and applications also. So I can quickly show you the example how we are using this query and how we are saving a lot of time. Uh, so we are using React query in this project is with the Apollo client in GraphQL. So if you can see here, we are using use mutation. So this is a simple query we are calling here. We want to retrieve all quest, and there's a function we just are calling here. And you can see just in like line of 196, we are calling this whole function, and we don't need to write any complex logic or any complex structure of code. So you can save a lot of time plus the very clean coding. Uh, Also, this help us to for our like React performance, app performance. And this is example of one of the Web3 app, so which is more complex. So we are um, go for this React query every time when we are building any kind of Web3 application, and that's how we are using this use mutation or other hooks like use query and other things. So these are some resources which I love. You can check this later. Like this is a practical React query blog or something. They have documentation. This is the codes and book which you can find all the examples. You can play with it and you can learn from it from the live example itself. So yeah, thank you. You can follow me on Twitter. I'm very active there, or you can mail me if you want if you have any query. So yeah, thank you so much.
Great presentation, Ash. Really, really good. Really liked to know a bit more about React Query, and I really liked the way that you showed the examples with use mutation, which is actually a very good follow up because someone ended up asking that. So yeah, really like the way how you showed working with it. So let me get back to the questions and see what more people are asking you. Just a
Yeah.
reminder, if anyone wants to ask more questions to Ash, make sure to ask it in the comments section and we'll show it here. So let's go to the next question here. Could you share the source code URL to examples? Could you paste it in the chat? Share it on your Twitter account? Anything that?
Yeah, I will share. I will share. I will share.
Okay, thank you for that. So you can check the link that Tosh will share with you.
Yeah.
So a follow-up question here: do you agree that React Query or Redux, in this case,
Toolkit.
Query, Redux Toolkit, replaces the need for a global state manager in 80% of the time?
So I totally agree. Like when we are using for our projects, we are not using Redux toolkit or any kind of Redux because in our current projects, if these are like, yeah, I'm not talking about small project. I'm talking about like a 1 million user or like more than like a million user project, which we are using completely React Query, and it's help us to reduce a global state management tool to like more than 80%. Like, and it's very easy to like pass the data across globally using simple contacts and simple hooks.
Okay, yeah, that's a very good perspective, and like it's super cool to get your experience on that. Another question that just showed up. So I think that these are actually two different questions. So the first one is, can you use React Query in Next.js? And if
Yes, you can
yes,
use it.
what would you say are the pros and cons in that scenario? And then I would say the second question is comparing React Query with use SWR. So probably let's start with the first one. What have you tried to use React Query with Next? What would you say are the pros and cons?
Yeah, you can use React Query in the Next. Like Next.js ultimately a React framework, so you can simply install React Query and you can use React Query in Next.js itself. Okay. If we go for a second question, like what are the pros and cons? It's come to data fetching. Uh, so it's okay. So if I go like when React Query introduced, ultimately they are solving three things: is like asynchronous data, server side data rendering, and global state management. So when you are fetching the data of comparison to use SWR, my opinion is like use query is a more bit of like upper side. Okay, it's give you a more clear data, and also use SWR. You are storing all the data in server side, which is not recommended all the time. Like if you're working with a big project or something, you don't like as a developer, I don't want to store my all the data in like server side. So use like React Query is more promising option.
Okay, yeah, that's a great answer. So let's look into the next question here. Okay, so let's see. So there's a question here. Let's see if we can interpret this together. After looking into your example, I can understand something like it is a promise kind of thing and not just a synchronous state management. So in simple words, what can we compare this with it? So I'm assuming that they are talking about the query functions and the mutation functions, which return promises.
Yeah.
What would you say we could compare it like? Is there anything very similar in the dev industry in React ecosystem?
Like I don't know like if something is similar to React Query currently in ecosystem, but I think you can create a custom hooks and try to use context API and create a global store, and but there is also a complex structure we already try for one project and we miserably fail. So currently I don't know like any uh, comparison between like React Query or anything.
Okay. Looking into our next question, can we have interceptors for React Query, for instance, as a refresh token?
Yes, yes, yes. Like you can use a refresh token, or you can pass a Barrett token or headers. You can pass all the context type or anything, everything you can pass. There's a similar approach when you are doing a fetch API calling or like you are using Axios. So,
Okay, yeah, exactly. Okay, then to the next question we have here. Have you tried to use mutation to mutate a flat file present in a remote desktop? It seems like a very specific use case.
uh, like I never, but like we can like give a shot. Like I never
Yeah.
do this, but like we
Mhm.
can give a shot. Like that would be a great example.
To build a demo. Yeah,
Yeah,
definitely.
yeah,
I assume here as long as there's an endpoint that you can call somewhere,
yeah,
it should definitely work.
yeah. If like endpoint is modifiable, like we can definitely give a shot.
Okay,
No,
so there's another. We still have two more questions right now. At
no
least
worries.
showing up. Does React Query work best with React Context, Redux, or any other type of state management approach? Since seems React Query is more about solving the server-side data management than the client state management side.
Yeah, so it's like more helping to server-side data management. Also, you can use React Query Redux. Which
Mhm,
using for Redux is like I never recommend because it's like more complex and you don't need a two state management thing in a single project.
mhm.
So you can use Redux. So you don't want to use React Query. If you are
Okay.
using React Query, don't use Redux. That is the best thing. Uh,
Mhm.
so, but you can use React contacts with the React Query. That would be a best combination.
Okay.
Yeah,
Like looking into the last question that is showing up for me right now. Should I create
yeah.
hooks and put the data fetching using React Query, or is it better to keep everything in the component?
Uh, so it's depend on the complexity, how your complex your app. If
Mhm.
your app is very small, you can create this kind of single page, like you can create hooks and fetching data, and you can call all the data in component. But
Mhm.
your app is more complex and it's require more components. It's better to everything in component, and you can call component one by one.
Mhm. Yeah, so it's a matter of organization versus the size
Organization,
of your
yeah,
application.
yes,
Okay.
agree, yeah.
Yeah, great answer. Let's see if we have anything else showing up. It doesn't seem so. So let me just double check. Okay, I don't think we have had any more questions in here. So once again, I like to thank you, Ash, for joining us,
Okay,
sharing a bit
Daniel.
more about React Query. I have to say, I recognize that T-shirt.
Yeah, it's similar of React India. We both are speaking.
So thank you for joining us. It was
Thank you so much.
great to
Thank
see
you
you
so much.
again. For
You.
everyone attending and watching, you can follow Ash on Twitter, following him on the links that he has on the Geekle page. So yeah, once again, Ash, thank you so much for joining
Thank
us.
you. Thank you so
See you
much.
again in the future.
See you. Bye.
Okay, so we're getting ready for our next speaker, and I can tell that he seems to be here. He posted on the YouTube chat that he's watching right now because the last time I've heard from him, he was boarding a plane. So it's a good thing to have him in the chat. So the next speaker, Elian. I'm sorry if I'm mispronouncing your name, Elian, but he's a software engineer at VBridge, and he's going to be presenting a very cool talk, which is called "An Intro into Island Architecture with Astro." Elian is a software engineer, like I said, at VBridge, and I think he recently just became a maintainer for Astro. So congratulations for that. And that's why I think he's one of the right persons and the best persons to talk about it. So without any further ado, I think we're getting ready to watch Elian's talk. I think we're not going to have a Q&A session with him, unfortunately, but you can send him a message on Twitter, on LinkedIn, and any links that he has, so he can give you his feedback about it. So without any further ado, let's go to his talk.
Hey everyone, thanks for tuning in to my talk for React Global Summit 2023. This talk is pre-recorded since I'll be in Copenhagen with the Astro team at the time this event takes place. We're actually hosting the very first ever Astro meetup in Denmark, so I couldn't really afford to miss that. Sorry for that, but if you feel like you have any questions, feel free to reach out to me afterwards with your questions. So I'm Elian, I'm a software engineer at Birch in Belgium, and I'm also an ambassador, and since a short while, I'm also a maintainer of Astro. And today I'm going to tell you about Astro. So if you want to follow me online or reach out to me, you can do that with @ElianCodes, which is my handle on most platforms. I'm most active on Twitter, but feel free to reach out wherever you find me. So now that you know who I am, let's dive deeper into the topics for this talk. We can start out by answering the simple question: what is Astro? Well, let me explain. Astro is not just a simply lightning fast framework. It's also not really a blazingly fast one. It's better than that. It's an astronomically fast one. Astro, in short, is an all-in-one framework built for speed. That might sound a little bit as an empty box right now, but I promise you that will get clear over the following slides when I go into it deeper. So my goal for today is to introduce you to the Astro Islands architecture. So let me start out by showing you a theoretical example. So take this page, for instance. We can divide all of these little HTML structures into blocks. See it as a Lego base plate with blocks added on and on and on. And I'm also totally not making that reference just because I'm at the Lego offices in Denmark at the time of this talk. So we're already kind of into this component design in our heads. Everyone knows it, everyone uses it. We use it in existing UI frameworks, for instance, being it Svelte, Vue, Solid, or React. We already know the component structure. But with Astro, we can actually do something like this. Now, this is theoretically possible, not the recommended way to use it, but that will become clear why afterwards. But with Astro, you can choose different colors or flavors for each brick, referring to the color as being a UI framework. So Astro is actually a framework that makes it able for you to bring your own UI framework onto this. We call this bring your own framework, like I showed you in the previous example. All of those integrations are clearly laid out and shown on Astro's website. We have a tab called the Integrations tab. You can scroll over there, you can filter out and see what each integration does. For instance, you signed up for an event that's mainly about React, so I will show you what the React integration with Astro looks like and how that works. But before we dive into React and Astro, we of course have to set up a new Astro project. So let me get into that. So let me pop in the terminal here and show you what our CLI looks like. So you can use any package manager you like, being it PNPM, Yarn, or NPM. I'll be using PNPM since I tend to use that the most. When it's downloading, you can see we have Houston here, our mascot. They will guide us through the process of setting up a new project inside of the terminal. We'll get some questions, for instance, what's the name of your project? Will you use a template? I'll choose the empty one since it's so easy to just take that as an example. Then when the template's copied, you'll get another question, which is, would you like to install your dependencies? I typically tend to do this, but if you, for instance, know instantly that you'll be adding on integrations, you don't have to do this. We'll never force stuff upon you. We also ask you if you like to use TypeScript. I plan on using TypeScript, so I will choose it. I will use the strict settings. Those are recommended as well. I will not use a Git repository. So this all will set up your project for you. Really easy, really beautiful CLI, really developer friendly. So let's open up this newly created project in VS Code. To get support for the Astro files, you'll of course have to add a separate extension, which is just the official Astro extension. Everything else should work right out of the box. Well, as you can see, which I've highlighted here, the Astro syntax feels quite familiar. Most of what you can see right now is actually just HTML or resemble HTML. Except for the code fences at the top, but we'll get into that a little bit later. Now, before we dive deeper into the code itself, Let's take a look at some file structure. How does that work? Well, in Astro, it's nothing too weird going on there. Your project configuration happens in the astro.config.js file, and all your components, pages, layouts go into their own folder inside of the source folder. So nothing too weird or different from any other meta framework there. Astro has file-based routing, so every file inside of the pages folder will create its own page and route. For instance, you can see the 404.astro file there. That's a special case because that will pop up every time you have a 404. But for instance, you can see we also have support for directories. For instance, you can see that we have a blog page there, which has an index and an ID. The index will just use /blog, whereas the /blog/ID will be a dynamic parameter. Okay, so now let's add the React integration because we want to see how React works with Astro. We're here at the React conference, so let's add React upon it. When you type Astro add React, it will show you just what files will be updated, what packages will be installed. So here we can see what will our config look like. It's very easy. It's very developer friendly. How beautiful is this? We just click continue and everything for us is set up. That's what I'd like to think of as the better CRA, Create React Astro, which is of course way better than Create React App. So that nifty tool that I used there, that's called the Astro Add CLI. I also want to highlight this amazing developer experience of Astro. We really tend to take care of that. It's really important to us that the developer experience is the best that you can ever have. So from CLI to error pages, Astro always bets on great developer experience. If you're, for instance, not sure which integration you like, you can just type Astro add and it will help you which ones you like to add. Okay, so here you can see the updated config file. So we've added React. We just import the React integration itself and add it onto our Astro configuration. Easy enough, right? Okay, so now that we loaded our integration, we can start actually building our component. So I guess the easiest is that we just start by creating a basic counter component. I know that we probably have all done this over a couple of times. Well, not to say a million of times, but I still want to show you how I build it just so everyone can tune in. It's just a basic function returning some HTML where we will display the counter, the value of the counter itself, which we put in a state. We'll also add two buttons, one to decrease the state and one to increase the state. Nothing too weird or different from anything that you've seen before. This is just plain React. So let me just add the dynamic state now. So see that here I'll be replacing React by an import at the top there. And the reason why I'm doing this is just to show you that we import the useState from React itself. We don't import it from the Astro integration. This is just plain React. And this is something that I want to stress because we're actually just importing from React packages. This also means that actually a majority of the React packages should work with Astro. For instance, React Fiber, I know a lot of people use it. You can just use that. Also, this actually means that your components that are already built in other projects, which are pure React or, for instance, Next.js, can just be copied and pasted over into Astro, and it will work if you install the correct dependencies. So that's a really cool thing. Okay, now so we built our counter component, but we still have to add it onto our index page. So let me head back to the index page, and now let's get into the code fences at the top. So there we can import components. That's where the server-side code goes in Astro, and then we just can use it like regular JSX. We use it on the page. Now, if we go to the browser and we type in our local host here, you'll see that the counter is there. But if we click on the buttons, it's not updating the state. This tends to be a problem. But actually, this is wanted behavior. Astro ships no JavaScript at all by default to your application. So let's take another look in the browser and open up the DevTools here. You see it's not working. So let us look into the dev console. Okay, here we can see if we refresh the page, we have no JavaScript being shipped at all. Really cool feature, but what if we need interactivity? What if we want to be updating components dynamically, or what if we want to render things conditionally? Then you need interactivity. Well, that's where a concept we call partial hydration comes in. Partial hydration I will get into because you probably don't know what it is. Well, this is actually the perfect analogy to understand it. So let's take this plant as an example. If we don't water or hydrate our plant enough, the plant will feel very sad, simple, or boring. That's the same with our web applications. We'll be drowned or parched in either technical depth, bundle size, general complexity. So let's take that to our application. Okay. Imagine we have this page in a normal JavaScript meta framework application. Think Next or Next. All of these different components here will require JavaScript to render, even though some of them might not even need interactivity. For instance, the footer, which is just basic static links and some info. We don't really need JavaScript, so why are we shipping it? In a perfect world, we actually want something more like this, where we just select our components we want to be interactive and ship JavaScript only through those components. So can we achieve this in Astro? Well, yes, this is what island architecture is all about, and this is where partial hydration comes in. In Astro, we have something called the client directive. And using this client directive, we can choose which components should use JavaScript. But we also have the flexibility to choose when or how the component should become interactive. And that's really interesting. So let's take a look at what options exist for hydration. Client idle, for instance, that will start hydrating your component as soon as the main browser thread becomes free. That's really cool. It's really useful. We also have just client load, which is the basic thing. So I will show this to you first. This will just start hydrating your component as soon as the initial DOM content is loaded. So let me bring that to our example here. So in the counter, let's add the client directive, which is client load here. We see we also have amazing developer experience inside of VS Code as well. Now, I am doing PNPM build and preview here, since I don't want you to see, for instance, the JavaScript that Vite ships by default on the dev server. So I actually want to show you the results. And then we can see we have the counter itself, the index, and a client JavaScript file. And now it totally works. So this is really cool. Our counter is fully functional. Sorry for that. But also, of course, we need to ship some React core JavaScript itself. So that's what that client is like. The cool thing is that even though you have 100 components, that will only ship once, because your client.js file, the core of Astro, the core of React will be the same over all your components. So really interesting. We also have client media, for instance. Client media is very interesting because that will start hydrating your components when the given media requirements are met. That's ideal and really cool for only mobile components, for instance. Think of mobile menu buttons or things you only want to show up on mobile devices. We also have client visible, which is the most powerful one by far, in my opinion. It's client visible, which will only start importing the JavaScript as soon as the component enters the viewport. This, of course, uses the intersection observer. So let's trade in our example here, the client load by client visible, to see what it does. To get a good look at it, of course, we have to add a couple of lines of code here. well, not code, just some lorem is good enough. Let me copy and paste it over a couple of times to just be sure we have to scroll down on the page. Okay, great, there we go. If we now open up our terminal again and start our process of building and previewing again, you can see it's very fast, so no worries there. If we go back to our browser and we start scrolling down, the moment the counter is loaded, you can see the JavaScript is being shipped. And still fully functional, of course. Let's test it out to be sure. Still works. Really cool here. Okay, so let's take another look at our theoretical web application example from earlier. So now that we have a better understanding of client directives, we can perhaps make this astronomically optimized and performant. So let's try and add correct ones. Let's start with the header. The header is always at the top of a page, will probably require some interactivity like buttons, theme switchers or such. So it only makes sense for us to ship JavaScript to that component first. What client directive do you think we should use? If this was live, I probably would ask you to put it in chat, but since it's pre-recorded, I hope you got it, but I think everyone will get it. It's exactly client load, simply because it's done as soon as the DOM content is loaded. And it's an important piece of the overall user experience, especially with the dark mode, for instance, that we added here. What about this sidebar on the left? It's only logical to try and defer this as much as possible. So this is where we should use client idle. Okay, that's really cool. For instance, I also added the image carousel here. Image carousels typically are very hefty to load since they have a lot of images, which might be optimized, but not always are. And it might be below the fold of a page. So it makes sense to use client visible. But actually, if I'm being really frank here, most of the cases you will be fine just using client visible, because Astro will take care of the rest for you. Yeah, okay, that's sad. This means that actually you would no longer be seeing this in your Lighthouse scores. Since it won't be shipping JavaScript, it will be very fast, it will be very good in SEO and accessibility. You'll be getting the full score. That's the secret sauce to what makes Astro so awesome for SEO, for instance, the composability. So all of these components are pure HTML and rendered at build time, so the content is fully indexable. I'll be coming back to that a little bit later as well. So yeah, this is what an Astro site gives you when you ship it into production. And we can actually see that if we take a look at our hyperdrive, which is a speedometer application we've built and that keeps track of all the Lighthouse scores of Astro websites. Most of them are all in the hundreds. Okay, so let's take a look at what obtaining data from a remote endpoint looks like. Because it's typically that you don't actually author all content on your website, it's likely that you need an endpoint as well. So let me just get a Jokes API. Jokes API is typically used as an example. Notice that I here am able to use a top-level await, which is really cool, and that the syntax just resembles plain JavaScript and JSX. If we then hop over into our in our browser, you can see it's rendered out. One of the cool things is this won't ship JavaScript at all because it's still not hydrated, and it will just fetch the API endpoint once at build time. So it won't refetch it every time you refetch the page. Of course, this has some counterfeits. For instance, if you want to refetch a joke every time you're on that page, this won't be the use case for that. Then you'll have to hydrate the component because the fetch has to be shipped with your component as well. So let's take, of course, also a look at authoring content inside of Astro. We have a great Markdown story. You can add some text in Markdown. You can use full pages in Markdown. You can also here use MDX. So let's import our component. And if we then inspect it, you can still see there is no JavaScript being shipped at all. Of course, that will mean that our counter is not interactive, but we can also add client directives into our Markdown components or Markdown pages. That's so cool to me. So now the counter is just a React component loaded into a Markdown page. How cool is that? And still rendered all out as HTML and JavaScript. So that's really, really cool. Of course, what I've shown you might be a little abstract. I know that. But of course, this opens up a lot of possibilities. For instance, you can fetch your data from a headless CMS as well. We also try to document as many integrations with content management systems as we can to keep the developer experience on top. But we also are, for instance, actually working with the front matter team right now on adding a new guide for that this week. So we still keep up with all CMSs and all systems that are popular. Of course, that's not all that Astro has to offer. Astro has an easy integration with style processors, for instance. It's as easy as an npm install Sass, for instance, or Stylus, and that should work since Astro has support for post-CSS. Astro also supports Deno as a deployment runtime. That's so cool. You can deploy to the edge with Deno, so really cool stuff. There is also a first-class prefetch package available from Astro. So if you want to prefetch your pages, you can just install it and use it. It works very well. There is first-class support for images and optimizations in Astro. We're actually changing that up to become part of the core, so it won't have to be a separate package for long anymore. But this works great. It optimizes and loads your images into very small assets that are optimized for the web, so you don't lose any performance there. We have Tailwind CSS support, of course. Tailwind is something that we all regularly use, and it works great inside of Astro. If you want to offload your JavaScript of the main thread by far, there's also support for Partytown, which works awesome as well. So if you do need to ship a lot of JavaScript, you can look into Partytown to make it a little bit lighter on your browser. Also, Cloudflare Web Workers, for instance, could work for that. Also, from AWS to Vercel and everyone in between, Astro has a lot of deployment adapters and deployment guides, so you can check on the docs if your preferred deployment is there, and we have probably a guide for it, so that's really cool. Also, if you like to use JavaScript but don't want to ship it every time, we also have support for SSR. So if you prefer to run your own container, for instance, there is also adapters for that. Now, also since Astro version 2, I think, there is a possibility to use a hybrid rendering, for instance, using or building your own API endpoints inside of your Astro project. I use it all the time to generate OG images, so it's really cool and powerful tool. And lastly, of course, the new content collection API. It's an amazing way to work with Markdown and MDX without any hassle. It works great, has support for a lot of things. You should check that out. Okay, so now that you've seen some of Astro's features and architecture advantages, why would you use Astro? Why would you prefer Astro over other meta frameworks, for instance, Next, Nuxt, or Solid Start? All of the previous examples that I've shown make Astro the ultimate framework at this time for being the greatest in SEO optimizations and developer experience. And since most or even all of your HTML will exactly be rendered at build time, the crawlers indexing your website will be very pleased and will give it a high score. So that works really great as well. That's also what we see if we check our Astro Showcase website, where real websites that use Astro are on display. We mostly tend to see personal websites, blogs, portfolios, or marketing websites. So typically things that are really content-driven. That's what we're going for at this moment, content-driven websites. So if you're interested in taking Astro for a spin, You can get started quickly by heading to astro.new. You can get a new project set up like in less than a minute there, all in the browser. So that's great. If you don't have a hefty machine or don't want to use it on your own machine, you can just open it in a StackBits and it works great. So the Astro documentation is amazing. We try to make it as accessible and as good for everyone. So as complete as possible as well. So it will be a great start for you if you want to look into Astro as well. If you don't feel like you're strong enough to just start out reading the docs, there is a full interactive tutorial on building a blog. So you feel like if you need a little bit more of a guidance, that will work great for you as well. I've also put some links up here to get you started. You can check the tutorial and other stuff over here on these links. There's also a link to the Astro Discord. It's a very welcoming place. More than enough people willing to help you out or support you on your Astro journey. So ask us your questions there and don't hesitate. I'd love to see you in there. So come join our server and let's be friends. Thank you for having me and giving me your time. I hope you found it interesting. And if you see me online, say hi. Or if you're in Denmark at the Lega offices for Astro meetup, come and say hi to me. Cool. Okay. Thank you all very much. And I hope to see you once again in the future. Bye. Hey, everyone.
Yeah, well, again, what a great presentation. I was chatting on Twitter and I was pretty much saying that I really like listening to Elian every time. Like, he actually convinced me to try Astro. I think we met at the last Geekle event last year, so it was a very fun experience checking out the process from him starting as a speaker and now going to a maintainer of Astro is a super cool thing. So once again, thank you so much, Elian, for sharing your knowledge, for teaching us all about how Astro works. Everyone here, you can check him out on Twitter, on LinkedIn, give him a follow, ask him questions, anything that you would like, he is there to help you. So yeah, without any further ado, we can go on and listen to our next presentation. So our next speaker is a senior developer experience engineer at Cloudinary. He's an Astro coder. He's the Space Jelly Commander, and he really likes to help others get the tech out of the way to solve their real problems. So Colby Fayock will present a topic called Performance. Everyone wins when you optimize the media. Just a reminder as well that this talk won't have Q&A, but I'm pretty sure you can, once again, like all other speakers, you can reach Colby in Twitter or on LinkedIn if he has a LinkedIn page. I don't know if it's on the agenda. I recommend you to double check that. But yeah, without any further ado, let's go to our next session.
Super important part of any web or mobile application. And it's not just something we want to check off a box for. It helps everybody, from somebody just trying to browse your app to how much we're actually paying to allow them to do so. So let's see what we can do from a media perspective. I'm Colby Fayock. I'm the one hugging BB-8 and Kylo Ren over there. I help others get the tech out of the way to solve real problems with the tools of the web. I work with the dev community building educational content and as a developer experience engineer over at Cloudinary. You can find me pretty much anywhere on the web by just Googling my name, as I'm the only one in the world. So starting off, we're going to take a look at a few examples of media in everyday websites, where we can kick it off with Amazon, king of e-commerce, where they use images to showcase the available products and categories on their site. Here we have Start Cadet, where I'm a big fan of their Final Space merch. They take advantage of GIFs to display video-like category and product images. It's a little bit more of a creative approach, taking a typically very static medium and making it exciting. Or NASA, exploring places that are out of this world, where we get high-resolution images from space, which is just absolutely mind-blowing. Or something fun like Giphy, where we can share our reactions with an animated image, who can't express themselves with Michael Scott. Now, as you might imagine, given this talk, we're going to focus on the media part of these sites. or images and videos. And let's not forget our audio friend that gets left out of there quite often. While it's awesome to be able to enjoy large images and GIFs on sites, it comes at a cost, which we'll talk about soon here. So what we can do to help reduce that cost. But you might be thinking, where does media fit into my application? Everywhere, of course. It's part of the web, whether it's a simple profile avatar, an embedded video, or an interactive experience. You're likely using media in some kind of way, but we're talking about web apps. So let's see how that fits in there. Starting off with your app, we have some crucial components, like the page itself, which is ultimately HTML that's rendered in the browser, that might or might not be built with a framework, like React. But then we need some dynamic data. And while we could do SSR, we have server components, of course, coming around. I like to deploy pages statically to reduce overhead and improve performance. So we can make any API requests in the browser that actually needs to be highly dynamic and that needs to hydrate with anything personalized for our visitors. Or better yet, we can even do that in an edge function. And then we have our media, which plays an important role in providing the visual context, helping people to better understand what you're talking about or what you're trying to sell, but also a way to be creative, creating engaging experiences rather than just a bunch of text on a page. But okay, that's pretty basic. I've seen images and videos on a website before. Why should I care? This is where we come back to the cost we talked about earlier. Let's take e-commerce, for example, one of my favorite types of sites to work with. Conversion rate is the percentage of your traffic that's actually going to buy something. There's a ton of studies how website speed directly correlates to conversion rate. eBay, for instance, found a 0.5% increase in their conversion rate with a 100 millisecond load time improvement. And Portland actually found the same correlation with their data. A site that loads 1 second has a conversion rate 3 times higher than a site that loads in 5 seconds. A site that loads in 1 second has a conversion rate 5 times higher than a site that loads in 10 seconds. That means that while all of our video and imagery might be good for helping build a user experience, that media is going to take up a vast majority of the size of that page. So if we don't pay attention to how we're actually delivering it, we're going to bloat our pages and destroy our conversion rates. So what can we actually do to help optimize the delivery? Well, let's start off by looking at some examples of images. To start off, while JPEG is a great option, it's a bit dated, there are some modern formats that can help deliver high-quality images at reduced sizes. WebP and AVIF are 2 great options, and depending on the image, can bring some very drastic reductions in size. We can also compress our images to the point where we're not actually impacting the visual quality. Maybe it won't matter for these tiny little thumbnails that you see on my screen here, but we want to make sure that we display our images huge or as big and clear as we can. So we want to let tech automatically decide how much to actually optimize our image without sacrificing that quality. That way we can optimize as much as we can without that visual difference. We're not over optimizing, but we're also not wasting precious kilobytes in download size. If you're working with high quality imagery, your source files might be huge. If you serve them as is, the browser is going to just resize those down anyway, so you're just wasting bandwidth. Resize to the sizes that you need, and don't try to just crunch the images just to get a smaller file size. You'll end up with a super blurry or pixelated image. Modern image delivery can help you get the exact sizes you need on the fly, so take advantage of that. Bring this all together, we have some pretty amazing results. Using modern formats, letting tech automatically optimize our images, and serving the images in sizes that actually make sense for our web or mobile applications, we were able to slash this particular example down from 4.3 megabytes to 51.2 kilobytes, all without sacrificing the quality. So hopefully I've convinced you by now that this is actually pretty important stuff. But how can we work with media inside of our applications and build them for performance? How can we improve our developer experience and ultimately deliver better experiences to our visitors? This shouldn't be new to anybody, but regardless of which framework you use, except for Next.js who yells at you in the linter, you can actually use an HTML image tag. Importantly, including a width, a height, and an alt, in addition to that location of the image in the source. Not too different is the basic video tag, which has a lot of more options that we can actually get into, but ultimately you need your source and a width and a height. The more interesting thing is sourcing the images and videos. This could come from a variety of sources. It could be a headless CMS or just a database. Maybe all your data is pulled all together into a single data layer, but ultimately the image and video tags that you're using dynamically get their sources from the data. where now maybe those images and videos are wrapped in a component. This is JSX, which you're probably familiar with given it's React. We're passing that data right into our image and video tags, but when that happens, what's actually connecting the dots? This is where we start to think about a framework or library, where we have a ton of options to use, and it doesn't have to be a fancy one. We don't need to ship a huge bundle of JavaScript, especially if we're just dumping static content. Now, of course, given our context, we're talking about React, so it's a little bit slimmed down here, but we still have a lot of options. But we start to be able to think about a higher level data flow, where we have the location we're storing the media references. We have the framework that's doing the hard work of pulling that data into the actual application. Then ultimately using that HTML we know and love to take that data and put it on a page. Now, this is a pretty linear solution, but it's only one solution. We could alternatively build our site by using local files from our project. We don't necessarily need a database to do that. And then once we deploy to Netlify, we can install the Cloudinary plugin, which automatically uploads all those images on build. Or we can even orchestrate whatever external data that we have, whether it's Cloudinary in a database or 5 other services, and pulling it all together into a single data layer and having a singular connector into the framework of our choice. The point is we have a lot of options for how we pull this all together depending on your needs. But this is all making a pretty big assumption that somebody somewhere in these solutions thought about actually optimizing our images and videos. But as we all know, it's not safe to make those kind of assumptions. So peeling back the layers of our stack where we can actually start to think about our optimization needs. Starting off, we can do this manually. As much time as it probably will take doing these every single one, we can work through that folder of 100 images and be pretty happy with the results. But you know where this is going. This doesn't scale, and beyond all that work that needs to be done, we're back to assuming that everybody who adds an image to our project is going to actually do that. Maybe they're assuming that you're going to do it. Either way, it doesn't fare well. A better solution is to start to automate this, where there's a lot of great CLIs and libraries out there to help out with this. Some of them can run on that same directory of images on your computer. Some you can pull in and script and then run on your build and deployment servers. This works fairly well. You're able to work through all the images, store them somewhere, and then reference that optimized version wherever that may be. You can even get smart with this, generate a few sizes. You don't want to go overboard with that, but at least you have to be able to serve the same high-res image everywhere. But again, this doesn't scale. Oh, your thumbnail size changed? Now you have to regenerate all those sizes again. What if you have two use cases where that original one is probably too big or maybe it's too small? Well, you can generate a new size inside that mix. Sacrifice the quality with that small image, or sacrifice the bandwidth with that big image. None of them are really great options, but you make do. Or do you? I see you sitting over there serving your blurry small images to your visitors, and I see you over there in the back. Look behind you. I can see you serving those images that are way too big. But guess what? We can do better, and we should do better. Let's again start off with our list of images. These are our source images. These are never going to change. Somebody can certainly upload more, maybe even delete them, but we're not going to modify them. Instead of manually creating versions, whether that's simply by some kind of GUI or running a script, manual as in still managing creating those different variations. Let's just throw on a little parameter in our URL there, QAuto, or automatically figure out the best way to compress this thing. We're not going to touch that source file, but now we're saying let's serve an optimized version of that file. And instead of creating those different sizes that we may not know what they'll be actually from a week from now, let's just again add a little parameter, setting the W or width to 800 and H or height to 600. We're getting the exact size that we need, again, not touching the source file, but serving an optimized resized version of it. Technically, we don't even need the height. It will automatically scale to the original aspect ratio. We can even, of course, crop that to a different size, but keeping it simple is always a good bet. And we saw from earlier that by using a modern format, that on top of optimizing our images and on top of resizing it to a responsible size, we can drastically cut down the size of our image. This is something that's especially tricky to deal with at scale. So let's just tack on another parameter there. Here's fauto, or format of auto, where we're going to see what the most efficient format is for that asset. On top of that, we're going to automatically detect what formats that your visitor can actually support. Not all browsers support every single modern format, and we want our images to work on all browsers. So this is important to make sure that we're doing what we can where we can. We're checking all the boxes. We're delivering in modern formats, we're compressing as much as we can without distorting our image, and we're serving them all in responsible sizes. The nice thing about this is with all these controls right in the URL, we can swap these out, particularly the width or other transformations, on the fly, because the URL is the headless API, so the developer or the implementer can actually control these sizes and use exactly what's needed for the app. And for the record, all of this works with video as well, or animated images, which can potentially have huge savings, given they're naturally going to be bigger files. So how does all this work? Expanding on our example, surprise, I'm using Cloudinary to achieve this. But when we serve this image on the page, it may or may not actually exist. So first, Cloudinary checks if that image exists. If it does exist, Cloudinary just retrieves it from cache. We don't have to wait for any processing. It gets served super fast from the CDN. But if it doesn't exist, Cloudinary processes it to generate that asset. It uses those parameters that we talked about as instructions for how to build that. But once it completes it, it stores it in cache for later use and delivers it similarly from the Cloudinary CDN, meaning this only happens on the first time. So all your assets will be served nice and fast once they're generated. Now, practically, we wouldn't expect you to manually construct that URL. Even though I know some of you cool cats are there doing just that. Yeah, I'm looking at you. But we can use SDKs and integrations to make this much easier. For instance, we recently launched Next Cloudinary as an easy way to work with Cloudinary in a Next.js project. To start, instead of an HTML image element or the built-in Next image component, we'll use the CLD image component. We can pass in the width, the height, and the alt. And now our source is going to be a Cloudinary image public ID, which will give us an image URL that looks like this. We're breaking this down to see the width and the source, where the alt gets used in the resulting image tag itself, so we wouldn't actually see that in the URL. But if you're wondering what's up with the height, Cloudinary will actually preserve the aspect ratio by default, so we don't need to pass that into the URL. But we still need to make it prevent layout shift, which is very super important. Layout shift is when something like an image or a video is loading, but the browser doesn't know the size of it before it's actually loaded. If you don't add the height, it doesn't know how much space to actually save in the browser viewport. So before your images load, you might see some content that gets shifted down as soon as your images load. You've likely seen this happen before due to ads, which is pretty annoying. So we can avoid this by adding our height. Next, we can start to add some more interesting features. Say I have a bunch of images with different widths and heights, like this space jellyfish here that's 800 by 600 size. What if I want them to all be square? That's yet another crop I have to manually add or script. Or I can just dynamically crop it. By setting my dimensions in a square, setting my crop to fill, meaning it will take up all the space within that square, similar to CSS background size of color if you're familiar, and a gravity of center, meaning it'll just anchor it to the center of the image, I can now easily get a crop of my image. And to that scalability factor, likely you're looping through all of your data to show these images. So this just works with all of your images. And this works similarly if I want a small image, such as if I were showing thumbnails of the image. This doesn't just resize in the browser, this delivers a smaller image. This extends into responsive sizing as well, which using the Next Image API will automatically generate responsive sizing based off of your configuration. And honestly, there's a lot of other cool things that we can talk about here. But how about I just show you? We're going to check out some real benefits of real-world image optimization. We'll serve this image up exported straight from Unsplash in a new Next.js application. As you can imagine, it's not going to be the most optimized image in the world, but we'll see how we can optimize it, crop and resize it, and even go a little bit further and have some fun with it. All right, so we're going to start off inside of our application where I have this picture of a pretty cute dog that I found over on Splash. I just grabbed the link from this download free. I copy that right here. I paste it in the application, and this is what it's giving me. Where if we start to hover over, we can see that I'm really only rendering a size of 335 for the width, where the intrinsic size or the actual size of the image itself is 2,688. Now, on top of that, if we look at that file size, that's 1.6 megabytes. That's absolutely huge. There's no reasonable way that we want to be able to load an image at 1.6 megabytes inside of our application. That's going to be an expensive cost to our visitors, especially considering if we have a bunch of images, right? So I think our first step here will be, how can we actually optimize this image in a way that's not going to put that toll on our visitors? So I already took the time to go ahead and upload this image over to my Cloudinary account. I created a new one for React Summit 23 here, where I have my dog and I have a beach that we'll later get to later, spoilers. But if I head to my application and actually go inside of my project, we can see this is my home project. Literally all I'm doing right now is rendering out this image tag. We can see my unsplash link here, where you can see the size and the alt. And aside from that, what I've already done is prepared the installation for Nextcloudinary. Now, what does that involve? Well, the first step is just simply installing the package. So we have Nextcloudinary here. That's all we have to do. The second step is setting up an environment variable where we specify our cloud name for our Cloudinary account, because we have to know where we want to point those images to, right? So we have our package, we have our cloud name, and now all we need to do is at the top of our file, import CLD image from Nextcloudinary. And what will that give us? Well, it'll give us that image component where all we have to do is replace that image tag. We already have our width, our height, and our alt, and of course our source. So that's really all we need to do, except of course we need to specify our public ID. Now, technically, I can set the delivery type to fetch and actually grab remote images through the component, which is a pretty cool feature in itself, but we're going to just go ahead and use the image directly from Cloudinary. So I'm going to specify my dog, which is the same as the alt. I'm going to hit roll. I need to actually replace that image tag because I backspaced there. I'm going to save that, head back over to my browser, and we can see that we're still looking at that same dog. Does anything look different to you? Well, if you're paying a close enough attention, we can look inside of the HTML where things do look different. So the first thing we start to read through here, first of all, we're lazy loading by default. The cool thing about the component is we're wrapping the Next.js image component, which has a lot of awesome features built right in. Lazy loading with the browser defaults is a really great safe bet for being able to get a better way of not having to load a bunch of resources that you might never need. So first of all, we're lazy loading. But second of all, if we start to look at the source set, we're actually getting responsive images in here too. Now, these aren't fully defined. We can do a better job at that, which we won't get into for this demo. But if we decide to, we can define a sizes attribute with the sizes we want, and it'll automatically give us that source set. Now, the interesting thing is if we start to look at that size again, look at the actual attributes here. I can't get that to follow me. So what I'm going to do is go to the network tab. And if I hard refresh this again, look at that size, 15.3 kilobytes. We're no longer loading that over 1 megabyte file, 15.3 kilobytes. That's a drastic reduction in size. If you're looking closer here, we can see that we are serving it from Cloudinary, but we're now serving it as an AVIF. Now, as I talked about earlier in the talk, that's going to be one of those modern formats that's going to give us a lot better results for being able to deliver modern formats in a more optimized way. And on top of that, because we're using Cloudinary, we're also using that quality of auto. And we can see just that if we open up the URL in our browser, where again, the URL is the API. So we have our image that we're referencing. We have the size that Next.js is automatically applying based off of those parameters that we're providing in. But then we have that fauto for the format and the QAuto. And that's all we had to do. We literally didn't do anything else inside of our code except swap that tag. We automatically got all those benefits. But as I mentioned, there's a lot of other fun stuff that we can do, right? If I open up the documentation and kind of look through, some of the things that I think are fun, if we look through the examples, are all the different features. Like we can remove backgrounds. We can even make GIFs on the fly. We can do a lot of the Cloudinary transformations that you would typically expect if you're familiar, but there's a lot of different things, dynamic cropping and resizing, that we can take advantage of in order to have a better experience with our actual images inside of a Next.js application. So let's get started with that. Well, first of all, let's actually crop this so that it's not this weirdly so it's a square, so it's not an awkward shaping here. So what I'm going to do is I'm going to say, how about I want it to be a square, and I'm going to say that I want to crop it with fill, and I want to set a gravity of auto. Now, technically, we don't need to set this gravity of auto. It already is set by default, but just to illustrate what's actually happening here, gravity of auto means it's automatically going to determine what's in the picture and center that crop to that location. So if I save this now and refresh the page, or it did it for me, we can see that even though the dog was at the bottom of the picture, it still only cropped the top because the gravity mode with the crop on top of that was able to place it in the correct spot. And we see that our size actually went down a little bit. So we're even saving some bandwidth there by not having to serve that rest of that image that we're not doing anything with. So that's goal number one. Now, another thing that looked super interesting in the examples, I think, is the background removal. So I'm going to head over here and add remove background. Simple as that. And we're going to see that what's actually going to happen in the background is Cloudinary is going to return a 423 response, meaning it's processing. Now, this takes a little bit of time to actually remove a background. So the very first time, again, the very first time that the image is actually loaded, it's going to give us this processing response. But as soon as it's done, we can see that it popped up, it reloaded because it's happening, it's polling in the background. It reloaded with our new image with the background removed. It was that simple just by adding that prop. Now, let's take this another step further. As I mentioned, we uploaded a picture of a beach. That was my huge spoiler. So what can we do with that? Well, let's put it in the background. So I'm going to define an underlay prop, and I'm going to say beach. And what's going to happen is after that loads, we can now see that our pug, or is it a pug? We can now see that our dog is actually on the beach, maxing and relaxing. It was just that simple for being able to add those few props in order to get these pretty dynamic results. Now, let's take it yet another step further. How about we add some text on here? Now, for this, I usually just go to the documentation because I don't have all these different properties memorized, but we can see we can add this text. So I'm going to copy this example where what we're doing is we're going to use overlays, and overlays can be both images and text. Now, in particular, in this case, we're going to create a text overlay. Now, I don't want it to be blue violet. I just want it to be white. I don't need an underline. I don't need different letter spacing, but let's say thug life for our little doggy here. And let's just see what happens if we do this alone, or maybe southeast. Yeah. Okay. Let's just let that as is and see where it ends up. Where now it's probably a little bit out of place for where we want it to be, but we can see that we just easily added the text. Now let's fix this a little bit. So if it's in the southeast, maybe we only want this to be, say, 40 for each of those. And let's see what we get. How about if we lower the font size to 60, since this is probably a bigger image that it was originally working off of. Maybe 100. And we can see how quickly we're making these changes without doing much more than setting these configuration parameters inside of our overlays. But now we can see we have our pug, or our dog. I keep calling it a pug. I don't even know if it is a bug. But we have our thug life doggy here. Now, let's do one more fun thing. As we might have suspected, given thug life, I uploaded these deal with it classes. So what can we do to actually add those as well? So what I'm going to do is, because this is an array, I'm just going to add another overlay here where let's just duplicate this object. I'm going to get rid of the text because we don't need that. But what we're going to do is we're going to pass in a public ID of deal with it, because that's what I called it. And the width, what's the width of this image in here? We can see it's 363 by 74. So 363, oops. 363, height of 74. I'm going to get rid of the crop mode. I'm going to just reset the position here. But what I'm going to do is I'm going to set the gravity of faces. Now, we're working with a dog, so I'm not sure how reliable this is actually going to be. But what this is going to do, especially if it's humans, it's going to look for the face using AI for detection and then place that overlay on top of that face. Now, let me get rid of it, or I'll keep the angle because it'll be a little cocked, right? So let's see what actually happens here. we're giving it, it doesn't look like it worked too well, or maybe it's just because the height and the positioning is out of place. But anyways, what we can do now is just simply position it to where we want it to be. I mean, it is a dog after all. This is it's a cute face, but it's not necessarily a human face. So let's just reposition this. So we got -40. Let's try -40 on that again. In the background, it's loading. You got to do a little bit more here. How about 120? Get it really nice and up there. I'm going to make it a little bit smaller. So what's 363 by 2? And then by 2. Let's see what this gives us. And that's looking a lot better. So let me get this a little bit further up on top of our dog's face. I think I need I think the X was probably good. It's really just the Y that needs to get up. I think the X could probably be reduced a little bit. So let's try that. And I think that's good enough for our demo purposes. We now have our dog with the deal with the glasses, thug life on the beach. And I think, all we had to do was work through those initial set of the parameters. We just had the simple things we have with the image tag. We saw the optimization, but then we saw how we could easily crop that to a square. We even set the gravity of auto so that it cropped it to the dog. We have the background removal. We set in that underlay of the beach for the background image. And then we added both the glasses on top, and we added the text to complete that out and give us our dynamic image. And it was all that simple. We can even see all the requests in the browser, and we're still only at 34.1 kilobytes in size compared to that 1.6 was it megabytes that we had before. It's crazy. But as you can see, there's a lot of options that you can do and a lot of fun that you can have with this. All right. So this likely isn't the same exact image you saw, but this is originally the idea that I was going for when I was creating this slide deck. The cool thing is we saw the real world impact of actually loading unoptimized images, and we saw how we can easily optimize it with Cloudinary and even take it to a thugged out level with some cool transformations. If you want to learn more about how you can work with Next Cloudinary, check out the docs at cld.media/nextjs, or it's also available on my GitHub if you look around there. If you head over to spacejelly.dev or youtube.com/Colby Fayock and search for Cloudinary, I also have a ton of use case driven examples, as well as a repository of straight up code examples using Cloudinary in projects. There's more to come, and I'm taking requests. And that's it. If you want to learn more or chat about the talk, again, you can find me everywhere at Colby Fayock. I'll also keep an eye out for a link on my Twitter where I'll post up some resources. Thanks, everybody.
Okay. What a great presentation for Colby. I really enjoyed it. I have to say, I want that Tag Life Dog poster because I need to hang something in that side of the wall, but I need to get one of those things. So, with that said, we're now going to be taking another break. This is a bigger one. It's going to be around 33 minutes or so. We'll come back at 1:35 so we can watch Misko's talk about Qwik. If you just a reminder, if you have any questions for Colby, you can ask him on Twitter or on LinkedIn. His links are on Geekle's page, so you can check them out there. Once again, see you in a couple of minutes, and make sure to grab some food, grab a coffee, have some fresh air. See you in a bit.
Hi there, this is Dmitry, and I have some awesome news to share with you. We're excited to announce our new event called AI in Software Development happening on July 6th. You know how techs keep changing nowadays. Well, we believe that AI is the future of software development, and we want you to be part of it. And here's the best part. As a special thank you, we're offering a 20% discount on tickets. Just use promo code REACT-Geekle when you register. So don't miss out this great opportunity to learn and connect with like-minded professionals. Thank you for watching, and I can't wait to see you there.
Hello, we're back. How's everyone doing? Did you grab a coffee, have a good meal so far? Because get ready, because we still have a lot of cool talks to go through today. And we're ready to start with the first speaker right now. He's the CTO at Builder.io. You might know him from being the creator of popular things like Angular and more recently Qwik. So in this talk, Miško will be talking to us about Qwik-React. And the title of the talk is Qwik-React, Introduced Progressive Iteration into your React applications through Qwik. I actually met Miško last year, and I got this Qwik badge from him, so super excited for it. Well, without any further ado, we can get ready to listen to his talk. Just one thing to be aware is that we won't have Q&A with Miško, unfortunately. But if you want, like previous speakers, you can reach out to him on Twitter or on LinkedIn with any questions that you might have. So, without any further ado, Miško Hevery.
React. It's a way of introducing progressive hydration into your React application through Qwik. Hi, I'm Miško Hevery. I am CTO at Builder.io. I created this thing called AngularJS, Angular, and now I'm working on Qwik, and I had something to do with Karma. So what is Builder.io? Well, Builder.io is a headless visual CMS system. What it means is that we allow you to install a drag and drop editor into your existing React application. That gives your marketing team ability to drag and drop components, and you as a engineer will retain full control because it's served off of your infrastructure, and you get to build your own components that the marketing team can do. Now, Builder.io does other things as well. We do this thing called Partytown, which allows you to take third-party code, and such as analytics, and run it in a web worker. And this is a way of offloading work from JavaScript. We also have a cool project called Mitosis, which allows you to write code once and run it on any existing frameworks. This way, you can have idiomatic code for your existing technologies. All right, so what do we want to talk about today? Today, we want to talk about startup performance. And startup performance matters. If you look at existing websites and look at their core web vital scores, you're going to discover is that most of them kind of fail. And I think this is a problem because, we live in a world where we are connected. We have these fancy phones in our pockets that have a huge amount of compute power. And yet we are still failing to deliver websites at scale with speed. And even companies such as Amazon, who have huge investments, are doing much better than everybody else, but they're not doing the best either. And so most of the other companies are actually in the red. And Google cares about core web vitals a lot, which is why they created this particular standard and they measure it. And one of the things that Google has shown is that having a good score, meaning that your website loads fast, has an impact to your bottom line. And that kind of makes sense because, somebody sends you a link to a shoe, and you click on it and you're like, hey, that's a nice shoe, I would like to buy it. But you push the buy button and nothing happens. At some point you're going to say like, forget it. I don't really need the shoe that much. And you're just going to leave. And so whether or not your e-commerce website is going to have a good conversion ratio, a large part depends on how fast can you make the page interactive. And so that's kind of the talk of it. And the thing I want to convince you about is that it all has to do with JavaScript. In other words, the less JavaScript you ship to the browser, the faster the startup performance is going to be. And the inverse is also true. The more JavaScript you're going to ship to the browser, the worse it's going to get. And this graph shows the amount of JavaScript we've been shipping to the browser over the years. And what it really shows is that even though our networks are getting faster, our phones are getting faster, and so on, we're kind of negating all of these benefits by just shipping more and more JavaScript. And JavaScript has a particular problem, which is that it's single-threaded. And because of that, the fact that we have new, faster CPUs that are multi-threaded aren't actually going to help the situation, multi-CPU, multi-core, because JavaScript can only use one thread at a time. Even though the technologies like web workers and essentially Partytown will allow you to offload some of the work into a separate thread. So the name of the game is to figure out how to ship less JavaScript. And it's not about figuring out, how to write less code in your application, because I don't think that's unrealistic. We have all the code that we have. But instead of delivering all the code all up front, which is what's happening right now, we should figure out a way to deliver the code on an as needed basis. We would like to have more like streaming approach to delivering of JavaScript rather than, upfront. Think of it, watching a movie. When you watch a movie, you don't download the whole movie ahead of time. You simply stream a few seconds ahead, and as you're watching the movie, the code shows up. And so what you would like is, like, if you think about it, when you have an application, you don't need all of the click handlers and all the interactivity of the application all at once eagerly available in the browser. You can stream it as you're using the application. As different parts of the application become visible or available, the amount of JavaScript available to the browser should be incrementally loaded. And so you want to have a kind of streaming metaphor. Now, to convince you that this is the problem of JavaScript, I have picked several different frameworks. And I wanted to show you is that the amount of JavaScript the framework ships, an average website built in this framework, the amount of JavaScript that ships, and the medium lighthouse performance is actually inversely correlated, meaning that the more JavaScript you ship, the less likely you are to pass your Core Web Vitals score, and vice versa. The less JavaScript you ship, the more likely you are to pass. And it kind of makes sense because if you ship less JavaScript, there's less JavaScript for the browser to download, less JavaScript to execute, and it can go through all the code faster before the page can become interactive. And so then we can ask yourself, like, well, how do we ship less JavaScript? And to understand that, we really have to understand hydration. And hydration is kind of the core of the problem here. And the way hydration works is, well, originally we didn't have server-side pre-rendered pages. And so the way we did is we had a small HTML that would send a blank page. But the blank page would be a problem because, well, I mean, who wants to stare at a blank page? Because then it would have to download JavaScript. The JavaScript would have to execute the application. It would have to render the application. And finally, you would see something on a page. And it's at this point that you could actually interact with the application, because at this point, the listeners are downloaded and everything is ready to go. Now, the problem here is that we get to stare at a blank page for a while. And so we need to solve this. And so people solve this particular problem with server-side pre-rendering, right? And so the way server-side pre-rendering works is that we, instead of sending a small HTML, which is just a blank page, we send a bigger HTML with the whole application. Actually, not the whole application, but rather the image of the application, right? We execute all of this code, the JavaScript and execution, and then the rendering on a server, and that produces the HTML. And so this is the HTML that we're sending across. And so when the HTML shows up, we have a full page. However, you cannot interact with this page. So the page appears faster, but it's actually not interactive. And so there's this uncanny valley where you have to still download the JavaScript, you have to execute the application, and you have to render the application before you actually have a page that is interactive. Now, some people will say render, some people will say reconcile. So, modern frameworks oftentimes know how to reuse DOM elements, but whether they're reusing the DOM elements or basically just creating a new one, it actually doesn't matter, because it turns out it doesn't matter what kind of a HTML is present in here. The rendering pipeline will eventually produce this particular output. That's because the JavaScript and the reconciliation has a full duplicate of this HTML, and we're essentially just rerunning the code base as if we had a blank page, and we're just trying to reuse the DOM nodes if possible. So it is at this point that the page becomes interactive, and you can go ahead and click on it. And so we have an interesting paradigm that we appear faster to the user, but we're actually slower. And this is the uncanny valley that I was kind of alluding to earlier. Somebody sends you a link to a shoe. You want to purchase it. You click on it. The shoe shows up. You see it. It's right here. And you would like to hit the buy button, but you can't, because clicking the buy button does nothing, because you are still downloading or executing or reconciling the application. You are not here. And the problem is that when you finally get here, there's usually any kind of visible thing to show you, like, oh, now I'm ready for the click listener, or now I'm ready for you to click on a buy button. There's just nothing in here. And so typically people just click, wait a little bit, nothing happens, click again, wait a little bit, nothing happens, click again, oh, finally something has happened, right? And so during that time, more and more people are likely to just leave your site. The other problem we have is we have duplicate information. The reason why this whole image is shifted to the right and is essentially on the end becomes slower is because this HTML we're sending over is now bigger, right? And it's bigger because, well, their same string, like for example, this visually built on your tech stack, that string is found both inside of the HTML and also inside of JavaScript. And so it's actually sent twice. And so we have a whole bunch of duplicate information. So an alternative to this is something called resumability. And so the way this works is, let's compare it with the hydration story above to how resumability works. In both cases, you start with server-side pre-rendered HTML. So you show up with HTML, and that shows you the actual UI. However, in this particular case, the UI contains extra attributes that tell it what things to listen on. And so at this point, the system already knows that it's supposed to listen on your buy button. So if you click on it, that click can get registered. And because it's already registered, we know that when you click on an application that's resumable, that will eventually be processed. Now, we don't yet have JavaScript, and so we immediately, so first of all, we do appear faster over here. But the first thing we do as soon as we download the UI is we start downloading the JavaScript. And so if you happen to click the button before the JavaScript downloads, yes, you might have to wait a little bit. But as soon as JavaScript downloads, and this is done eagerly, right? Your clicks will be processed immediately. And so it's at this point right here where your response to your click will show up. And this point right here is way ahead of this point right here. So first of all, no clicks get lost. And second of all, the point which they processed is significantly pulled up. Now you might say, hey, but you just made this box smaller. What happened to this extra box over here? You're kind of cheating. And that's because this is the duplicate information that was removed. The system can auto-detect which things are static and basically say, hey, this visually built on your tech stack, that particular string never changes. And so why am I sending it to you again in the form of JavaScript when I know that this text will never change? And so as a result, a lot of the duplicate information is removed. And because the duplicate information is removed, we actually cannot even execute the application end-to-end, even if we wanted to. And so the execution of the application and the reconciliation of the application is actually not possible. But that's fine, because resumability doesn't need any of these things. Resumability has serialized all the necessary information, such as click listeners, into the HTML and can just continue where it left off. And so a resumable application has a significantly faster startup performance than a typical hydration. So let's look at hydration and how it works. So the way hydration kind of appears to the end user is that first you come across server-side rendered HTML. And that looks something like this. And this is a standard thing for your Angular, React, Solid, Svelte, Vue, Web Components, kind of a list of frameworks. So SSR shows up, you immediately see it, but the browser now has to download the JavaScript. So the browser starts downloading the JavaScript. When the JavaScript shows up, the browser executes it, and as it's executing it, it's attaching the listeners, and this is shown as the application becoming blue, meaning that it's possible to now interact with these particular components. Now, the thing I'm trying to convince you of is like, well, this is taking too much time. This hydration is too expensive. We need to make it smaller and cheaper. And so one thing you might be tempted to do is to say, that's fine, I'll just use lazy loading, right? And so now let's do the same exact thing with lazy loading. Here is a HTML sent from the server. So same thing happens again. We download it, we start executing it, and we start the hydration process. But at some point, we're going to come across a lazy loaded boundary. And so now the framework cannot continue the hydration. And so it is forced to re-download the component because they're not visible. And now as it's re-downloading the component, then it can go and continue the hydration. And so the realization you have with this system is that the only kind of lazy loading you can do with classical hydration systems are with components that are currently not in the render tree. So you can lazy load a separate route, a separate page, like a modal dialog box or something like that, but you cannot lazy load anything that's in a currently rendered tree. So that you can argue that makes the situation worse, because now you have to make 2 round trip to the server than 1 round trip to the server. All right, so what is the solution that people have come up with for this particular problem? So one thing that's becoming popular is islands. And the way islands work is that instead of hydrating everything eagerly and taking the time at the beginning, the islands are much smaller. And because they're much smaller, we can do them lazy. We can do them on click or on hover or anything like that. And because they're smaller, we basically don't pay the full cost all at once. We're basically amortizing the cost over time. And we're hoping that maybe you don't interact with all sections of the page. The static pages don't have to get hydrated ever. So the way island architectures work is that when you, for example, come to an island and you interact with it, it's only then that the hydration happens. And because we have delayed the hydration until later, and because now instead of hydrating the whole application, we're only hydrating a small section of it, we can actually do it quick enough where hopefully the user won't notice and it will be immediately responsive. But as you can see, these are all islands. And one of the problems you have to solve is that these islands need to talk to each other. Now, normally the islands are components, and well, the framework provides mechanisms for talking between components through state. But because these are islands, and island is a separate application in a sense, most frameworks don't have an intra-application communication channel. And so it is up to you to kind of figure out how to talk to these particular islands together. Now, frameworks such as Astro do provide some mechanism, but it is different from the mechanism you normally use for communicating between components. And an often thing that has to happen is, there's a buy button right here. So maybe this buy button needs to get hydrated, but then clicking it then needs to cause hydration of another component that's far away. Typically a shopping cart and a buy button are actually far away. And so you need to have ways of communicating between them. And finally, we have Qwik with its resumability. So Qwik is different in a sense that it doesn't really hydrate anything at all. Instead, it can just continue execution where the server left off. And the way to visualize it is that when I go and interact with particular components, such as this one, only the associated code related to that component needs to get downloaded. Now, even that's not actually a good mental model because, for example, if the component never has to re-render, then the component never actually even downloads. So really the only thing that has to download at this point in time is just the listener or just the interactivity associated with that component. Now, the interactivity may cause a component to re-render, in which case we have no choice but to download the component as well. But if the component doesn't necessarily re-render, then even the component doesn't have to get downloaded. Now, the thing to kind of point out is that when I interact with a component, notice that only the component itself got woken up. What didn't happen is I didn't automatically wake up the parent components or the child components. And this is an important property because it allows us to automatically have fine-grained kind of resumability rather than rehydrating the whole application at once. Now, the thing that it allows you to also do is that let's say you have a button, such as we talked about having a buy button. And if I go and interact with the buy button, notice the system already knows how to automatically wake up other components that are related. So if this is a buy button and that's a shopping cart, the system knew how to automatically wake this up. And this is an important part, which isn't part of islands, right? The island architecture kind of leaves that to a separate thing. Whereas resumability, you have the same mental model of having components, which just are very good at not sending the components over to you. So how can you use this to help your React application? So the way to think about it is that there is a continuum, right? On one extreme, we have full hydration systems like Angular, React, Svelte, etc. They fall into this category. On the other extreme are fully resumable systems like Qwik. Google has one called Wiz, which is one you probably never heard of, but you use all the time because it powers Google Search and Google Photos. And eBay has one called Marco, which is also resumable. And so what these technologies allow you to do is to kind of pre-compute the application on a server and then just transfer its state over to the client, and only the interactivity is the parts that need to download and execute, rather than re-executing everything at once. And so that's the other extreme. But in the middle are basically our island architectures. And typical island architecture, the most popular one being Astro. There's another one called Fresh from Dino. And I'm going to argue that Qwik can actually do also perform this kind of an island architecture on your React application. And I'll show you how in a second. But what these architectures are kind of in the middle here. They basically still do hydration for your components, but instead of doing the hydration on the whole application, they do it in parts, on sections of the application. And that's beneficial because it allows you to kind of put the system together instead of having to download everything at once, things can be done partially. So let's do some demos. First thing you need to do is install Qwik. And so that's done through a typical command line CLI, npm create Qwik at latest. You answer questions about the name of the project you want to do, you want to create a basic app, whether you want to install npm dependencies and so on, and voila, you now have Qwik installed on your machine. The next thing you need to do is you need to get Qwik-React installed inside of it. And so Qwik has a CLI for doing that. You do npm run Qwik, and there's a command called add integration. In this case, you want to add the React integration. It shows you all of the pieces that need to be downloaded, and now you can use React from within your Qwik. So how does that look like? Well, let's build a hello world. So any kind of interaction between Qwik and React has to happen in two separate files. And the reason for that is because the React component needs to be compiled using a different JSX compiler than the Qwik component. So the Qwik has a different way of compiling its JSX. It uses its own things, whereas React has to use the react.h function or React create DOM element, etc. So we put them in a separate file, and all the React components need to have this JSX import source, which tells the JSX compiler to use a specific import for the JSX. So that's what you see. Let's create a simplest of possible components in React. So let's do basic greetings component. All it does, it says hello from React. And the thing to do here is to wrap it using Qwikify. So Qwikify is the function that takes that it's provided by Qwik, and it takes a React component and returns to you a equivalent Qwik component for this. Now you might be asking, what's up with the $signs? So $signs within Qwik have a special meaning, and that basically mean that this particular thing can be lazy loaded. And so every time you see a $sign, that is a potential place where Qwik can decide, hey, this code may or may not be needed now or later. And it gives basically a point of lazy loading or tree shaking or bundling for Qwik so that it can decide in the future whether it needs to do that or not. It's also a communication channel from Qwik to the developer to say like, hey, I may or may not include the greetings. It's up to me based on how what I find is necessary. And so now that we have a Qwik version of the React component, we can import it in our Qwik file. And in here, we can just say, hello from Qwik. And we can include the component that was generated by Qwikify. And so the output looks just like this. We can look at it in the browser. So here is what it is. And one of the things you're kind of going to notice if you flip over to the network tab, let's look at JavaScript only, and let's refresh. And we're going to take out Vite. So this is in dev mode. So I'm going to say, don't show me Vite. What you're going to see is that very little code actually downloads. There is some router outlet, which is done for debugging purposes, but you can ignore this for now. But no actual code is downloaded in the client. And that's because Qwik looked at this application and said, I don't see any listeners here. I don't see any behavior, neither here or obviously on the React side either. And so because of that, I don't see how you could possibly interact with this application. And because you can't interact with the application, there's no need to send any kind of JavaScript over. And so the only kind of JavaScript that gets sent over is kind of debugging purposes, etc. So you can kind of ignore this. And so no JavaScript actually gets sent across to the client. But of course, this is not very interesting because, well, it's not interactive. So let's see if we can do something more interesting. Let's create a counter. So counter, it requires a button that you can click on, and clicking on it requires a state and a listener, and clicking on it updates the state of the system, which then causes the React to re-render. And again, as before, we will Qwikify it, which will turn it into a Qwik component, and then insert it into a Qwik side of things. Now, if we go into the UI, same thing will happen again. We will look at our network tab, and we will see that, hey, there is, we will look into our network tab, and we will again see that if we take out the Vite, there's essentially just the debugging file over here, and nothing else is present. But also clicking on it doesn't really do anything. Now, if this was a Qwik component, Qwik would know how to automatically wake everything up and do, but the Qwik can't really see into the React. And so we didn't tell Qwik under which conditions should the React be hydrated. And so we need to add a little bit to it, which is this eagerness hover. And that's basically saying that, hey, you need to hydrate this component when you hover over this particular button. So let's have a look what that looks like. Notice again, nothing in the console. No, let's take out the Vite. Nothing in the UI. And then if I hover over the button, whole bunch of JavaScript downloads, and among all the things that downloads should be React. As you can see, React shows up in here as well. And if you look at it let's look at it from the console point of view. Let's refresh. Again, nothing's showing up. And when I hover over the button, it is at that point that the Qwik container gets resumed, that the React DevTools shows up, right? That's how you know React is being downloaded. And you can see that the React actually says React counter render. This is the hydration, right? Because during hydration, React will execute this particular component end to end. And as the component is being executed, this is the point where React figures out like, oh, there's a click listener I have to attach. And so now the click listener is attached. And so now hovering over it does the trick. And so now I can go ahead and click and the content updates as you would expect. And so that's basically the basic idea of Qwik and React. However, one of the things I talked about is that, typical page will have multiple islands. And one of the things you need to solve is intra-island communication. So let's look at that. So let's have a little more complicated case where you have a button, which represents island 1, and you have a display, which represents another island. And so this button is going to get wrapped using Qwikify, and it's going to have on hover, right? So that when you hover over the button, React is going to get woken up. It's going to do hydration. During the hydration process, it's going to set up a click listener. Display is going to not have a hover because there's no need to re-render anything. We only need to re-render the display when its input changes. So it does not need a hover. Now, these two components will then represent two separate islands in your application. And we can include them in the Qwik side, and we can connect the button with a click listener. And again, notice the $, meaning that this will be able to be extracted and downloaded independently from the whole file. That's going to become important in a second. And you can see the Q display over here, count value, showing up over here as well. So let's see how this particular thing runs. So let's go to two islands. And notice when I hover over the button, this is the time when the container gets resumed, React downloads, and you can see that the React button got rendered. That's because hydration has occurred for that button, and now the button has registered a click listener, and it's going to be able to interact. Notice what you don't see over here. What you don't see over here is the display, the display executing, because, well, the display didn't have to execute because, there's no click listeners on it or anything of that sort. And so it can be lazy instead of eager. And that's because we didn't give it any kind of eagerness, the display doesn't do anything just yet. But the way to think about it is those are two separate applications, right? So this is one application running in React, and this is a separate application running in React. And then this one gets hydrated when you hover, and this one only when the item changes. Now, let's look at how the pieces get placed together. Okay, so now we have a button. So when I click on this button, actually what we have done is we have passed the listener to the button over here, right? So this listener got passed in and got registered by React in here. But this button actually closes over the signal value of 0. And when we go and increment the value, the signal fires and notifies the display that the count has to be re-rendered. And it's only at the point when I push the buttons, only at that point that you see that the React actually rendered or hydrated the display island. And it's only at that point that the display then re-renders with the new value. Now, so let's do it again. So notice no React is present on the page, right? The page was very fast. When I hover, the React comes up and we hydrate the button only. And it's only when I interact do we go and we then hydrate the display as well. And then we re-render the display as well. One thing you're not going to see is this one right here, the console log quick render. And this is kind of interesting, right? Because this string never shows up. Where it actually did show up was on a server. When the application first rendered on the server, it is at that time that this component got executed. And what happened is that the Qwik framework was able to then extract just the listener, just this listener over here, and say, you know what, this is all static. None of this stuff is needed in the client. And so I am not going to send the code associated with it, and I'm not going to execute it on the client. And that's why we don't actually see console.log. The only thing that's going to get sent to the client is this click listener right here. And we can see that if we look at the network tab. Again, filter out Vite. Let's do it again. You know, no JavaScript, right? When I hover, Qwik and React shows up, but it's only when I click does the click listener actually load. It's only at that time do we actually download and print out the click listener and increment the value, right? And so this is what the $ allowed us to do, is it allowed us to pull out just this section of the file rather than the whole file, because we correctly deduced that we don't need the rest. And so this example really shows how you can have two separate islands and then use a intra-island communication channel, because the rest of it is just a regular framework, right? Regular framework communication through state that you can pass around, and the correct things will wake up when you need it. Now let's do one more thing. Notice how originally here we had to have eagerness hover, right? But if you think about it, the only thing that was done was to register the listener. So let's show this again. We don't have any code. When we hover, we executed the button, right? That's because the hydration required to set up the listener. But once I clicked on it, the button no longer re-renders, because, well, it's a separate application, right? It's not part of the render tree. But more importantly, there is no set state in there. And because there's no set state, well, there's nothing to re-render. And so if you think about it, this is kind of a waste, right? Because we spent all this time and energy downloading React, hydrating things, etc., only to set up a click listener. So in the situation where the component over here is static, we know the button is static, will never re-render on the client. In a situation like that, we can do a trick. What we can do is we can remove the eagerness here, and instead we put the special host prefix over here. And so what we're saying is, hey, Qwik, instead of passing the on-click to the button and have it do the listening, why don't you do that on its behalf and just set up a click listener on automatically as part of the SSR, because we can serialize this information inside of attributes. And so this particular change over here allows us to completely get rid of any kind of eager hydration on the React side. And so now if we go to the page and we refresh, notice no, let's go to the network tab. Let's remove Vite. Okay, no JavaScript. Notice hovering doesn't do anything, right? Just because I'm hovering, nothing's happening. It's only when I go and I click on a button, it's only then when React shows up and downloads, etc. So let's flip this over to the console view. Refresh this, and notice nothing's showing up, and it's when I click, it's at that time that the code, React downloads and hydrates the display, and then updates the display with a new value. Notice the rendering of the button island is no longer present over here because, well, it's not needed. And there is no set state, and it actually never actually happened because we're relying on Qwik to set up the listener on our behalf. But we're still using the button as part of the SSR. So during the SSR, the button is used for rendering. That's how we knew how to render the right stuff. And this console log would have shown up in the SSR logs, but never downloads into the client. And so because there is this $ over here, not only does the code not execute, but Qwik can actually remove this from the client bundle. So if you look at the client bundle of the older code that we have downloaded, you will not find the button. You will find the display, but the button will not be present. Similarly, you're not going to find this component in the bundles in the client. You're only going to find the click listener in here. We can kind of look at in the network tab, and we can see that here is our listener, the trigger, the click. This is a framework for Qwik. Kind of helper functions here. And here is our display. So the display has to get re-rendered, right? So this part over here is present. So let's talk about islands a little bit. So you can use Qwikify to turn things turn React components into islands. And a thing to kind of keep in mind is that while this might be a fun thing to do, you want to keep the islands as big as possible. You want to hydrate things that are all things that are related. So in this particular case, when you have list items and complicated component, you should really hydrate the whole thing at once rather than hydrate individual items one by one. And we call this having the islands be wide rather than having the islands be narrow. So the opposite of this would be, quickifying individual items. While this is possible, you can certainly do that and it will work. The goal you should be having is that you should have kind of a good balance between related components that need to be hydrated together instead. And finally, I want to show you one more thing, which is that there are a lot of controls about when you hydrate different components. So you can use it, for example, on load, which just means eager hydration when the page loads. You can wait until there's idle time. You can wait for the intersection observer when the component becomes visible. A mouse hover is another thing. Or you can have a custom component such as a click. And finally, you can do it programmatically. So in this particular case, clicking the button over here goes and sets a value of a signal. And then this signal is then used as an input to decide when a particular component should be hydrated. Anyways, I hope you've enjoyed the talk about how you can use Qwik to turn your React application into a bunch of islands and how you can lazy hydrate these particular islands and therefore remove the amount of JavaScript that you have on the client.
What a talk, right? So, what did you think about Miško's talk? Do you want to try a Qwik with React right now? Well, for me, it's definitely a thing to try. So, I'll add that to my personal backlog. So, one thing that I mentioned before, it's important, and just to remind you all again, we won't be having Q&A for this session. So if you have any question you'd like to ask Miško, please make sure to reach him out on Twitter or LinkedIn or any of the social handles that he shared in Geekle's page. So without further ado, we can go to our next speaker. So our next speaker is a software developer at Bootstrap. And his talk is titled Rock and Mock. So that's definitely an interesting title. I'm going to bring Dario to the stage with me. Hello,
Hi.
Dario.
Hi, Daniel. How are you doing today?
Yeah, really great. How about you?
I'm doing really good.
Okay, amazing. So I'm excited to hear about your talk. Do you want to do a small preview of what you're going to talk to us about?
Sure. Yeah, I'm going to be speaking about server mocks and how we can work in parallel as a team.
Okay. Count me interested. So without any further ado, I'll give you the virtual floor. And yeah, everyone, this is Dario with his presentation.
Awesome. So, okay, I think you can see my screen. Okay, awesome. So, morning. Welcome to Rock and Mock, or How to Work in Parallel as a Team. My name is Dario, and I'm a semi-senior software engineer from Bootstrap, which is a Norwegian-American company. We have teams of experts from all around the world, and we are focused on outcome-driven development, which includes rescue missions, building apps from scratch, and also extra development muscle for clients' internal projects. I also used to work at Mercado Libre, and I focus on React.js and Node.js currently. So before we get started, I'd like to give you guys a Mentimeter. So I'd like you guys to tell me if you ever had a frustrating experience integrating APIs. So the code, I think I can give it to you guys. So right here in the chat, the code is 366.1.94.44, right? And yeah, so if you'd like, you can vote and tell me if you ever had a frustrating experience integrating APIs. So while we're doing that, sometimes, right? So while we're doing that, we can tackle that later. We can start talking about a little bit about mocks and what they are. So we're going to be talking about what a mock is, why would we mock in the first place, how do we mock exactly, and then some pros and cons of different alternatives, some examples, and then a Q&A. Okay, so we're already having some votes here, and okay, that's interesting. So most people sometimes have frustrating experiences, and then a few people have every single time a frustrating experience, and then no one says never, right? So we're gonna speak a little bit about why that is, and why we keep why this comes up, right? So we're trying to build an application. Building an application requires a front end and a back end, and why does this happen every time, right? Or most times, right? And so let's talk a little bit about what a mock is, right? So in a nutshell, a mock is an inexpensive fake, right? So it's like that scene from the movie Wolf of Wall Street, right? So it's a fugazi, it's something that's in the air, right? It's not real. And in the case of server mocks, we're talking about something that emulates a server, right? So instead of having a real server, which is expensive, we have to deal with authorization, the actual logic of the application, the business model, all of that sort of stuff. And that takes time and money. And sometimes we need to first, for business reasons, or maybe we want to pitch the idea to an investor, and we don't necessarily want to invest all of that time in the backend, which is not going to be as viewable as the front end, right? And so, right, so most people have had some bad experiences with APIs. Okay, and now I'm going to give you another one, which is what mock have you used in the past? It's okay if you haven't used any of them, so you can put none, and then we're going to use some of the alternatives that are right here, right? Right. Right, so I figure that most of you probably know unit test mocks, which are the most common, and that's awesome. And also all right, so we have a few with stoplight, mock service worker, and if you haven't used any of them, that's awesome, because that means that this talk is going to give you the most value to you. And so, right. Okay, great. So we have an overwhelming success on the part of unit test mocks. That's awesome. Okay. Mock service worker. Okay, great. So let's go back to the presentation. And right, so we were talking about server mocks, or mocks in general, which are inexpensive fakes, right? It's something that's not really there, and that just helps us get things done, right? So why do we mock exactly, right? So the first reason is that it's fast and cheap to develop, right? So imagine in the casual case, we have a front-end application, a back-end application, and we try to join them as one. And something that happens is that it's complicated, it has nuances, it has like different options that make it like really difficult to make an integration. And sometimes, right, like I was saying previously, maybe you want to show the client front end while you still are in the middle of developing the backend. And so, yeah. So Another reason is that the real API might not be accessible, right? So if you are consuming an endpoint from an API from the government or some other entity that's regulated, you might not have access or the authorization to consume the actual API. Maybe only the production code can access it. It may not be reliable. So if you're consuming an API from a third party and the API is down for some reason, that may imply that you have to halt your development process. And so like if it's down for a day, you cannot work on that project for a day. So that's the worst. And something that also may happen is that the real API might not even exist, right? So maybe we're building an app from scratch and we're developing the front end and the back end is in development, but it's not built yet. And we don't want to, as front-end developers, we don't want to pressure the back-end engineers at all, right? So as you probably know, if you have like an engineer background or developer background, we learn about classes, right? And we learn that when a class is too close to another class, they are too tightly coupled together. And that's bad because they are codependent, right? And that makes it difficult for a lot of reasons. But we can extrapolate that and use it to our own development process and say, hey, if I, as a front-end developer, need the back-ender's work to be able to work, that's too tightly coupled, right? So we want to move away from that and be able to work on our own. So here we have like a front end on its own, and it's very sad, and we have nothing to consume. So some strategies that I've used of and heard of from other people include like having objects in the front end, which are like sort of mocks, but they are inside the actual code. So that's not very clean. And sometimes like you just consume the actual API when you have it. So it's very, very improvised. And what we see here is that with a server mock, we are actually able to unite it with the front end and just like be happy with our application. And right, so even though I'm saying front end a lot, some of the use cases that we're going to use, we could be talking about a backend that consumes a third-party application. So that's also the case. That also helps, right? So, okay, let's say you guys are interested. How do you mock exactly? So we have numerous tools. One of them is Mockooon. Another one is Mock Service Worker. And we have many others like Stoplight and yeah, so tons of them. There are like tons of competitors in the market, and that's awesome because that means that we have more to pick from. So let's talk a little bit about these two options. Mockooon is one that I've been using for the past 6 months, and it's awesome. In one word, it's like the postman of mocks. So basically what it means is that if you know Postman, Postman lets us consume a backend application without having the front end. And this is sort of like the opposite. We can provide a server and consume it without having to actually make the server. So we're going to see a few examples later. And basically the thing that it has is that it has a UI. So it has an interface. It's very user-friendly. We don't have to code at all to use it. So it's very, very friendly to anyone who just wants to get started. And yeah. And here we have a screenshot of how Mockooon works. So here we see that we have on the far left, we have multiple projects that we can set up with their different environments, and we can see the local host, the port, and where we want it set up. If we go a little bit to the right, we have unlimited endpoints, which is the place that we can set up folders or endpoints with gets and mutations and all that sort of things. We can set the params, right? So we can use, so the same way that in a real backend application, we could use the params and the query params and things from the body and all that sort of thing, we can actually also use in Mockooon. It's very, very flexible in that style. We can use rules to determine which responses are returned. And also it's independent of your code. So as you can see, Mockooon doesn't know what kind of project you have. If you have a React project, if you have an Angular project, you just use it independently. You could even be using Python and consuming another API from like a banking client, and yeah, so it's very independent. Let's do an overview of Mock Service Worker as well. Mock Service Worker is a package that we can install on JavaScript and TypeScript applications, and it basically uses code to do exactly the same. So it's we set up a server right there in our front-end application, and we can just start going with our different endpoints, and yeah, so it works basically the same way. That's the same thing. The only difference is that it doesn't have a user interface, right? So if we can, we can create handlers for the endpoints that work with JS. The only drawback that I can see here, apart from the UI, is that we have to. This is specifically for a front-end application, right? So here we can see that we have the verb. So we have rest.post. So post is the verb, and we have /login, which is the endpoint, and then we can define what we want the body to be, the status to be. We can define all of those things, and even consume another real API. So it's as flexible as it gets, but it also adds complexity, and it doesn't have a UI, right? So comparing the two of these, Mockooon has a UI. It's fast to test locally. We can just like that get going. We can alternate responses, and we can use logic without code. While Mock Service Worker provides more granularity, so if we want to get really, really specific, we can do so, and we can use it in unit tests, and it's right next to the code, right? So we can simulate an API call in our unit test, much the same like we use Mockito and other unit test applications. The difference is that we are simulating an actual API call, right? So that's useful for integration tests and that sort of thing. And also it's right next to the code, so we can have a version control over it. So we can use Git to keep track of it. We can execute it in a CI pipeline, right? So that's also awesome. So as Linus Torvalds would say, talk is cheap, show me the code. So what we're gonna do right now is view a few examples of this and just see how each of those works, right? So we're gonna head over to Mockooon here, where I have an example project for the Global Summit. And something that we're gonna do real fast is that, hey, I wanna add an endpoint, so I can just go here, I can just select HTTP route, and I can put /hello here. And in the body, I'm gonna return down below, I'm gonna return greeting is hello. Right. So we have to restart the server when we add an endpoint. That's how we do it. And now we're gonna head over to Postman in this case, and I'm gonna say, hey, I wanna go to localhost 3003/hello. And there we have it. So it's that easy. It's that simple. And we can just do all sorts of things with this use case. So I've got a few examples over here of how crazy can we get with this. So let's keep it simple for now. I have an example on /users, which has the same user copy and paste 10 times over, right? So it's a list of users, and they have different IDs, but except for that, it's the same user, right? So if we go to get /users, we can press send, and we have the list of users, right? We can also have another endpoint, which is for deletion and all of the different verbs that we are allowed to in HTTP. Here we see that we are using a param, which is ID, and I can return an ID with something that we're going to see in a second, but it's called templating. Mockooon is actually integrated with handlebars, so it uses the handlebar syntax, and it also is integrated with Faker.js, which is also a popular library with fake data, so we can use it to do some real crazy stuff that we're going to see in a bit. So if we go over to delete users, I can press send, and here it returns, since I told it to delete the user 0, it returns ID 0 to confirm that it's deleted, right? And we can define it however we want. And right, so let's see something that let's see what else we can do. So here we can set a post and just tell it to give us a file when we hit the endpoint. So if we go over to post export/file, and I press send here, I get the image for the React Global Summit 2023. And yeah, I just had to set up a relative path here, right? So we can return files. But well, something else that we can do is that we can, and this is a new feature, by the way, we can define a CRUD route, which is a route for, it's one route that we can define and that lets us do all of the things in REST, right? So with just defining CRUD users, I get access to all of these different endpoints. And the big difference here is that it actually modifies our existing, we can use like a fake database to modify our users. So one thing that we can see in get users, if this is, I get the ID 0 here, and if I press delete on /users, it says that it's deleted, but it doesn't delete it here, right? So, because it's a mock. But if we have CRUD users, I can just go ahead and make a get here. In this case, we see that it's empty. I can make a post to users to create a user. Here I have an example body. I can press send, and when I press get again, I now get the actual body that I wanted to see, right? So, and this is all with just one endpoint that we're defining, right? So that's very powerful. We can also set up a proxy here. A proxy is very useful in case you already have the actual API, because you can tell it, if you haven't defined an endpoint, it will automatically hit the actual API for the endpoint, and then you can add it to, add the endpoint to your mocks. So that's very, very helpful. So let's see a few of the examples in templating. Templating is something that I've discovered a few weeks ago. Sorry, can you guys hear me? Okay, awesome. Great. So basically, here we can see that I use templating here to do exactly the same example as previously, but in this case, I'm using a sort of for each iteration. And right, so what we see here, if we switch the flag here, we can go to Postman and press the get /users. And in this case, we get exactly the same thing, but with only this amount of code, right? So previously we had all of these copy and pasted, and now we just have this. And we can do all sorts of crazy stuff with this. In this case, I have a more complex example which uses Faker.js, and it also uses query params and variables and all that sort of thing. You don't need to do any of this. I go through 6 months of work just doing the bare minimum, which is the simple example. But if you want to get crazy with it, you can. So here we set up the more complex example, and we see that we have the same repeat, which grabs a default of 10, but otherwise we can set up the actual size that we want it to be, and we can set the variable with a first name, a last name, and Faker.js will give us default data that looks real, but actually isn't, right? So now that I've switched the flag, I can just press send. And here I have totally different examples down below in the body. So Eileen, Christine, Alexandro, and I get usernames which make sense for the first name and the last name, right? So that's one of the useful things that we can do with Mockooon. What else can we do? We can also we can also use a JSON file to get the data. So if we go over to get/animals, we can press send, and we're going to get animals that actually come from a file and not from the actual body of the application. And also we can, okay, so here I have another example of templating that I think we don't need to go over. And this templating that we see here, I can also put on a JSON file and use it from that file, right? So if I set it to have a complex template from the file, I can do exactly the same, and now I get like a different set of species and types of animals, right? So the first one is a dog from the species beacon, and now it's a snake, right? So this goes on and on. And that's basically it for Mockooon. Now we're going to see a little bit of an example from Mock Service Worker, right? So right from the get-go, we see that we actually get this is our project, right? So this is an application. I'm going to start it right now. But basically, this is our front-end application that we're going to use. And we added in a few files over to the left in the folder called mocks that we're going to use, right? So let's take a look. So we can set up a worker in browser.js, which uses some handlers that we define. And if we go to the handlers file, we see that we have a list of endpoints, which is basically the same thing that we were doing, just without an interface, right? So I've gone ahead and defined an animals endpoint that we're going to use. And here we see that we, give me a second here. Sorry, yeah. So we have on /animals, we have a list of two animals, which are a rabbit and a bear. And in our index.js file, we ask if our environment is development, then we start the mock server. And then on app.js, what we're doing is that we are fetching from /animals on a backend URL, and then we are setting the animals and displaying them over here, right? So if we go to this website, we can see that we are actually getting a list of the animals. The only difference is that if we go to network, we see that we're actually fetching the animals. So this is an actual GET request, but it says from service worker, right? And if we go to the console, it says that mocking is enabled, and it logs each and every mocked endpoint that we hit, right? So that's basically the difference between the two of them. We can use whatever fits our project best. I would recommend, if you have like a very specific project that needs like a custom logic for your mocks, I would probably go with mock service worker. But if you're just starting out, I would recommend Mockooon because it's simpler. It has a UI. You can eventually use it in a CI pipeline. And so, yeah, that's basically it. And so if you have any questions, I'm happy to answer them. And yeah, thanks for watching.
Yeah, well, hello again. Great presentation. Can you hear me? Oops, we're having a bit of technical. Okay, can you hear me now, Dario?
Yeah, sorry.
No problem. I was saying great presentation. I've worked with MSW for like 3 to 4 years right now, and I think you did an amazing job setting it out as well. So we already have a couple of questions, and if anyone has any more questions for Dario, make sure to add them in your, as a comment in the live stream, and we'll have the opportunity to ask him. So starting with the first question that we have in here. Can you mock a GraphQL API with Mockooon? Have you tried working with this?
I haven't, but I think we can quickly look that up. Mockooon, GraphQL. And, well, I have to look it up. I haven't tried, actually. I haven't used GraphQL in an actual project, so yeah. But
okay.
Yeah.
Yeah, on of hope, I can say that it works with MSW. At least that I know. I haven't tried Mockooon as well, but you made me want to try it out. So that's a good thing. Let's check any other questions that we have in here. Can you generate documentation from Mockooon and perhaps like try to pass it for your backend developers?
Right, so Mockooon uses open API format as something similar because we have the templating and so on. But if you're using just simple endpoints, you can actually like export it and then have your developers import it into Postman or Swagger or whatever they use. If you're using templating, there may be some transformation that you're going to have to use, right? So you're going to have to change it for actual endpoints.
Okay, so and for instance, for MSW, would this work as well?
I haven't tried. I think with Swagger, you can actually make documentation from hidden endpoints, but I have to check. Yeah, I actually haven't tried.
Okay, yeah, but this seems very exciting as well, because then all you need is even if you don't have like a backend API, and I think you touched that very very well in your presentation. All you need is, okay, we have the schema, you have the API definition. Let's go ahead and start working on our task, which is personally I think like that's a very tricky thing as a front end developer nowadays, when you have to wait for that backend API that doesn't exist, and now you can just build stuff.
I would also encourage you guys to think the other way around. So thinking about the API first and documenting it, and then working on making the mock, right? So first, you actually, in order to make the mock, you have to know what we're going to build, right?
Okay.
Yeah.
Okay, yeah, and then definitely. And then that's a huge win for you as a developer, because then you can tell your product owner or project manager, yeah, we can do this in pair with backend developers and we'll probably deliver this even faster, right?
Yes. Yeah, actually, in this last project that I've been working on over at Bootstrap, that's exactly what happened. So we were, it was really fast-paced project, and it was built from scratch, and I needed to have an API to get things done, but I didn't know what to do. I didn't want to pressure all the developers because that's something that's not really nice. And so I said, okay, someone must have invented something about this. I can't be the first person to stumble upon this. And I stumbled upon Mockooon, which actually fixed this. And it actually mixes up the power dynamic, because you're actually negotiating the API with the backend team and thinking how it would be like. And then you can just work in parallel with them once you've agreed on what the API would be, right? So I don't need the backend guys to have it ready. I just need to hear from them that they agree with the API, and then I can just make the mock, and that's it, right?
Exactly. And then you probably get to scenarios where you're delivering the front-end task before the back-end one, and it's kind of like the reverse struggle, where now people are
Yes.
waiting for the backend instead of front end, right?
Yeah, that's something that also happens, right? Because in some cases, the front end is just displaying a list, but in the back end, there's like a lot of logic that's happening, and that's also happened to us, and it's been well, in the integration, nothing exploded. So that's and we were just waiting for something to explode, and it just didn't, and we're now in production, and it's very nice to see that that working out, right?
Exactly, and even like you end up feeling a bit more safe as well, because then, for instance, I didn't understand if it works with Mockooon, but with MSW I know it works. You can write tests already for integrating it. It doesn't use like that service worker. It's kind of an interceptor, but it ends up working as well. So you can just start testing ahead of time, and once the API comes, if you want to run those tests again, probably if it breaks, then it's because there was some or obviously you didn't contemplate something on your test, and there was something on the API that shouldn't be there.
Right. So with Mockooon, I actually haven't done this, but it has a CLI that you can use in a pipeline. So you can use it to, if you're having GitHub Actions or something else, you can actually set that up so that you have integration tests with Mockooon. Yeah, so that's also an option.
Okay, let's look into the next questions that we have here showing up. Oh, speaking of Mockooon, an interesting one just showed up. Could you connect Mockooon with Cypress to mock integration tests?
I'm not sure. Yeah, I haven't used Cypress, so I had to check. Sorry.
Yeah, no problem at all. It's a question of integration with one API to another one, basically.
Right, so Cypress is a little bit like, okay, so Selenium, right? So you use it to automate. So if it works on the front end, Cypress, it doesn't actually need to, Cypress doesn't need to know what the backend is. If it's a mock, if it's an actual server, you can use whatever you want. So I guess it's fine.
Yeah, probably. Yeah, probably you just need to point to the URL that is being mocked right now, and hopefully it should work.
Right.
Okay, let's look at another thing here. So I think you mentioned Stopwhite in your survey. What's the main difference between Stopwhite and Mockooon?
So I haven't used it personally, but I've had coworkers use it, and the difference that they've told me is that it was more restrictive in terms of the use cases, the different responses based on rules. So that's an area that I've been told is lacking in Stoplight. Right.
Okay, let's look at the next question. So this seems like to be a configuration issue. Did you ever experience a problem with configuring an mock service worker endware for an endpoint starting with /API instead of HTTP API? It seems like it happened when I used Vite bundler instead of Qwik-React app. I'm not sure how to interpret this. If you like to give it a go, or we can try look at it together.
Yeah, no, I actually haven't stumbled upon that particular problem. Sorry. I haven't used Vite either.
Okay, but hopefully someone will find out an answer for this person. Let's look at the next question that we have here. So, as a best practice, who should write the mocks? Backend or front-end developers?
That's an interesting one. So it actually, I actually haven't thought this through. What I actually have thought through is who should think about the API, who should define the API, and I think it's a team effort, right? So in a last instance, whoever writes the API should define it, but in reality, most of the time, maybe because of time schedules and so on, you need to be proactive. In the case of the project that I worked at, I was the one proposing APIs, and then I just say, hey guys, what do you think about this? And they would say, hey, this is how we can improve it. So it's like a team effort between the backenders and the front-end developers. In this particular case, I developed the mocks for our project, right, as a front-end developer.
So answering this question, I think it would probably depend on kind of who's more free to work on that. Yeah, sharing a bit of my personal perspective here. The ways that I did it in the past in this scenario was pretty much, if we are the ones using the mocks, in this scenario the front-end developers, then we implement them, because we did the effort. But
I think it makes sense, but I think it also we also rely on the backend developers to tell us of all the use cases, or maybe if you have a product owner, they also
define.
Yeah.
Okay, and one follow-up question here is, so does mocking tools in this scenario, Mockooon and MSW, also imitate backend request timing? So could we perhaps manipulate delay times as in real-life applications?
Yep. I haven't tried with Mock Service Worker, but with Mockooon you actually can. If you want to show my screen again.
Let's share your screen.
Second. Right, so if we go here to settings, here we have a miscellaneous, we have a latency, and we can actually set that up to however long we want. And we can also set that up on an endpoint basis. So here in animals, here on the far right, we can define the latency of the request. So I'm going to put this on 300, and I'm going to put this on like a second, right? Let's say 2 seconds just in case. So if we go over to Postman, I'm going to go to get/users, and here I see on the time that it lasted 300 milliseconds.
Okay.
And if we go to get/animals,
300.
Yeah. Maybe it's a problem with priorities, right? Yeah, well.
Yeah, but you show that it worked for one example, so that's a cool thing.
Yeah. Sorry. Sorry. So what happened there is that I had the flag here.
Okay.
So I actually wasn't hitting the actual response that I wanted. So if we go to
you were forwarding it. Okay.
Yeah. Okay, so now we have the 2 seconds, right? So we have an endpoint base and global latency.
I can say for mock service worker here, just to complement, you can use the context object and do context.delay, and you can pass the time in milliseconds here. So it should work very, very similarly to this part. Let's look at next question that we have in here. Let's see, we've seen this one. Oh, this is something interesting. So why would I use Mockooon or mock service worker instead of just writing in my code simple return promise or mock and keep the backend call commented?
So because as you go, I'm not sure how your development process is, but as it goes, as the company grows, it grows in complexity. So you have maybe you have Git flow where instead of just pushing straight to main, you have a new branch, and you have a code review, and you have all of these different things that make it so that when you want to try something, when you want to change something in the code base, it actually takes time. You need someone to review it. You need to manage it. So basically, if you have to just go ahead and change it every time you want to try something new, it basically doesn't scale at that point, right? So it also is less clean, right? So it's not really clean to do so. If you have all of your code commented, if you've had your code reviewed, you probably notice a lot of comments saying remove this comment, because people don't like them. So yeah.
Okay, I think we run out of questions. So I think we can wrap this up for now. So Dario, thank you so much for joining us. This was a real great presentation. You made me really want to check out Mockooon as well. So I think I'll give it a go after today. Like I'm doing a list with the conference so far of everything I want to try out, and thanks to you, I just added something else to the list. If anyone has any other questions, you can reach Dario on your LinkedIn page, right? That's the link you added here.
Yeah, I'm also going to be staying for a few minutes to answer any questions on the chat.
Okay.
If you want to ask them. And I also have the resources from this talk in a GitHub repo if you want me to share it. So you guys can download it, the presentation, the examples, all of it. You can just go to github.com/Dario Kozicki/rockandmock, and here you have all of the examples. And so, yeah.
Okay, so thank you so much, Dario. It was a pleasure to meet you, and looking forward to seeing your next presentations in the future, having you once again in the next conference. So have a nice day.
Thank you for having me, and yeah, have a nice day. Bye.
Bye. Okay, so that was a great presentation, and now it's time to go to our next speaker. So Travis is a senior software engineer at Plex, and in his talk, An Intro to Solid.js for React Developers or anyone else, he will walk us through to Solid. I'm super excited to check up where this talk goes and to learning a bit more about Solid. So yeah, without any further ado, I'll give you Travis, who's the creator of Bedrock Layout Dev, and he just authored the new course at newline.co, and yeah, we'll probably have him here for our Q&A session, so you can add any questions that you have for him in the comments throughout this presentation. And yeah, let's give it up for Travis.
Everybody, it's Travis Waith-Mair, and I'm going to be giving you an intro to Solid.js for React developers or anybody else. Now, a little bit about myself. I'm Travis Waith-Mair. I'm a senior software engineer for Plex. I also am the creator and maintainer of the Bedrock Layout Primitive Library. It's a library that helps you create and compose web layouts and makes it easier for you to create those web layouts on the web. Now, I also am on Twitter at Travis Waith-Mair in camel case, and I blog at nontraditional.dev. Now, let's get started. Solid is very familiar to React developers. It has an API that looks very familiar. It's easy to learn for React developers. In fact, I can bet that anybody who's a React developer looking at this set of code probably can follow right away what's going on here. That's because it has a very familiar API to those who are coming from React. For one thing, Solid uses JSX, it uses components, and it uses props. In fact, if looking at this component, there's no way for you to tell at this moment if it's a React component or a Solid.js component. That's because of this JSX components and prop pattern that is used in both languages. Now, Solid has primitives that have a very hook-like API. For example, we have this create signal, which has an API very familiar to those who are used to use state. It also has this create effect primitive that is very familiar to use effect. So there's a lot of similarities that you can bring from React into Solid.js. Now, I'm going to quickly pause here just to make sure there's no confusion. Solid is not a drop-in replacement for React. Unlike frameworks like Preact that are trying to have a compatible API, Solid does not do that. It has a familiar API, but it is not replaceable directly. You cannot take a React component and drop it into a Solid.js project, and it will just work. So we've talked a bit about the similarities, but it's more important to talk about how they're different. And that's where Solid.js and React are different, is how they work under the hood. Solid.js focuses on reactivity, and React focuses on the VDOM. And let me explain that a little bit more in depth. When something changes in React, there's a virtual DOM and the browser DOM that are both happening at the same time. When state changes, all that gets computed in the virtual DOM, and then only at the very end does the actual DOM get updated. And this is where React tries to be efficient, is it can keep things in memory and make all those updates and figure out what changes need to be made, and then does it all once with the browser. On the other hand, Solid.js has lots of reactive primitives, and it surgically goes and updates those places of DOM whenever those primitives have a change. So for example, let's take this counter component. We have a signal, which is kind of like state, and we have an incrementer that will increment it. And you'll notice right there in the component, we have this console log. Now, I've put in here that it only ever gets logged once. That's because components only ever run once. I'm going to say that again. Components only run once. So, yes, when that component runs the first time, when it first initiates, you're going to get that console log. But when things update, when you click on that button, only things that are actually directly tied to the signals, for example, the count, will ever get updated. So you don't have to worry about components rerunning all the time. That's a major difference where Solid.js and React are different. Because in Solid.js, it's not about the components, it's all about the primitives. Components in Solid.js disappear after that first initial render, and it's those fine-grained reactive primitives that do all that heavy lifting of optimizing DOM updates. So what are these Solid.js primitives that we're talking about? Well, pretty much everything can be broken down into either a signal, a memo, or an effect. So what are signals? Well, create signal is how you create signals in Solid.js. And signals, simply put, are functions that return a value. They're used for reactive state. Like I said, very much where you would use useState, you would use create signal. So in this example, we use create signal. It returns a getter function and a setter function. The getter function is where we can pull that value out, and you can see we're calling that function. And then if we want to update the value, we can call setCount, which will update the value of the signal. When setCount is updated, when setCount is called and the value of the signal is updated, then the paragraph up above will update automatically. Now, create effect is very much like use effect. It's an effect that lets you do actions based on when signals updates. And you'll see in here we're updating the document title anytime that the count changes, and it's going to say the current count is the count. Now, you'll notice coming from the React world that there is no dependency array. The create effect automatically, under the hood when it gets transpiled, is wired up to know when count is updated to automatically rerun. There's no need for you to tell it, hey, here's the values that it depends on. It automatically happens by default. Also, if you use a create effect but don't have a reactive value in there at all, it only ever gets called once. Because if there's no reactive value, there's nothing that will trigger an update. Now, create memo is like an effect and a signal put together. Create memo takes a function that works like create effect, where it will update anytime its reactive values that it depends on inside of itself update, and then it returns a signal. Now, as you can guess by its name, this is used for when you have expensive calculations that you don't want to rerun all the time for the same values. So let's take a simple counter example. We have these create signal with a count set count. We have an effect that will update the title every time the count is updated. And in our JSX, we have a paragraph that shows the value of the count, as well as an incrementer that will increment the value of the count every time we click the button. Very straightforward. Once again, this function will only ever run once, and then anytime we click the button and update the signal, then the count, only the create effect and the paragraph will update, because those two things are dependent on the signal updating. Now let's add a little extra complication in there. Let's add an input that takes the value of a signal called my name, and anytime it changes, we update that value of that signal. Well, it's still the same thing where when the count is updated, those effect and the paragraph is updated. But anytime we update that input value, that effect and the paragraph are never touched. That's because they don't depend on those reactive signals. It only depends on the reactive signals of the count. And this is what I mean by Solid.js will surgically update those things that are dependent on reactive signals. Now, it's important to note that primitives don't follow React hooked rules. You don't have to only call primitives inside functions. You can call primitives outside of functions. In fact, as you see here, we have that signal being not just called outside of the function. We're exporting those values. And that's a great benefit because now we can create a global state that can be shared anywhere in any of our components. We can also have conditionally called primitives because our function only ever runs once. So if we want to only have an effect that runs if a condition is present in the props, we can totally do that. Now, there are some gotchas when you're coming from React into Solid.js. And to share an example of this, I'm learning Spanish right now, and there's a lot of words that are very similar to English words in Spanish. For example, in English, we have the word university. In Spanish, it's universidad. In English, we have the word president, and in Spanish, it's presidente. And in English, we have the word embarrassed, which in Spanish, you might think is embarazada. But my Spanish-speaking friends out there will know that embarazada does not mean embarrassed. It means pregnant. So sometimes familiarity brings about situations where we think we know what we're doing, but it's not working out the way we want. It's a false friend. And Solid has false friends for React developers. And so I thought I'd share these now to kind of help you from not falling into the same traps I fell into when I was learning Solid.js. So the first thing I'm going to tell you not to do is don't return early from your components. In React, it's a common thing where if some type of state or props are available, that will return early and show like a loading state. But once that value's there, then we'll skip and then go back and show the rest. You can't do this in Solid.js. And why not? Well, remember, functions run once. They disappear. So after that initial render, the rest of that code is never run again. So that bulk of your component that is after that happens after you return early never gets wired up for reactivity, and therefore it never works. So you're like, what do? I want to have this pattern where if I'm in one state, I show one thing. If I'm in another state, I show another thing. Well, to do that, you use control flow components. Solid.js has a lot of these control flow components that do all the things you want, but without breaking reactivity. So in this example, we have a show component that when we have the data, it will show its children, but it will also have a fallback. So that way you can show something else instead. Now there are many control flow components. We have switch components, for components for doing loops, error boundaries, and suspense. And in fact, Solid.js has had suspense working for a long time. Now, the other thing you don't want to do in Solid.js is do logic outside of your JSX or reactive primitives. And let me show this example here. We have a double counter, and then we're deriving a new value called double count from that signal. And intuitively, you might think, yeah, that's fine. I'm using the signal and I'm doubling the value. The problem is that double count, that only happens once because it's only inside JSX or in primitives does the wiring up happen to know that things need to change. Anything that's in the body of the component only ever happens once and then never happens again. So how do we do that? Well, if you need to derive a value, do it inside of a function and then call the function in the JSX. Or just do it in the JSX or just do it in the primitive. Sometimes we overcomplicate things and it's easy to overthink it. But yeah, just do it in the JSX. Or if you want to, if it makes more sense for readability, yeah, put it inside a function call and then call that function to derive that value. Now, here's a big one for all React developers, because I see this in pretty much every React code base. And that is, people will tend to destructure the props in their React components, whether it's done directly in the function signature or immediately after the function is called. Either way, this will break reactivity in your component. And you might go, what? How's that happening? How does that happen? Well, when you think about it, when you call a component, the value could be static or it could be a reactive value. And just to give you a peek at the magic that happens under the hood, when props has a reactive value, it's actually done as a getter. So when you pull that value name, it's calling the signal under the hood for you. And so you have to treat props as if they're reactive values, as if they're signals. And if you destructure them, then you're doing logic inside of your function, which is a no-no. So instead, just call your props directly inside the JSX. Now, there are legitimate reasons where you might want to split props out or merge props together, and Solid.js has utility functions that allow you to do that. And as you can see here, we have merge props that allow you to clone props, add extra props to the props so that way they can be passed on, and as well as we can pull out certain values from the props while passing the rest onto something else. Now, another big thing that you shouldn't do in React is use React inline style objects. And the React inline style objects will not work. So we're used to using these camel case values. And in Solid.js, you need to use dash separated values. And there's some reasons why it does that under the hood, but the important thing is don't use camel case, use the dash separated values. But the other really cool thing is you can also just use a string. You don't have to use an object if a string makes more sense. So that's the really cool part about Solid.js is you have more options for inline styles. Now this last one, there is no don't do, because I like to emphasize this part is that in Solid.js, because functions only ever run once, you don't need use ref or use callback, because you don't have to worry about your refs or your functions being stale. You can just pass in functions inline, and you don't have to worry, or refs, and you don't have to worry about functions getting called again with stale values. So there you go. No need to use ref or use callback. Just use functions and just take refs and assign them to variables directly. Now, after hearing all that, you're probably thinking, I don't know what to do. I'm not going to be able to keep track of all this. This is way too much. There's an ESLint plugin that's going to help you. That'll warn you if you're breaking reactivity. So don't worry. It's simple to install and add into your linting that you're already doing. So you might ask, why bother learning Solid.js? Well, it's got one of the highest satisfaction rating. 2 years running, it is the highest satisfaction rating in the State of JS survey, and it's only been on the State of JS survey for 2 years. So it's been the highest rated for the last 2 years, even beating out Svelte, which is already been around for a while and has a high satisfaction rating. Solid.js is performant by default. Its creator is a stickler for performance, but he not at the expense of the API. And so you can guarantee that like you're going to have a very performant app by implementing Solid.js as in your project. Now, Solid.js already has a robust ecosystem. You can go to solidjs.com/ecosystem to see it, but there's already routers, UI components, utilities, etc. For example, TanStack, a very popular React library, has solid adapters for them. So if you love React Query, React Table, you can do all those things with TanStack Query and TanStack Table and the solid adapters for them. And I'm also going to give a shameless plug for Solid Bedrock Layouts. My library that I wrote for doing web layouts has a solid version of it as well. There's also Solid Start, which is a meta framework, very much like Remix or Next.js or Nuxt or SvelteKit. It allows you to do client-side rendering, server-side rendering, streaming, SSR, static site generation. So check that out at the start.solidjs.com. So I've convinced you all, you're all excited to start Solid.js. So where do you go from here? Well, I would start by going to solidjs.com. They have a great tutorial to help you get started, as well as a playground to help you play around and see the reactivity and how it works for yourself. I'd also recommend joining the Discord. It's full of great people. Most of the maintainers of Solid.js hang out there and answer questions on a regular basis. I want to thank you, everybody. Once again, my name's Travis. I'm at Travis Waith-Mair, and I blog at nontraditional.dev. And I hope you have a great rest of your conference.
Okay, we're back. What a great presentation from Travis. Let's bring Travis on the virtual floor once again so we can answer any of your questions. Hello, Travis. How are you doing?
Doing great. How are you?
Yeah, really great as well. Really great presentation.
Thank you.
One information to give you. When you were talking about the translations part, if you were learning Portuguese, embarrassed would definitely translate to embaraçada. So in Portuguese, it would work.
So I should be learning Portuguese so I won't have that false friend, right?
Definitely. It will translate directly. So great presentation, I have to say. I really like Solid. I have a sticker here that I got from Ryan Carniato, the creator of Solid. So like he actually he sold me on Solid when I met him last year. And I really think your presentation did a very good job in giving this highlight of, okay, I'm a React developer now. What should I do to go into Solid, and what are the things that I need to take care of? So definitely a great presentation from your side.
Thank you very much. Yeah, I try to present the stuff that tripped me up when I was first learning, and hopefully prevent other people from falling into those same blunders.
Exactly, and you did an amazing job. So I see that we already have a couple of questions showing up. If you have, and just to follow up for the chat, if you have any questions that you would like to ask Travis as well, make sure to leave them in the comments and we'll ask him here. So the first question that showed up is someone asked for benchmarks of Solid versus React. I don't know if you have them at hand or if
I don't have them at hand. But actually, if you follow Ryan Carniato on Twitter or anything, he is fantastic at doing benchmarks. And in fact, he's fantastic at making sure his benchmarks are apples to apples and not just what I think it should be versus what other. He's very good at working with the React team or Svelte team or whatever, and has a good relationship with them to do that. So definitely follow him. In fact, if you tweet him, give me a benchmark, he probably has it available right now and can throw it to you.
Definitely. I think that was actually one of the first things that he showed me as well when I met him in person.
And in fact, he's actually very good about also showing when Solid doesn't perform as well as other things. He's very honest about when Solid is not as good and why they made certain trade-offs. So yeah, definitely follow Ryan and check that out.
I love it. We're doing a love fest for Ryan here, but you should definitely follow him. He's an amazing person and an amazing instructor as well. So bringing back to the presentation here, someone asked you, what about any state management tools? Did you felt the need to use it with Solid? What did you use in this scenario?
Honestly, for when I've worked with it, I've never felt like I've had to go beyond anything that Solid doesn't offer. But I also feel that same way when I'm working in React. I typically don't need to do anything that beyond what is given in the certain frameworks. I mean, definitely if you run into situations where like Redux or something like that is helpful for you, definitely add that in. But just like anything, like don't jump to state management tools if you don't need it. But going with what they have, the using primitives and the ability to call those primitives outside of functions is amazing at making global state so easy. Like we talk about lifting state in React. Well, it's so much easier when state doesn't have to live in a component, when you can just pull it and put it inside of in a module and just import that everywhere, and it just works.
Yeah, definitely. And on a follow-up to that, if you mentioned 10-stack query in your presentation, I know that it has a 10-stack query for Solid as well, so it's called Solid Query, I think.
Yeah,
so,
yeah.
On a follow-up, if anyone would like to try it out, I just remembered because you mentioned that part on your talk. So someone asked, let me look at the next question. Someone said that they didn't catch the problem with destructuring props. Could you talk a bit more about this part?
Yeah. So this really, I think, is the one that like throws React developers off the most, is because like by default, I think everybody destructures props, but like you have to think of props as if they were signals, because you don't know, like they could be signals or they could not be, depending on how they're used outside of the component. So when you're writing your component, you have to think of them as signals. And if you destructure them, that's the same thing as like deriving a value it's basically doing logic outside of the reactive primitives or JSX. And so if you just remember, you can't use reactive signals outside of JSX or reactive primitives, then it just makes sense, because you have to what's the word I'm thinking? It does logic, and components only ever run once, and therefore that destructuring causes that reactivity to get lost, because under the hood, like everything, like what we write is not exactly what happens under the hood. Same thing with React. Like this isn't like new anymore. This is like how all everything works in front end with a framework nowadays. And so basically Solid doesn't know, unless you do it inside of JSX or in a primitive, Solid doesn't know that reactive value needs to be wired up to something, and that subscription and all that stuff that happens under the hood gets lost, basically, because that component ever only gets run once. So the long and short of is, if you do props dot something inside of a JSX or reactive primitive like create effect, you're fine. But if you ever do it outside of that, then you're going to get a situation where things don't work the way you want. And the same thing applies if you don't like to do that props dot something, you can derive that value, do inside of a function, and call that function inside of JSX or an effect, and then your reactivity works again.
Okay, yeah, amazing. It's good to know that, because at least it kind of, and I really like what you mentioned, like React developers, we're so used to destructuring stuff that when going to this part, I also remember that was probably one of the mistakes that I did a lot of times when learning Solid. So I can definitely relate with this part. So on a follow-up question to that, someone asked, is it possible to use NPM packages that are made for React in Solid? And then I'd say that these are 3 questions. Then the second one is, how big is the Solid community? And there's another one that says, is there a lot of helping packages? I would say helping packages for it. I'm not sure I interpreted that part right, but let's start with the first question here.
So no,
are you able to use React packages in there?
You cannot. Like packages that depend on React won't work in Solid, and that's why I wanted to make sure it was clear. Like it's not, unlike frameworks like Preact or things like that will like retranspile and try to be compatible so that like React APIs will just work. Solid doesn't. Like what happens under the hood is not compatible at all. So you cannot just like grab a React package and drop it in. That's the, oh man, I kind of wish like I have this React package that I'm used to. The good thing though is there is a really big community. Like it's and many of the things that like in React are not built by the React core team are actually built by the Solid core team, the same type of packages, so the routers and things like that. And so what's kind of cool about that is that they don't deviate from each other and then like have to kind of reconcile as React decides to go a different way, and then the packages have to kind of play catch up. I remember like when hooks came out and like everybody out there was like, oh crap, now I have to rewrite all my packages because hooks is a whole new paradigm that is not going to work easily. So I have to do all that. Solid, most of this ecosystem is maintained by like Solid maintainers, and so like when they know that Solid's making these changes, and that they start making the updates to their routers and all that stuff right away, and they're not like thrown off guard by the changes that are coming. So that's a really cool benefit, and especially around things like the Solid Start meta framework. We have things like Next and Remix, and that is great that we have this competition, but like you start getting this like they're not necessarily like the React core team either.
Exactly.
And so they kind of sometimes they have to like catch up to what React's doing, versus Solid Start is maintained by the same people making Solid. So it's all being made together with understanding each other together.
Yeah.
And like we've already talked about, some major libraries are being done by the maintainers, like TanStack. But there's also like people who've gone in and like made those, brought those community things that were used in React and ported them over already. So Chakra UI has a version of it. It's not maintained by the Chakra UI people, but the community said, hey, we like Chakra UI, so we're going to like bring that over and make a solid version of it. So yeah, like if there's something you like in the React community, chances are there's a solid version of it. And if not, go build it. There's a fantastic opportunity for you to be the first one to go create it.
Yeah, and there's a very good support for the community. One thing that personally I admire a lot about Solid and the community itself is like they are always on top of everything. I remember like the first time I met Ryan, he showed me a demo of like building server components with Solid, like their version of it. And I was like, wow, this is amazing. Like, okay, React is announcing it, Next 13 that just came around, and they had the same thing working in Solid. So it seems a super cool thing because the ecosystem, they are always paying attention to that part.
Yeah, exactly. And what's really cool is like the good and bad is like they don't have to like maintain an old API like React and Angular and Vue do, because they have this big thing. They can be a little bit more nimble. So Solid Start has already got islands architecture stuff built right into it, where like React, you don't have that like in React by itself. You have to go to like Astro or whatever, which is cool, but that the community has it. But like Solid has already thought about island architecture from the very beginning because it can.
Okay, yeah, amazing. Let's go into a couple of questions to make sure we can get them with time. So there's one question from Priyajit on YouTube. I hope I'm not mispronouncing your name. They asked how to do type checking and testing in Solid.js.
This is also one of my favorite things, is that Solid.js is TypeScript like by default. You don't have to bring in different types. And the other, like, this is a personal gripe of mine, is that the TypeScript types is done by separately from the React community. The React core team doesn't like really participate in the TypeScript types. And sometimes we get this like separation, and then they have to kind of converge back again as React changes things. And so on one hand, I'm really grateful for the community, but on another hand, sometimes like the type community is doing something different than the React community, and it gets frustrating trying to have to like maintain two different things. You don't get that with Solid at all because it's TypeScript from the very beginning. And much like Vue or other libraries are, it's nice when the actual types are built by the people maintaining it, because they change with an update and get fixed by the people who are actually writing the code under the hood, and they know what's going on.
Definitely. And for testing, have you what did you use to test with Solid?
V-test and that's another thing about Solid, is that like it's built with Vite and with these modern like bundlers, and so a lot of the things that you can do. Yeah, I would definitely check out the Vite community along with Solid, because and Vite test is what I use for when testing it, because it just works fantastically already.
Okay. Looking at another question that we have here, what was the biggest performance issue you found working with Solid?
Just like anything that I do, usually the performance issue is the code I write. It's not. It's typically not the Solid code, and so I haven't found. But I find that true with other frameworks that I've messed with, like React, or when I do stuff with Svelte. More often than not, it's the code I've written that is causing the performance problem. So but honestly, Solid.js is, I said in the thing, is performant by default. It is that fine-grained reactivity allows them to do some very cool things that you can't do with a virtual DOM. And this isn't to say that React is unperformant at all, but Solid blows away all the other frameworks. And as it shows, more often than not, the only way to get more performant than Solid is usually to go write your own performant vanilla JS, which means you have to have a deep understanding of how to write performant vanilla JS, which I don't. So
exactly.
More often than not, you're gonna get very performant code, except for probably the code you write will probably be performant, and that's usually the thing that you have to work with most. But yeah, I'd also have to say along those lines, there's usually your intuition on what to do, assuming that you're not writing those gotchas, is usually the right thing to do. And that's what I really like about Solid.js, is that you don't have to understand what Solid's doing under the hood to write performant code. They try to have an API that just is intuitive, and then they do the performance optimizations under the hood for you.
Okay, amazing. Let me see if we still have a couple minutes. We have 2 to 3 minutes. Let's look at this question. So when you talk about global state with the primitives, doesn't the code become hard to manage with multiple components exporting states, especially on big projects?
Yeah, but that's true of anything. It's not necessarily Solid specific. When you're dealing with multiple states that multiple components need to share, yeah, you have to do some orchestrating, and you have to maintain that. I showed the example of exporting that state from the component, but honestly, that was more of just to show that you could do it outside of a component. More often than not, if I have a global state, I put that in a separate file somewhere else where I'm managing that. So it's more of how you want to maintain your folders and keep track of that state. And I didn't really show it in here, but they also do have a provider and consumer. I can't think of what a context. Sorry,
context. Yeah.
Pretty much similar to the way React context works. You have that with Solid, because sometimes when you get to a point, you really, not because you have to, but it's just really easy to grok, having a provider context pattern and have that kind of pattern come into your app. So yeah, you can go along those routes if you need to.
Okay. And on a follow-up to that, are there any public or styled guidelines or best practices on how to organize your Solid projects?
No, it's very similar to the React community, where it's what makes sense to you and your project, do it. Typically what I see is very similar to what I see in the React community, which is try not to go too deep. More, and so I'd say that's the biggest ones. And that's just probably, I think, just generally good practice in general. It's don't make a lot of deep folder nested structures. Don't try to solve problems you don't have. But yeah, if you have a problem where you want to nest certain things together, do it. But yeah, I would say very similar to the React community. There is no Solid.js. This is the standard way to do it. Do what makes sense, but a lot of the patterns you use in React, you can definitely bring those over to Solid. At least that's how I do it, and it just is easy to follow.
And on a follow-up to that, this is a personal question, by the way. Do you think Solid Start will impose some type of structure that we didn't have, of just starting a solid project from start?
Yeah, I mean, it's similar to the way Next.js does with, like with routers and things like that. So as you add more opinions and you bring in a meta framework, that will come in with more opinions, because it's usually more the pattern that a lot of these meta frameworks tend to follow is convention over configuration. And so and that's proven to be a very good pattern to follow. So yeah, I would, as you move into a more opinion thing like Solid Start, yeah, you're going to have more things like that.
Yeah, so I think that this is kind of like a follow-up to this question: is does Solid have any framework like Next.js to SSR? So
Yes, it is Solid Start. And it's in beta, but honestly, it's at this point, it's a pretty stable beta. Like, I'm going to still put don't bring it in production because it's in beta. But like, exactly. Honestly, like, there's a lot of things that I don't think you would be too hard to like start using it. And if you're confident, I don't think it's going to be too big to like maintain that. But like, there's the flag. If you don't have the time to maintain it, because things will change in beta, like, understand that. But like, it's a really solid
pun intended
framework at this point.
Okay, and I think, let me see, this question seems very similar to what we have here. Is wondering about global state. Is there any easy to set up solution, or does create stuff store is enough to set this up?
I am not big in the Redux community, so I don't know if there is. I would imagine there's something that like easily follows, but honestly, like, I can imagine there is, but I don't know. So I'm just going to say I don't know. But like, Redux is designed to be separate and framework agnostic, so I imagine it shouldn't be too difficult to bring it into Solid.
And you mentioned that they have their version of context. So for global state itself, at least seems like a good thing that you can use from the get-go.
Correct. Yes, exactly.
Okay, and I think we're going to the last question here. Someone asked if signal updates are asynchronous.
I mean, well, yeah, pretty much anything in JavaScript is asynchronous, and you have to think but like, you don't have to like await it or anything like that. But yes, like, it is an asynchronous update. And so signals, like, you can, if you need to, do that same pattern where you provide a function to the signal rather than a value, because you need to make sure you're getting the most up to date. You can definitely do that same pattern. But honestly, like, because signals are a function call instead of a value, more often than not, if you drive a value from the signal, you're usually getting the most up to date version anyway. So more often than not, I don't usually use that function pattern, but it is available for updating signals.
Okay, so I think that's all the questions that we have here. Travis, thank you so much for your presentation. I really liked it. I hope everyone watching liked it as well. If someone wants to reach out to you, where they can reach out?
Probably like Twitter's the best way. Like, I'm on Twitter at Travis Waith-Mair with in camel case, so Travis then WM in uppercase. So
okay, so if anyone has any questions, feel free to reach out, Travis. Travis, thank you so much once again, and hope to see you again in the near future.
For sure. Awesome. Thank you.
Bye. Thanks. Okay, so that was it. Now we're getting ready for a 10-minute break before we go to next sessions. This is also the time where you and me part ways, because we'll be changing moderator for the next couple of sessions. Don't worry, I'll be back tomorrow for the senior track, so you're not done with me. But if you're not joining us tomorrow, or if you want to find me any social network at Twitter or LinkedIn, feel free to search by Daniel JC Afonso. It was a pleasure to be here today, and for the rest of you who will be joining us tomorrow, see you tomorrow, and yeah, let's go for a break.
Hello, everyone. Thank you to Daniel Alfonso for moderating the last session where we learned so much. I'm Preston Wallace, Senior Software Engineer at Mountain. I build courses, record online tutorials, and I work in React every day. And I don't know about you, but I'm so excited to learn in this upcoming session. We have 3 great speakers lined up, all software engineers at Adobe. We'll be talking about PWAs, dependency management, React security, all kinds of things. The first speaker we have is Deepa Subramanian. Deepa is a software development engineer at Adobe. She has over a decade of experience as a software professional and is also a Google developer expert. She builds front-end and full-stack web applications and has a passion and curiosity for new technologies. Deepa also spoke at Geekle Node.js, JS, and React Summit 2022. So she's spoken at quite a few of these conferences. And today, we'll be looking with her about building and deploying a React progressive web app to Firebase. So she'll teach us how to create a React application, including registering and using service workers, and she'll show us how to run an audit using Lighthouse. Finally, we'll also learn how to deploy the app using Firebase. This session includes a demo, so please keep your eyes peeled. And with that, I'll let Deepa take it away and show us how to build a PWA.
Good morning, good afternoon, good evening from wherever you're joining me today. I will be talking about build and deploy React progressive web app in Firebase. Thank you so much, Geekle, for giving me this opportunity. Thank you so much, Anna and Nick. Once again, I'm glad to be here. Thanks. My name is Deepa. I'm a Google developer expert in web technologies, and I'm also an organizer for GDT San Jose, an ambassador at Women Tech Makers. Fun fact about me is I love coffee. If you're in the San Francisco area, let's meet up for coffee. And here's a QR code that will lead you to all the social handles that I have. And every top right slide would have my LinkedIn handle too. So let's get started with this. Today, the agenda is going to be, I've split it up in 2 parts. The first part is going to be progressive web app. And then we'll move on to React progressive web app. We'll talk about how to create a React progressive web app using a template. And also we'll focus more on how to make your existing application into a progressive web app by adding a service worker and manifest. And finally, we'll see how to build and deploy. I have deployed, and there is a live application that is right now converted into a progressive web app. So you would see it as a small demo at the end. So some of the prerequisites I expect you to have before we go on in the session is you should know JavaScript and ES6, and you should have developed a web application, at least a vanilla JavaScript one, and you're familiar with IDE, CLI, and it's also nice to have Firebase knowledge too. So to begin with, I just wanted to set the stage as here is a web architecture. It's a 3-tier architecture, right? A fundamental rule in a 3-tier architecture is the client never communicates directly with the data tier, and it has to go through a communication, right? So it's pretty linear when you take a look at this 3-tier architecture, where you have the UI, logic, and then the data. So what are progressive web apps now? These are also web applications which are built with specific technologies and standard patterns so that it makes the user look and feel like it's a native app. So when you create a progressive web app, and if you use it on a mobile or on a desktop, it looks like a native one. So note that I'm referring to native here and not specifically mobile. So you have a web application. How do you classify them into a progressive web app? I call these as pillars of progressive web app. At the heartbeat, you have something called a service worker, which we'll be talking in a moment. And a progressive web app has to be served in a secure portal, right? So it has to be served on an HTTPS, and it should also be responsive, and it contains something called as app manifest. We'll be talking about service worker and app manifest in this on a very high level, But there's also resources that I can provide you for more in-depth information about progressive web app at the end. So stay tuned. So here is a project folder. And if you see in a regular web application, you would have index.html and some JavaScript files, right? So in a progressive web app, you will also see something called as a manifest file, and then a service worker, which is a JavaScript file. So we talked about the 3-tier, where JavaScript, you have your HTML, CSS, and JavaScript, which runs on a single thread to render the elements on the page, correct? So JavaScript, interacts with the DOM API. However, a service worker runs as a separate thread. It does not interact with the DOM API, and it can manage single or multiple pages. It can listen to ongoing requests, fetch them, and cache the responses, and load when the user goes offline, right? So understand that it acts as a network proxy. So how do you, so you say that you created a service worker.js. What do? You have it as a file, but how do you use it inside your application? As you would write a function in your app.js saying that, hey, if you find a service worker file, then register it, right? There is a function called as register. And then it's a service worker is basically an API. So you use it, and then once it finds there is a service worker file in there, it gets registered on the browser. So what are the features of service worker? Like I said before, it can load offline. It can load content offline. It can enable push notifications, and it listens to fetch API requests and by constant background sync. So here is when you have a service worker in your application. So if you go and open Chrome DevTools, and inside the Applications tab, you would see something called as a service worker under the sidebar here under Applications, and you would also see it contains something called a source. It picks up the service worker file, and it also has something called a status, which says activated and running. And then it also has push, sync, and periodic sync and update cycle. Understand that service worker goes through a life cycle, and each time when the user goes and does something, the content gets synced, and then it gets registered, and the life cycle basically changes. It has certain life cycles, such as here it's mentioned install, wait, and activate. So there's a life cycle that goes on with service worker, which I have talked in detail in one other video that I can point out to as a resource at the end. And understand that the caching also happens here. So now let's move on to the next pillar, which is the app manifest, which is nothing but a JSON file. And it tells the browser about how progressive web app should behave when the user installs the application, right? It has to say it is a key value pair. It's very similar to your package.json file. It has some name, it has a name, it has icons, it has a description, etc. So here is a visual for that. And here is a theme color, icons, name, and background color that we have. And we also have this as inside the manifest. And if you see here, it's got it gets the icons from the source, and what is the type of the icons. It is a PNG, and what is the sizing. And it gives a lot of other information as well. Once you have the manifest .json, you should make sure that you link them into your web inside your HTML file. I'll be showing it in the demo as well. So now, what does progressive web app solve ideally, right? Why are we even talking about progressive web app, right? Here is here are the steps that you would do if you have a native app. First off, you would go to a store and you open the store app. Then you would try to find the app. and then download and wait. And once it gets installed, you would have to accept permissions and then use the app. So these are the different steps that you'll perform to use a native application, right? Whereas in a progressive web app, there's only two options that you have. One, you don't want to install it because it's already a progressive web app. You just open it in your browser inside your native device that you're using, be it desktop or mobile. You just click the URL and you start using the app. So that's one way. Otherwise, if you want to install it, there is an install option that's available when you click on the URL. And once you install it, you use it as a native app. So how simple is that, right? So here's an example of Google Photos app. And then if you see in the browser, I have the screenshot from a desktop browser. So if you see, there is an install button here. And then when you click on here, it'll pop up this dialog saying that, hey, do you want to install? So another example on a mobile device is Tinder application on a mobile browser. It has an address bar at the top, and then in the middle is your native app without no address bar. You just have the login information. And if you have it as a progressive web app, you have the address bar, and also you find something in the bottom of this app saying that, hey, do you want to add Tinder to your home screen? Basically, you're creating a bookmark and you're just having it on your device's home screen. So, and not only Tinder, many applications use that. Starbucks, Flipkart, Alibaba, and a lot more applications are moving into progressive web app. So now, okay, you created a web application, and once you have created, how do you know that if it is really a progressive web app, right? There is a tool for that called Lighthouse. Lighthouse is a Chrome extension which you can install it you can add on to your Chrome browser. And once you do that, once you run an audit on this page, it checks for basically, it goes through a checklist of items, and it checks whether the application that you have built is installable, and whether it meets all the requirements, as you can see here. And it also sees whether it's optimized for a progressive web app. For example, it says, hey, it has registered for the service worker, it has a manifest with a maskable icon and things like that. So once you do that and the check passes, you get this green tick mark at the top. So if it has any errors, it'll show up here. And if you click onto this drop down, it'll lead you to what and how you have to fix it too. So now we have the progressive web app architecture, which is very similar to your regular web application, but then it goes through a service worker, which runs as a separate thread, and there's a constant background sync that goes on, right? So every technology has benefits and drawbacks. Some of the pros of progressive web apps are it costs less to develop and maintain. Any web developer can now build a native application using their JavaScript skills, and there's no need for you to submit your application to the App Store. Submit and wait for it. God forbid if it gets approved, you can your app can be installable by many users. And note that you have to go through this process every single time when you try to update your application too. So once you do an update, you have to again resubmit it to the store, right? So this is not there in progressive web apps. So that's one of the major highlights for this, and you don't have to pay for any stores. And there's a study that is being done. There's a lot of higher engagement when people started converting their application into progressive web app, and also there is user engagement too. So these are some of the pros of converting your web application into progressive web app. And like I said, every technology comes with its own drawback. Understand that this technology is not supported by all browsers or platforms. There are specific browsers that are supported. For example, Chrome is supported for Android and Windows, device, etc. But then mainly there are some there's a lack of support on Safari and Firefox, which makes it difficult for different users, right? Target users. And it also takes some time to adapt. People have been using native apps for so long, so it takes time to adapt. So the next thing is the background sync that I was talking about, because it constantly syncs, the service worker syncs your content. What happens is that your battery life can go down. However, there's a workaround on this. There are two APIs that are available. One is a background sync, and then there's one is background fetch. So background sync, you can limit your content to be cached, and then if you want to load more content, you can use fetch API where you can attach it to CDN. There are workarounds, and then you can pull your content based off of that. So these are the cons. So far, we talked about progressive web app. Now let's move on to React, part of this session. So as we all know, React is the most popular JavaScript library. It's highly efficient because it's component-based. It's fast. People can develop applications faster. It's flexible, and there is a humongous support on the community as well. So these are some of the React benefits that we already know. Now, so how do we create a progressive web app in React, right? There are two ways that you can create. There is a NPM template package that is available. Through that, if you do that, it gives you a template already to begin with. If you are a first-time user trying to build something, if you want to quickly mock up something and see, you can use this. However, if you already have an application and you want to add service worker and manifest file to it, there's this way also. So we'll be talking about both, and mainly focusing on the second one. So like I said, you have a package called as Create React Application Template. PWA, it's a mouthful. CRA is Create React Application Template for PWA. There's a package to it. You add this when you create it. You use Create React App, and then you give the app name, and you use this template. Once you do that, once you say, and then you do npm start, it comes with a out of the box. It has service worker. It has service worker registration. As you can see in the manifest, you have all these. The name is there, short name, icons, like I showed before, right? So it comes as out of the box. And once you do that, once you run npm start, you would see it in the local host. You would have this installable icon, and you can, when you click install, it would install. So this is something that you can use it to try. So the next one is we would be creating our own, right? So here's an application, weather application. We'll be building, and we'll be using Open Weather API. And I have built this, and then I've tried to test it locally as well as after hosting. So it did pass all the PWA checklist. So this is what we'll be building. And it also supports offline. So when the user, if you go to Chrome DevTools inside of Service Worker, when you check on this offline checkbox, it'll show up offline content saying that, hey, you're offline. It'll be available once you come back online. So this is also, we'll be doing this. So here is what you would do. You have to, when you create a React application, you would have a source file where you will see app.js, index.js, etc. And you have to, you create inside the public folder, you would already have, you can create your own app manifest. So here I've created a manifest file, and also note that there is only index.html inside the public folder. And I have some images, and this is something that I have added on to my project. So let's move on to the service worker. So we talked about the service worker lifecycle, remember? So I'm just going to quickly skim through this so that you understand. First off, we are trying to create a, we wanted to install the service worker, right? And note that the registration one, it goes into your index.html. So we will have to write either inside a script tag. I think I added this inside the index.html as a script tag for registering it. Once you register it, after that, it installs, right? So it'll listen for, I'm using an add event listener where it opens and it gets the cache. So once, what are the things that I'm caching? It gets it from this offline.html file, right? It listens to it, it fetches it, and then if it matches, it checks whether if it matches with the offline.html. If it is not, it updates it. So it fetches it, and then it also activates it. So basically, it goes through all this registration, installation, fetching, and then once it fetches, it gets activated. So understand that this is the life cycle that we talked about earlier in a very high level. So once you do that, here we have, this is a very important step that you need to do, is to run build. So once you do that, you build the whole application, and inside the build folder, you would have index.html. This is what, if you see, there's no index.html inside your source folder. It's only in the public, but then we still need to take our React code from app.javascript, and then we also need to put it together along with this index.html, right? So for that, we need to build it. So we build the application. Once we build, we have the build folder with all these, index.html, we have the manifest file, we have the service worker, etc. So this is a very important step that you need to do. Once you do it, you're almost there. We have to go now, build and deploy it. We have already built it. We have to deploy it in Firebase. So inside of Firebase, there are a lot of tutorials available. Just go through the GUI part of it. Try to set up a project first. And once you have set it up, it will go through all these steps for you. But we are not going to use any of this Firebase configuration because we are just going to host it, right? So once you do it, just once you create a project, if you go on the left-hand side, it'll show build, and there will be something called as hosting. Click on to the hosting, and then it'll show you on the right-hand side to get started. Click on the get started button here. And then these are the steps that you need to do. So one thing that I wanted to specify here is once you have to install the Firebase CLI. Once you do that, you log in your command line, and then you do Firebase init. And before you once you say deploy, it's going to ask you which folder, and make sure that you do all these steps inside of your project folder, root folder, and you have to say specifically, it will ask you, do you want to build this? Don't say build, just say, I want to use the build folder here, and then say no to other things, because it will rewrite URLs if you index.html if you say yes. So we have already built it, so you just have to say that you have to pick up not the public directory, but the build directory. Once you do that, you say Firebase deploy. Once you're done, we have the application here, which I'll be showing it in a moment. Here is the demo that I wanted to show for the application that I've hosted in Firebase. Here's the application. As you can see, there is an install icon at the top here on the browser where you can install. This is a weather application that I created. So if I go ahead and it picks up the information from Open Weather. So if I give Austin, it does show the weather at Austin in Celsius. And if I go and check the DevTools here, and as you can see, there is a manifest, there is an icon here, which is what you would see it as a favicon at the top left here on the tab. And inside the service worker, as you can see, this one is installed and it's activated and running. If you go to the console, it says that registered successfully as well. And if you see inside the cached storage, you would also see an index.html and offline.html. Now let's go ahead and run this and see whether it passes audit, right? That's the whole idea about this. So let's change it to mobile. And then because we built this as a web app, I don't know whether you saw that real quick. Minute it showed the offline message, but it'll also show up here. See, it does show for an offline message too. As you can see, it passes, it is installable, it is optimized for PWA, and it does pass the check. So this is something that I wanted to really quickly show on this demo. So let's move on to what we had here, right? So here is okay. So I have some resources provided for you for Progressive Web App here in the left. If you click onto this, it'll take you to my YouTube video where you can learn more about, if you're new to a Progressive Web App, you can learn more about it on this video. And I also have a bunch of blogs about Project Fugu and Progressive Web App. Project Fugu is Google's project, which deals with a lot of Progressive Web App APIs. So I have a bunch of blogs about it. You can go read about it as well. So where you go to the next level is if you are new to Progressive Web App, but you're familiar with React, you can start working on server-side rendering, real-time data, and you can also connect it to Firebase real-time database too, and try to use APIs in Progressive Web App such as payment, notification, geolocation, etc. And you can also try to see how you can automate service worker and use advanced APIs too. So the possibilities and the learnings are more. And this technology is going, I know it is getting very popular these days. And there is a code labs that I've provided the link with here. You can take a look at it too. And with that said, my name is Deepa. You can connect me with the social handles that is there in the LinkedIn Linktree QR code. And thank you so much for your time. And if you have any questions, let me know.
Thank you so much, Deepa. That was an amazing presentation. I learned so much, and I'm sure you all did too. As you all know, we accept questions in the chat, and now we'll have the opportunity for Deepa to answer some of those questions for our viewers. So let me bring on Deepa. Hello, how are you?
Hello, hi, good morning, good afternoon, good evening. Thank you so much for having me here.
Yeah, great talk and welcome.
What about security? I'm seeing the questions right here on the chat.
Yeah, right. So the first one here is,
yes,
what about?
It is secure because it is, like I said, it is very secure because it serves only in the HTTPS portal, right? So that's the protocol that we use, so it is secure.
Awesome. Wonderful. Yeah, if whoever asked that question, if you have any follow-up questions, feel free to ask it as well. Next question here. Yeah, is there any research that shows that PWAs are better than other solutions?
Actually, I was researching, and there is a study that says that by 2030, I think this technology is going to take off more rather than, yes, there are other solutions available. There is Flutter there, which is a cross-platform too. So having said that, you have to learn a new language for that, right? So if you are a web developer already with JavaScript skills, I think this would be very ideal for you.
Right, certainly
And
lowers.
there is going to be a 30% or 30 to, I think, 70% increase, something around the numbers that I read, that this technology is going to pick up.
Right, it certainly lowers the barrier to entry for those that want to create an app for something like that. Yeah.
And if you're still going on and trying to do it, submit it in App Store, it is still possible. There is a PWA builder. If you go and look at those templates, and they offer you out of the box, you can customize it for your own needs, and you can also submit to the stores.
Wonderful, wonderful. So next up, so do these resources cover the challenges of building a PWA and or service worker? I heard.
I didn't cover the challenges of service worker, sure, because I was thinking that it's a junior talk, but that would be something for the future. I'll definitely think about it and write something about it too in my blog.
Great, yeah, and so as you all know, she shared her link tree and the QR code, so definitely go to her LinkedIn and other places to find more about that. So then the next question, does the service worker know when a cached file is updated?
Yes, it does, because that's what the service worker listens for, all those events, right? So when the user revisits the page, and if there is anything that is new, it'll get cached up and it'll get updated. That's what the activated does for you.
Great.
The function that you write. Yeah.
Awesome. Yeah. Wonderful. Thank you so much, Deepa. I think that was the last of our questions here.
And I'm not too sure if the link was passed on to my presentation. If you can pass it on, that'll be great. I have added the same. If you try to open the demo link in your mobile phone and go offline, you will see the offline message, because if you go offline, I couldn't record that because when I switch my Wi-Fi off, I couldn't record. So if you go and see in your mobile device, it'll still show up. And please do I added a couple of slides on this particular link so that it'll be much more clear.
Great, great. Well, Deepa, I know that you already had a couple of links on your talk as well, but what is the best way for people to reach out to you or to follow you or things like that?
That's why every slide would have it on the right.
Right. Okay, so LinkedIn.
LinkedIn is my go-to. Right. Please reach out to me. If you have any questions, please reach out.
Great. Wonderful. Thank you so much, Deepa. And
thank you so much, Kristen. And thank you so much, Nick and Anna, for having me here. Always a pleasure to be here. See you soon.
Wonderful. All right. So again, thank you so much for that. And our next up, we will have Tyler Hawkins. So Tyler is a senior software engineer at Adobe. His areas of expertise are JavaScript, React, accessibility, design systems, and testing. Tyler has written over 110 articles with over 1.5 million views. And I'm sure that it's not 1.5 exactly now. It's probably a lot more than 1.5 million views on various tech platforms, and has spoken at all kinds of conferences. You should really check out some of his talks and articles. He's got an impressive amount of content out there. So today, Tyler is going to be helping us understand dependencies in JavaScript to create a more performant create a more performant app. So web apps are, rarely written from scratch, and we depend on libraries and frameworks for nearly everything. And so we'll be, introducing all these extra packages can lead to bloated apps that are large and slow. So Tyler's going to be showing us some strategies for using dependencies more effectively, like using tree shaking and lazy loading and bundle analysis and all things like that. So there's quite a bit there. So I'm going to bring on Tyler here. So welcome, Tyler.
Hey,
so excited to hear this talk.
Yeah, thanks for having me. Happy to be here.
Yeah, for sure. So with that, I will hand the mic over to you, Tyler, and take it away.
Awesome. Thank you. Let's see, my screen is, are we sharing the slides right now? Do we need to get those going?
I see. Sorry about that. There you go.
Yeah, no worries. You're good. Sweet. Well, yeah, thank you, Preston, for the introduction. Appreciate it. As you mentioned, this talk is titled Understanding Dependencies in JavaScript to Create a More Performant App. My name is Tyler. I'm a senior software engineer at Adobe. As Preston mentioned, I love to speak. I love to write. You can find some of my stuff on Medium or Devs, where I usually publish my articles. But yeah, if you want to look at the things I'm thinking about or learning about, feel free to give me a follow there. Diving right into the talk. As I prepared this talk and began to put together the demo and the content, I realized that the talk name is perhaps a little bit misleading. And so the revised title here, if you will, is a bit longer. But what we're going to talk about today really is using bundle analysis to create a more performant app, particularly by only loading what you need. And so what I mean by that is this is a topic that earlier in this conference, Miško talked about this. He gave an amazing talk on Qwik-React. And he talked a lot about the different strategies that a lot of our modern frameworks are using. And this has been kind of a focus for the last, I don't know, few years. But the kind of consensus seems to be in the React community and then in the developer community is that we've been shipping these apps that are really bloated. React comes with a lot of code. We have a vast ecosystem of NPM packages and React packages that we can use. And we just ship all this JavaScript to the browser, which leads to these really bloated apps. It makes users download a lot of code. And for us that have, faster machines and great internet connections, we don't really feel that impact as much. But users with maybe a slower internet connection, or who are maybe viewing your app on their phone, start to pay the penalty for that. They start to see, slower load times, slower speeds with the apps, which leads to a lot of customer frustration. And so what we're going to talk about today is just how we can better understand our apps by using bundle analysis to kind of dig in and see where is the bloat coming from. So that's what we're going to look at today. As part of our talk, we're going to be looking at this Pokédex app that I built. I am very much a visual learner. I like seeing actual demos and working code as opposed to just talking about abstract concepts. That really helps bring it home for me. So we're going to be looking at this app, and we're going to explore this journey of how we can make this app a little bit more performant. So as we go through here, I'm going to be sharing, you've got just my whole screen. You can see the app, and then we'll also dig into VS Code a little bit here. So we'll be kind of toggling between the two. But right now we're looking at this app, and I'm going to make sure I have this running. I'm going to reload this real quick. Great. So we have a Pokédex app here, and you can see that you can catch all your Pokemon. You can mark them as captured. You can see that we've got all 151 Pokemon here. We're not going to acknowledge all the different generations. You could filter by ones that are captured. You could filter by specific type. You can go through all those Pokemon, right? You could click on a specific Pokemon, come through here, see a bunch of dummy data about the Pokemon. You could even save it as a PDF. This functionality, I'll admit, is not that impressive, but it's using JS-PDF under the hood to create a very basic and boring looking PDF. Not exciting at all, but we'll get to that in a little bit of why we're including that here. Then we also have this little about page. So that's the app. Not super complex, but it's also not a trivial app, right? We've got several different pages. We've got some different components. And underneath the hood, what this is using is, this is a React app. So it's going to be using React and React DOM. It's using React Router for the client-side routing. It's using Material UI for our design system or component library. And then for that PDF generation button, it's using JS PDF as one of our NPM packages that we'll be using. So we've got some code that we've written, and we've got some code that is a third party that we're depending on. And so let's imagine that we have this app and users are starting to complain that it's slow and it takes a long time to load. And so if we dig into that, you can see I've got my developer tools open, I've got the network, and you can see if I'll refresh this page one more time, and I've disabled cache, so I'm just reloading everything on each new page view. But when we open this page, it downloads this main.js bundle. That's the little content hash right there. And it's 241 kilobytes. And as we navigate around, you can see I can navigate to a different page, and it doesn't download any more JavaScript. I can navigate to one of the specific Pokemon pages, and it still doesn't download any more JavaScript. So we've essentially just got this single bundle that we're looking at. And regardless of which pages the user visits or actually cares about, they're just downloading everything. And so the users or the visitors is really kind of paying that penalty, downloading all of that code that they might not even want or need. And so our first question might be, okay, it's 241 kilobytes. Like, that seems pretty large for this very small app. What's contributing to that, right? And so the first tool I'll show you, a little trick, is we're going to use a package called Webpack Bundle Analyzer. There are a whole bunch of different bundle analyzer tools out there. My app is using Webpack, and this is one. I really like the visualization that it creates. So Webpack Bundle Analyzer is one of my favorites. But what Webpack Bundle Analyzer does is it creates a visualization of all of the makeup of your JavaScript bundle. And so to use this, I'm going to kill our server real quick. I've already run npm run build stats. And so that's just creating the production bundle for me. And then by passing it this stats flag, it's generating this bundle stats.json file. And so that's just some metadata about the makeup of our bundle. So now if we were to run npm run analyze using that script that I've added, we can pull up this sweet little visualization. So this is the output of Webpack Bundle Analyzer. And this is the makeup of our entire app. And so you can see over here on the left, it gives you some file sizes of all the different chunks. You can look at, I believe stat is unminified, parsed is minified, and then gzipped is minified and gzipped. So we're going to look at the minified and gzipped since that's what's actually being delivered to the user. And you can see these are the different chunks that it's created. This is all of our code. And so we have this main one. It's reporting that it's 234 kilobytes. If we go over here to our React tab, this is the same main one, and it's 241. So there we go. Make that big again. So we have this main bundle, and it's a single bundle. We also have a few other bundles that are created over here that our app, you saw, never actually used it. We've got one for this Canvas G library. We've got one for HTML to Canvas. We have one for DOM Purify. We won't dig into those too much, but those are some separate bundles that this JS PDF library already created and code split out for us nicely so that we don't actually have to download them if we're not actually using them. So they were nice and did us a favor to split those out. So we'll ignore that for purposes of this talk and demo. So we're going to focus just here on this main chunk right here. So we don't really have a lot to go on at the moment. We know that we just have this giant amount of source code, and then we've got some node modules for things like React or React on. And so we might start to think, okay, we've got this giant bundle. How can we start to break that down a little bit? How can we make that a little smaller and just deliver to the user what they need or what they want? So that's the first step. We've started analyzing our bundle. We have a little bit of insight into what it's made of, right? A lot of companies or teams, you might be surprised, they haven't taken time to look at this, right? They don't know why their bundles are so big or what's contributing to the bloat. So first step, get some visibility in there. Once we've done that, we might use one of our first techniques, which would be to do some lazy loading and some code splitting. So this is functionality that React supports. So you can see right now we're using, this is our main app file. This is where we set up all of our routes with React Router. So you can see we just have these different routes, and each one renders a different component. So it might render the Pokédex or the About or the Pokemon page, right? So what if instead of doing that, I'm just going to comment this out real quick. What if instead of doing that, we decided to lazy load some things? We'll uncomment that. And while that's going, I'm going to build this real quick. It usually takes about 20 seconds. So to avoid some dead time, or build that and then we'll talk about it. So I'm going to do npm run build stats. Preston or whoever, if it starts to get laggy or the audio is bad, please let me know if it's too much running in the background. But so while that's running, let's look at this lazy loading. So this isn't anything new. This has been around in React for several years, but it's often underutilized. So what lazy loading lets us do is, rather than just importing all of the code right out of the box, it lets us import it on a lazy basis and only actually import and download the code when it's needed or requested. And so for all of our routes, rather than importing the pages for Pokédex, About, Pokemon, and this no match page, we're going to do lazy. So we'll do lazy, and then this function that returns the import to that. And then inside of our router, for each of these routes, the element is no longer just the page. Instead, we're going to wrap it in this suspense component. So that's another component that React provides. And that is going to be our fallback content. So basically the loading content or a loading spinner while we're waiting for this wrapped content to be loaded. So I don't have anything fancy in here. It's just showing a ... but you'd probably put like a loading spinner or something in there. So we've done that for each of these components. So let's take a look at what happens there. So in the background, we were already running npm run build stats. And you can see now it's created many different files. We don't just have that one main file anymore. We have a bunch of different chunks. And you can see that that main in particular was drastically reduced. It's down 153 kilobytes. So now it's only down to 87. So if we were to take a look at this, let's get this running again. So I'm going to do, I'm just using like a static local server here. So I'm just going to do serve-s build. And just going to run our app just on localhost 300 or 3000. Okay. So now as we run this, you can see that it's downloaded many different chunks. It's downloaded the 87 kilobyte main chunk, and then a couple more here, right? If you add those up, we get up to about 135 kilobytes. So we're now downloading 135 kilobytes on page load instead of blanking on what it was before, like 241, I think. So much smaller. And as we navigate around the page, you know, maybe we go to this About page and it loads another chunk. And so to get to the About page, it only costs us 2.5 kilobytes, right? And if we go back to home, that's already been loaded. Now we could go maybe to one of our Pokemon pages. And you can see when that loaded. Now it loaded in a few more chunks. We got 110 kilobytes and 5 kilobytes. So you can see it's loading these pages on demand, right? If a user comes to your app and only ever visits the home page, they now no longer have to download all of the code for the rest of the app that they might not need or might not care about. So we've saved them a lot of time and a lot of resources, right? We could take a look at this with our bundle analyzer again. So I'm going to come back here and I'm going to do npm run analyze. It's going to pull up our visualization tool again. So now as we look at these again, you can compare these to the former one. So the former one was just this main giant static, single JavaScript file. Now we've got several of them, several different chunks. And so as we look through here, you'll see a couple of familiar ones. You'll see like these old ones that we weren't using, like the HTML to canvas and purify. So we'll ignore those. But you'll see some new ones now. So we have this main one. So this is the shared code that all of our different pages are using. And you can see in main, it broke it out into, it's mostly our node modules. It's all of React, React DOM, it's Material UI, it's React Router, and then this tiny sliver of source code, right? So our main shared chunk is mostly kind of this infrastructure, third-party stuff that we're using. And then we have smaller chunks. So some pages only use a part of Material UI. They use a few different components. These two over here on the right, these are just our source code. So like the pages themselves are very, very small. Most of our app is really just built out of these third-party dependencies, which is contributing to the size of it. And so this one that's most concerning is this JS PDF one. All of these are in the visualization are the size of it on the page is correlated with the size of the actual chunk. So this is the largest chunk. It's bigger than all of the rest of our main stuff. We have this JS PDF. And as we looked back at our app, like when we navigated to this page, it downloaded 110 kilobytes and then 5 kilobytes for that page. And you're probably wondering, like, why does it need that much JavaScript just to show an image and a button and some text, right? Why does that take up 115 kilobytes? And so we could start diving into that a little bit more. We might think, okay, this page is taking up a lot of JavaScript, and we know that we have this JS PDF module here. So let's dig into that a little bit. So as our next tool, what we might go into is go look at the Pokemon page, the index.js. And you can see right here, we're importing JS PDF from JS PDF. So we're importing that library. And then we have this save as PDF function. And that's just used as the on-click handler for the button. And so if we take a look at that, all this does is creates just a new instance of this JS PDF class, and then sets some font and text and then saves it. So that's all it's doing there. But again, it's representing about 110 kilobytes of our app. And so what if maybe we have some tracking in our app, you know, maybe you're using some monitoring and logging tools, and you know that most people really don't use this export to PDF button. It's a nice feature for the small subset of people that need it, but most people ignore it. And so once again, you're making a majority of users pay a penalty to download all of this code where they don't really need it or want it. And so what if we dynamically imported it? So I'm going to comment out what we have here. Get rid of this guy. Then we'll switch over to our second set. Okay, uncomment that. And let's look at those changes here. So now what we're going to be doing, I'm going to run the build again, just so we don't have any dead time here. So we'll do npm run build stats. Build that real quick in the background. So now you'll note here, as we look at our import statements, we're no longer importing JS PDF up here at the top. So very similar to what we did when we code split our routes. Instead of loading those routes at the top, we're going to dynamically import it. And so if we go look at our button, look at our Save as PDF button, you'll note that as soon as we click that, we're going to call import JS PDF. And then, so that returns a promise. So then we will work with that module and then create this new instance of the JS PDF class from there. So very similar code. The only difference is that we're now importing it here inside of this function as opposed to just at the root of the file. So let's take a look at that now. So we've got that. Let's run this. So let's see, let's serve this. We'll do serve-s build. And it's going to be loading our app again. Give that just a second here. Then go back to our home page. Okay, we're going to clear this and then go back to the start. Okay, so we've loaded the home page. Again, we've got our main, and then we've got a few different chunks that this specific page needs. And now let's go visit a Pokemon. So let's go click on that. And you'll note that when we loaded that page, it only loaded 5 kilobytes. So much, much better, right? We've just gotten rid of like 95% of the JavaScript on this page. And so if I just want to view this page, that's great. I can view it and I can walk away and navigate to another page, and I've only downloaded 5 kilobytes. But now if I want to save this as a PDF, I can click on this button and it downloaded the PDF. And you'll note that when I clicked on it, it then loaded this code, right? So now it loaded this 110 kilobyte chunk. So that whole giant JS PDF library has now been lazy loaded and dynamically imported and kind of tucked away in this button so that people don't have to download it unless they need it. Also of note, if I click this again, you'll note that the functionality just works here. It's not like it downloads it again. So once it's been dynamically imported once, it's there to stay. If we were to go look at the visualizer again, so let's do npm run analyze. Take a look at this. It's going to pull up our Webpack bundle analyzer again. And what's interesting to note is that not much has really changed. If we were to take a look between this latest one and then the second to last one, they're really identical. The content hash has changed briefly just because we commented out some of the code. So the content hash is different, but the sizes of them are really the exact same. And so what's interesting here is that throughout this experiment is we haven't really reduced the size of our bundle at all. All we've done is we've chunked it and we've made it a better experience of when things get loaded, and also makes it conditional for if things get loaded, right? And so we could look at like the full bundle size. So like all the chunks here are 349 kilobytes. All the chunks here are 349 kilobytes. And all the chunks here are 339 kilobytes. So as we went through this, we actually added 10 kilobytes to our total bundle size because there's a little bit of overhead with kind of coordinating these lazy loading and code splitting. But we've created a much better experience for the users so that things only get loaded when they actually care about them. So I'm going to go back and we'll go to our slides for a minute here. We'll come back here. Get that slideshow going again. If you wanted to play around with that at home, the GitHub repo is github.com/thawken3/bundle analysis demo. But a few takeaways from that. So the first takeaway, we should use a bundle analyzer. Again, you might not have a very good idea that there is a problem at all or how to solve the problem if you're not inspecting this stuff. So use a bundle analyzer. I really like Webpack bundle analyzer. If you're not using Webpack or if you're using some other build tool, there are dozens of other great bundle analyzers out there. Second key takeaway, use lazy loading to code split your app, at least by the page route. So most people expect kind of a short delay as they're navigating between pages. That's a pretty normal experience on the web. So at least start splitting by route, and that should be a really good start. From there, you can start to split by different features, or you might split by different maybe modal content or other things that are dynamically used. Third, use dynamic imports to code split heavyweight pieces of code. We looked at how we could use that JS PDF, the dynamic import for the JS PDF, save as PDF button. If most people aren't using that, we can just dynamically import. We can keep that away from most people. And then fourth, choose third-party dependencies wisely. So this is the part that we haven't really touched on yet, but we might be asking ourselves, why are we even using this to begin with, right? JS PDF is the one that we chose. It's a great PDF generator tool, but there are also a lot of alternatives out there, right? So maybe this one is a very, very large library, which it is. And maybe there are some other tools that we could use instead. Maybe there are some smaller libraries, or maybe we don't even need it at all. Maybe we don't need like a professional looking PDF and just the like browser's print functionality would work just fine. And so it's important to choose third-party dependencies wisely. One last tool I'll give you in your toolkit is Bundlephobia. It's bundlephobia.com. You can take a look at any package that you want to add. So for example, we could look at JSPDF. And you'll note here that, yeah, it's huge, right? It's reporting 107 kilobytes in minified and gzip size. So take a good look at your different dependencies that you're using. A lot of time we're using larger packages that maybe we don't need. Another good example is something like moment.js. That one, I'm sure you've seen the announcement. It's been deprecated for a while, but they've essentially declared Moment dead. Moment is a very large library, and there are other alternatives out there, right? Like DataFens or Day.js. But look at potential alternatives to your bundles. And again, all of that can be visible to you if you're using a bundle analyzer tool or something like Bundlephobia to kind of be smart about those and think about those as you include them in your app. We'll go back to the slides just one more time. But that's it. Thank you so much for listening. Again, these are not new tools or new tricks, but I do think they are underutilized. So hope you learned something new. Hope you found a good way that you can take this back to your work or to your app or your product and reduce that bundle size, make it a little bit better performance for your users. Again, my name is Tyler. If you want to find me, you can find me on LinkedIn, sometimes on Twitter, and mostly on Medium and Dev. So thanks.
Great. Thank you, Tyler. And yeah, thank you so much for those amazing tips. I found that quite informative. I do have a few questions, if you will. So one of them is, do we have something like spread and register for controlled components as well?
I'm really sorry, but I have no idea what that means. I don't know what this registered is.
I mean, obviously it's like spreading in some sort of props into the component, right? I'm not exactly sure what that means. I figured maybe you might know, but no. Okay, well, if somebody has a follow-up question to that. The second one, oh, I see. I guess this is the follow-up to that. This is what the question means. So where React.js updates the component value every time, the default values get reset without explicitly setting it and passing it in to the component.
Trying to understand what that would be in reference to the React.js up. I'm not sure if that is a question for my talk or not.
Yeah, register. We're like register service workers. Well, yeah, let's go to the next question.
Okay.
And I'll see if I can figure out what's going on.
Maybe that was for the previous talk.
That might have been for the previous talk where we were talking about PWAs. All right, next question. How do you manage caching when creating chunks across multiple builds?
Yeah, so that's great question. So when we create multiple chunks, create lots of different chunks across multiple builds, your app might consist of, instead of just a single chunk anymore, maybe it's 100 different chunks. Like in ours, we ended up with probably like 10 or 12, I think, was the end result of that. And so the important part is for Webpack specifically, but this applies to all bundler tools, is that you can control how the file is named. And so for our Webpack setup, it's using the content hash. And so you saw, if you remember from like the network tab, it was like main dot, and then like, ABC123, whatever .js, or it would be chunk dot whatever .js. And so that random string is not really a random string, it's the content hash. And so what that means is that when the content of that chunk remains the same, the hash will remain the same. And so if you think about, maybe you are deploying your app on a fairly regular schedule, maybe you have daily deploys or weekly deploys or whatever, you don't want to be redeploying basically 100 new bundles, right? Because now the user has to download all of those. And so instead what happens is that if maybe you only changed the content of like 7 of those bundles and the other 93 remain the same, right? Then that means those other 93 still have the same content hash, which means it's the exact same file, which means that the browser can still cache that and use that, right? And so that's the beauty of controlling that content hash there, is that you can then, the files that don't change remain cached, and the files that do remain get cache busted. And then obviously you can set like your content headers or caching policy of like, we want to cache these for a week or 2 weeks or whatever, but it's all about that content hash and the file name.
Fascinating. Oh, really good answer. Next question. How do you determine which dependencies should be lazy loaded versus eagerly loaded? And are there any trade-offs to consider when making that decision?
Yeah, that's a great question. I think oftentimes it will come down to using data. Like, I don't know if there's, going to be one right answer that I can give you right here, but I can tell you the right answer will be to use data and make your decisions based off of that. And so, for example, I mentioned using like I'm blanking on the name, but like an observability tool or something, right? Like maybe you use New Relic or Datadog or Sentry or something. And so you should have a good idea of which pages are commonly visited or which features are commonly used. And so based off of that, you can make these decisions of which should be lazy loaded versus eagerly loaded. The PDF example that I gave you, while this is a fictional app, that's actually based on a real world app. This was something in my job like 3 or 4 years ago. We had some export PDF functionality, and it was absolutely massive. And because we knew based on data that it was very rarely used, we decided that was a great candidate to lazy load that. So like exactly what we saw in my demo here, like we drastically reduced the bundle size of the actual page. And then for like the 1% of users that actually cared about it, they could click the button and download the PDF later. So use data.
Nice. Yeah, so use data. Perfect. Next question. If you lazy load a library dependency in one page of your application and another page also uses that library, does your bundle get re-downloaded?
That is a good question. If it's the exact same bundle, I would think no. So like we saw, like this isn't the exact thing, but we saw with the export PDF button that once I loaded it once, right, it had downloaded it. And then if I clicked the button again, it didn't try to re-download it. So I would expect it would be the same thing. If it's the exact same bundle and exact same content, the browser would just know, hey, I already have this.
They probably figured that out. That would be pretty cheap if they didn't figure that out.
For sure.
It's like you just split it all up and then we're re-downloading everything multiple times. Great. What bundle analyzer do you recommend for ES build?
Oof. I don't know. Sorry. I don't have experience with ES build. I mean, for React specifically, I think if you just Google like React and then bundle analyzer, like they give you like 5 different ones. Yeah, but there are a lot of different tools that are like bundler agnostic, right? So all of these different bundlers can generate like these bundle stats.json files, and then these different bundle analyzers can just take that data and grab it. So
yeah, interesting. Then I think we kind of covered this a little bit before, but what are the trade-offs when using lazy loading?
Yes, we covered it a little bit. So the trade-offs, right? The pros of lazy loading is that it doesn't have to be downloaded up front, right? So smaller bundle size. And again, if you're using data to determine which features are probably not necessarily used as much, that means you're benefiting a majority of your users. The cons is that when the functionality does get requested, so when I do click, for example, that Save as PDF button, there may be a slight delay, right? Because now it's actually downloading that dynamically. And that's the reason, like in React, we have that suspense component. So it does show like that fallback or a loading spinner or whatever, right? So you get the upfront benefit of not having to load it, but then if you do use it, you're going to have a slight delay, show that loading spinner.
Yeah, to follow up with that, actually, is there a simple way to have suspense component keep the current rendered component instead of displaying the fallback?
The current. Oh, okay. So like if you were transitioning between multiple different pages and we want this, I'm trying to understand what the context is for that. Like I assume maybe they're talking about like page transitions of like if you navigate to one page and then you're going to the next page, maybe you don't want to show the loading spinner. You just want to keep the old content until the new appears.
Until it loads.
Yeah. Yes. I don't have the details off the top of the head, but I do know that the React docs actually cover that in pretty good detail. They actually cover that exact question. I want to say it's like a use, don't quote me on this, but it was like a use transition hook or something like that. But for that exact use case of like, keep this content until this next thing shows.
Nice. Awesome. And in your experience, what are some of the most common causes of performance issues in web apps related to dependencies?
Yeah. The biggest one I've seen has just been like an inattention to what gets added to your app. So, you know, you're a developer and you're needing to build a feature and you think I'll use a third-party tool because it's cheaper and I won't have to build it myself, right? Which is a great trade-off, a great rationale, right? And so you include it in your app and you say, well, it's just 10 kilobytes, like it's fine. But then 50 other developers do the same thing and they say it's just 10 kilobytes, right? And then all of a sudden your app is composed of like 100 different, you know, little widgets and whatever, right?
Inching your way towards
exactly, and it's super bloated. And then, you know, you kind of realize that, and then you start analyzing it, and you're like, we've got all this stuff. How do we pare back? But now we're already using it, and it's going to be a pain to like try to strip out or replace these things. So the biggest like thing I've seen is just being very judicious in evaluating packages before you add them. So making sure, like, there's a lot of things you'd want to check, not just bundle size, but like, is this package maintained well? Does it have good tests? Is it accessible, right? But yeah, be careful before you add it. It's probably the most common thing I'd see.
Yeah, I'm going to skip to this question. Can you explain what tree shaking is and how it can help with app performance?
Yeah, yep. So tree shaking, this is something, we didn't cover quite in the talk, but I did put it in my talk description. So fair question. But yeah, tree shaking is this cool thing that ES modules can do. It was introduced with Webpack specifically. It was in like version 3, I think, and we're on 5 now. So it's been around for a while. But the idea of tree shaking is just that, just like a tree shakes dead leaves off of it, tree shaking is it's just the name for the fact that when you create a production build, like unused methods or functions that you don't actually use in your app, just get tree shaked out of the bundle. So they're not even included at all. So tree shaking is particularly important for, like if you're authoring a third-party library, like maybe you are authoring the design system that is then consumed in other apps. You want to make sure that your design system is tree shakeable. And there are a lot of good docs on that. Like Webpack specifically has a whole bunch of specific tips of how do you actually do that? How do you make your library tree shakeable? But yeah.
Awesome. Well, wonderful, Tyler. That's all of the questions that we have. And thank you so much for sharing all of that knowledge with us.
Yeah, thanks, Preston.
Yeah. And why don't you just say one more time, what's the best way for people to connect with you?
Yeah, if you want to reach out, feel free to follow me on LinkedIn. And again, if you want to look at any of my writing, feel free to find me on Medium or Dev.
Awesome. All right.
Sweet.
Thank you again.
Thanks, everyone.
All right. That was wonderful. And finally, I get to introduce our last speaker for the day, Jayton Birch. Jayton is a software engineer at Adobe. He has a bachelor's in computer software engineering and also holds a master's in cybersecurity and information assurance. He has an extensive experience with React.js and front-end architecture, and quite frankly, is an expert in application security. So today, he'll be talking about securing your React app, finding and fixing common vulnerabilities. He'll debunk a couple of myths for us, and he will be talking about client-side injection vulnerabilities that are still in the top 3 of OWASP top 10 web vulnerabilities year after year. So he'll talk about vulnerabilities that fester in common React.js patterns and may even go deeper under the nose of a seasoned React developer. So this is gonna be great today. Let me grab Jayton here, and there he is. Hello, Jayton. How are you?
How's it going?
Great. So this is gonna be a great talk to end the day, and I'll let you take it away, Jayton.
That's great. Forgive my unprofessionalism. I did arrange for a
yes. I'm sorry. Yeah. So we will. Yeah, we'll.
Oh, so it's just like an intro. I'm so sorry.
Yeah, I just wanted to introduce you.
Yeah, but just to clarify, I'm a master's student. I don't want to claim that I have a master's.
Thank you for correcting me. I was like, I was just so excited to share that. So.
So don't have that.
Student of the master's.
But yeah, this is very exciting. So so that's basically what my talk is about. It's got security is such a big topic, and then front end security is like another topic within that, and then React is like another kind of like micro one. So
all right.
So yeah.
Thank you, Jayton.
Thanks.
Hey, how's it going? This is Securing Your React App, Finding and Fixing Common Vulnerabilities. I'm Jayton Birch. Welcome. I am your host. I'm a software engineer at Adobe. I'm a full stack engineer focusing primarily on web-based technologies. So a lot of UI work, all that UI work is primarily in React. I have the CSS LP from ISC Squared. So I like security, particularly regarding the software portion of it. And for better or worse, basically since graduating college, I've been a React dev, and it's kind of been like a love-hate kind of thing. but I'm sure we can all relate. That's all why we're doing this, right? It's good stuff most of the time. So my primary motivation, my inspiration for this was constantly hearing these React security myths. I see them online in tech forums. I hear them at the office, and I hear them a lot when I've had jobs where we've moved to React in our tech stack, and these myths have kind of been used as like a selling point, as like, oh, React does this, and it does. One of the biggest myths, it protects us from cross-site scripting automatically. It's magic, it's impervious, it's bulletproof. I've heard that a ton. And when I've heard that a ton, I've repeated it a ton. But that's not true. It's not true. There's a lot of benefits that React gives you, a lot of tools and protections. But the complacency that one dev might have when hearing those things could result in being a little bit lazy in implementing some protections with cross-site scripting. So what is cross-site scripting? You probably already know, but just like a quick recap. Basically, when a user submits text to a web application to be saved at the data layer, and it is then reflected somewhere else in the app. And the vulnerability is if the app takes that text and interprets it and compiles it and executes it as JavaScript instead of text, then really bad things happen. So, and it's particularly bad when that text can be reflected to other people. And it's a really bad vulnerability because the browser has a lot of security implementations in place, particularly the same site origin policies, where, if you have iframes going on and you have all these different JavaScript files from other sources, it won't allow them to access, your document object, like your cookies and sessions, unless it's from the same origin. So when these cross-site scripting attacks occur, the browser thinks it's the same origin and it thinks this is legit JavaScript code. And so the attacker can access everything in the document object, your sessions, cookies, doesn't matter how strong your password is, how many, you got your two-step verification app going on, doesn't matter. They could just log in as you, essentially. And so sometimes I've thought erroneously in the past, this is so simple and silly. It's like we learn it security 101 in college. It can't be that prevalent, right? Well, yeah, it's one of the most prevalent ones that exists. So the OWASP top 10 list, which is like the industry leading surveyors for tech vulnerabilities. In 2017, the number one was injection, including JavaScript injection. So very similar to cross-site scripting, but cross-site scripting was number 7. They've combined cross-site scripting and injection and placed it at number 3. So it's one of the top ones. So if we look at number 1, breaking access control, yeah, you give people permissions they shouldn't have. Catastrophic failures that results in people not accessing your service. Yeah, pretty simple. Your server goes out. But when it comes to the first vulnerability of just improperly implemented code, injection, including cross-site scripting, is the first one. So having it be common knowledge isn't making it go away. It is still really prevalent, and we're still pushing up these vulnerabilities, right? And so let's look at some other data. So let's look at this. So HackerOne, you've probably heard of it, but it's the vulnerability disclosure program service. So, hackers can find vulnerabilities and companies pay them bounties. If you just search cross-site scripting, it's still happening. So we got Shopify, Uber, Line, TikTok, Department of State. That's a good one. Slack, Reddit, GitLab. Yeah, still prevalent and still happening. Some of the best companies with the best funding and resources are still pushing out cross-site scripting vulnerabilities. So big deal, right? Let's look at React. This is the supposed library that magically makes cross-site scripting go away. It is so prevalent. It is almost the de facto tool like in the State of JavaScript survey. Really good survey if you haven't looked at it. But despite the buzz for a lot of other tools, your Solid, Svelte, some of the full stack frameworks like Remix and stuff, React is like the de facto. It is just everywhere. And we know that from other surveys like the Stack Overflow ones and just data about job listings and things. But in just this survey, the amount of people sampled, React is almost double the usage of its most similar contemporaries like Vue and Angular. So XSS or cross-site scripting vulnerabilities, big deal. React, very common. See where I'm going with this? If React is so great at stopping cross-site scripting, why is the issue still so prevalent? So that was some data, but let's look at some actual code now. So let's, oops, that's not what I wanted to show you. Let's go here. So here I have some JavaScript that's super stupid simple, where it just reflects input text to the DOM. And here's my function that does it. I get the value of my input. And I set the inner HTML of this H1 tag. So there's no sanitization. It just takes whatever raw text you have, inserts it into this document. And so the browser doesn't know whether to interpret it as JavaScript or regular text. So it could basically do whatever you want. So if I insert this payload, if you can see it, so I'm going to insert a span element with my attribute on mouse hover to execute JavaScript, my classic alert 0. So if I reflect it, there's my text. But when I hover over it, JavaScript is executed. And so there it is. Ta-da, we're hacked. And this JavaScript, I'll continue to remind you, has access to the document object. So that's cross-site scripting. So you're supposed to sanitize that input. You could do DOM purify as the common one, and you clean it up, make sure there's nothing sketchy in there before you render it to the document. But if we compare it to React, so let's start typing here. I'm typing my stuff, and it gets reflected automatically. I don't need to click a button, right? Because it's React. It reacts. It's so great. It's so reacty. But let's insert the same payload as before and see what happens. Boom. Nothing. It inserts it. It doesn't interpret it as an HTML tag or JavaScript. It just thinks it's a string, and that's what it is. So it is rendered safely. It is escaped. So that's one good thing that React does that benefits you. So you don't have to do any sort of boilerplate sanitization of user input text if you do it properly. But there's still a lot of open doors in React. So one common one that's probably a bigger one now is HTML attributes. So one common attribute, we have our anchor tag and our href attribute to, put a URL or something to send the user somewhere. You could have a JavaScript URL. So if I put this in here, all right, so it renders here, it doesn't do anything there. But in the link, it is putting this JavaScript as the href attribute. So when I click the link, I am hacked, right? And this is React, right? Not impervious, still happening. We're still doing it. Yeah, so, obligatory dangerously set inner HTML. Like we said, React escapes all those characters for you when you render strings to the DOM. But if for some reason you don't want that escape to happen, you want to render raw HTML, you have your dangerously set inner HTML, which is properly named to remind you that it is dangerous. And you have to manually sanitize it if you are going to do that, if it's not from a trusted source, even if it is from a trusted source. And they talk all about the cross-site scripting vulnerabilities there. So yeah. So this myth is perpetuated. If you just kind of Google it, I did a little bit for fun. I Googled is React cross-site scripting proof. This says, this means that the user input will never be executed, making the React secure in terms of cross-site scripting. That's not true to be talking in like a general sense. It's like a half-truth at best, and at worst, it's misinformation that could lead people to depend on something that doesn't exist. Oh yeah, and we got our forum. So in Stack Overflow, people are saying, this is like the first one that popped up. Looking at a React tutorial, it says cross-site scripting protection is the default. How is that possible? There's lots of arguing underneath. But yeah, that tutorial, probably not super great, right? But so yeah, the truth, there's great tools that React offers you to prevent cross-site scripting, but is not impervious. And we shouldn't be complacent in mitigating those vulnerabilities because we assume that it just magically goes away. All right. So yeah, so some solutions. You could really depend on a linter to help flag you when these things are around, because they're not bad. Dangerously set inner HTML, or even manipulating inner HTML from an element that you query from the document. I mean, that's not bad. There's purpose in it, but kind of just like flagging you to look at it to ensure that their sanitization is a really good way to do it. And so you could have those checks in your pipeline, or you could have them in your Git hooks. So like, while you're committing, before you send stuff back up, like to your repository. All right, here's a good one. Implementing protections against injections is the backend's job, and the front end is just a nice to have. So this one's really common thinking because, security is to protect data. Data is on the back end. And, if the back end sanitizes the thing, why does the front end have to sanitize the thing? Is that redundant? It's not redundant, and it's usually necessary. So, so my primary point in this demo will be that reflected data from cross-site scripting doesn't just come from databases. So when things come from your database, they're served up from your web server. You have all this magic happening. You have all this super secure sanitizing happening. But data can come from other places. One, I'll show you right now in this little demo that I made. Okay. I made this wonderful application, my memory saver. It's great. I add some details about memories, like a title, description, a link, and an image, and I put them on my memory wall. And, we could suppose that these memories could be shared through other people that are logged in the application. So we're going to need to have some good security. So let's suppose that backend sanitization is happening, and cross-site scripting vulnerabilities can't be reflected back to other users. So like if we just make I've done this before, so I have lots of saved stuff. Okay, so I'm going to make this memory. It's a dog. This is my dog. This link, I know, goes to eventually makes its way through props into an href attribute of an anchor tag that's rendered to the DOM. So I know that could be malicious. And so when I click submit, I get this little demo of my memory. And look, if I click the link, I'm hacked, right? So, but I entered in this data. So is this really a vulnerability? Because when I click save or send or submit, it'll go and it'll get sanitized, and no other user will have that payload, because when it gets saved, it'll be cleaned. So by the time they get it, it might have like no link or something, or an error will get thrown or something. So let's look at the code for this. So that little preview that you saw, here's some of my stuff. So that preview is generated by the URL search params in my window object. So that's a very common pattern. So let's go through it. So if I go through it again, it's in my dog, here's my hack, there's my image, we submit it. So look at my URL. So the form data is kept persistent by the URL query search params. And this is a common pattern. So like, this is a pattern when like, maybe you have like an app that's like a shop and someone doesn't complete their form. You could email them a link and it has their form half completed and they could complete it and you don't have to depend on cookies and things. Or for sharing. So you could share this link and it'll generate in somebody else's browser without having any data from the database. So, so this link, here's the link of my sketchy memory that has a JavaScript or a cross-site scripting vulnerability in it. And you could see it, it's URL encoded, but you could see it. So my link equals JavaScript, alert, hacked. Yeah, so if we click it, so let's pretend I'm someone else. I click it, I go, oh, wow, Jayton, great memory. And I have that vulnerability in my browser, even though we had state-of-the-art validation and sanitization on the back end. So this kind of demonstrates that in the world of single-page applications where, your URL path doesn't mean file path anymore, it just means anything that the developer wants. That's a lot of data is reflected from the URL path. So basically if data doesn't come from the database, then everything that the server does in terms of security is irrelevant. So to kind of show this out in the wild and not in my silly demo app, I just searched XSS URL path in HackerOne for vulnerabilities that had this that were disclosed. So like, here's a good one. So Reddit. So Reddit had an email verification service that, depending on what was in the path, it reflected data from the URL path in the browser, and it was interpreted as JavaScript. And here's an image of when that vulnerability was in place. So if a user was logged into Reddit, for example, and this link was shared to them, they can have a malicious payload in the path, and then that JavaScript would execute, and a hacker could get access to their account and steal their cookies and sessions. And it's a good one. They're paid $5,000. Little skimpy, right? Can we say, right? Reddit, come on. But yeah, it's common and it happens. So yeah. So that was our myth. So the truth is, front end needs to be secure, the back end needs to be secure. I know, revolutionary. Never thought of it before. But joking aside, sometimes we think of like injection vulnerabilities as like a chore that kind of gets passed along, and as long as somebody handles it, then we're good. And that isn't the case. So the attack vector for each part of the stack is different for the same vulnerability. So like we demonstrated, the backend could handle vulnerability, an injection vulnerability, but if the front end doesn't do it, it's a different attack vector. So it's not so much a pipeline where a chore goes down and somebody has to pick it up. It's every part of the stack has to consider these vulnerabilities. All right, another great myth. My node modules are always safe because NPM, they check if it's sketchy. They have a committee of people to grant and bless these packages to be installed. And I know that because so many people use my packages, right? Well, we know that's not the case. Yeah, this is a really easy topic to pick on. Some of the, new web application development patterns, or rather culture, has made us super dependent on third parties for silly things. There's so many packages to pick on, but this one's awesome. So like is odd. It tells you if a number is odd. 500,000 downloads. So I don't have data to prove this, but if I were a betting man, how many of those 500,000 people have looked at this code that they're using in their app to see if it's secure? I don't know. Probably not that many or any. Lots of dependency managers. They sometimes do research. JFrog, you've probably heard of, but yeah, they have it. Sometimes they do research and post about maliciously named packages in NPM and how they have pretty egregious payloads, stealing tokens, environment variables. They go on to mention a really common tactic of naming a package very similarly to a popular package, sometimes fudging the encoding to make the characters look the same, but they're not the same, so they register differently. And it's just like straight up malware. Yeah, there's lots of good tools. I wanted to mention this one. This one we use at work. Third party, so it will audit your dependencies. You can do it in the command line, and it will query against the open database of vulnerabilities tied to the dependencies. So you know if there's anything sketchy, and a lot of those vulnerabilities are tied to GitHub issues. And so you can see what's going on, see the chatter, see if it's fixed. And a lot of the times they are fixed and your application just needs to update them. And so you could have this run in your pipeline. You can have it break if there's vulnerabilities in your dependency tree. But yeah, NPM. So the truth is NPM is the Wild West. We just need to be extra careful. And a common term in application security is shifting these concerns left as possible. So like in earlier stages of your pipeline, in your development pipeline. So it'll be really helpful in your, so like I said, your Git hooks or your pipelines. Yeah, so some solutions. So NPM audit is good too. It's not amazing because it doesn't hook up with like GitHub and any of these open vulnerabilities that are declared, but it'll know if it's out of date, and you could have that flag you in your pipeline or your Git hooks, and same with Sneak. And yeah, okay. So to close, yeah, right? Can we do it? Obligatory AI. I know it's cheap and easy, but it's a good thing to look at. So here I have ChatGPT. This is the exact component from the React XSS demo. So we talked about what the vulnerability was. See what it talks about. Yes, there is a security vulnerability in this component. See what it says. Yeah, so it calls it out right here. The href attribute of the anchor tag. Yeah, so and another common concern with like this, hold on, this is distracting. I'm gonna go back here. But so React is obviously aware of a lot of these open doors, but a lot of these things like using the href as an XSS vector of attack wouldn't be patched as like a security patch. It would be considered a breaking change. Some people may depend on this functionality. I don't know, but like if we look at the console here, sorry. But if we look at the console here, it says a future version of React will block JavaScript URLs as a security precaution. So let's suppose that this was patched tomorrow and it was registered as a breaking change in their versioning. Every React app would have to update and handle those breaking changes. And if it's a breaking change, they might purposefully not do it for a long time. So even if some of the things you saw today were patched by React tomorrow, these will still be concerns for us for a very long time. So thank you for joining me. We are React developers. We are still concerned with security. Just because the front end doesn't need to worry about security is a myth. And so vulnerabilities regarding React code is all our responsibility. There's not like a magic React security team at your work, I bet. So yeah, thanks.
All right. Thank you so much, Jayton. That was quite informative.
Thanks.
So if anybody has any questions for Jayton, please do submit them. We have a few here to start off with. First of all, how do you stay up to date with the latest security threats and trends in the React.js community? Are there any particular resources or communities that you rely on for information and support?
That's a really good question. So like in terms of security vulnerabilities, there's like a spectrum of little ones to be concerned about. And then there's ones where if you just have like your Apple News on your phone and you like search by security. So it's like, if it makes it to headlines, then it's pretty a big concern, but there's a lot of robust React communities. There's like the React, there's like the React subreddit that's good. There's like Discords and things like that. But basically, if there's anything notable, and most vulnerabilities come like from like new packages or patterns or things. But if there's anything notable, it usually makes the rounds. And so I haven't found like one perfect source, but yeah, just kind of curating them.
Nice. Yeah, that makes sense. If it was a really, really big vulnerability, that it would most likely make headlines. Yeah, cool. In your experience, what are some of the biggest security vulnerabilities you've seen in React apps?
Well, yeah, so
you went over a few, but I mean, like, what are maybe some of the bigger ones that you've seen in personal experience?
So ones I've seen personally, like kind of like what Tyler said with his demo was just like reminiscent of something he experienced at work. My little demo of like things reflecting in the URL and links being malicious based off the href. I've seen that in my personal work at my last job because I pushed those vulnerabilities and I made those vulnerabilities. So like lots of learning there. So but like nothing bad happened, but just kind of really interesting. And that's why I did that, because I was guilty of thinking I don't really need to sanitize this because this is React, and I kind of have that mindset. And so some good learnings. Nothing bad happened. Just it's good. So like tried to like make my demo app similar to what I was experiencing at that job.
Yeah. What are you talking about? We're developers. We don't make mistakes.
Yeah, exactly.
Okay. So the next question here: how can we build with security in mind from the beginning of a project? Is there anything like one of the first things that you can do to set up and secure a React application from the get-go?
That's a good question. There's a big discrepancy between like textbook perfection of security versus like what really happens every day. The textbook will say that you need to have like threat modeling in your design and all that, and you have to have your threat modeled and all the different vectors explicitly described. And that's not going to happen. If you have a new feature for a new button that does a thing and talks to the database, you're not going to get like a round table of security people to do that. And so just making your efforts go towards the pipeline instead of everything specifically. So for example, I mentioned like Sneak. We use that at work. It's a third-party thing that checks our dependencies. That's amazing because we don't have to really put a lot of thought into it. That's where the value.
I see the Sneak billboards all over LA.
Yeah. Oh, really?
Driving up and down the freeway.
Yeah. So that's good too, as well as like I also mentioned like you could have linting patterns. You could have them tied to the project, or you could have them in your IDE to like warn you of if you're doing anything weird with like dangerously set HTML or things like that. And so just the more you can automate to not think about it is good. So to answer the question, one of the first things to set up a secure React application is just have your culture and system and pipeline of making new software be secure. So yeah.
Nice. Cool. So last question here. Any good open source tools for running security tests on your app?
Oh, that's a good question. I have some start on GitHub, but
nice.
Let me see. There's some. All right, I can't pull them up right now, but there's Sneak. I don't know how much it costs. I don't know, but there's.
My company pays for it. I don't pay for it.
Easy one would be, you could do npm audit to just audit things, and there's really good. There's tons of repositories of different kinds of cross-site scripting payloads. Like if I won't share my screen, but here's one. It's called Awesome XSS, and there's tons of ones like this where, depending on where text is used, it could be interpreted as JavaScript in very specific scenarios. So if you have like a list of 100 strings, you could test each one, and some might be vulnerable and some might not. And so,
interesting.
Yeah, there's lots of good knowledge bases around that. But yeah, I'm sure there's more. I just can't think of any off the top of my head.
Awesome. All right, so we did have another question pop up. Do you have a kind of checklist that you would follow to make sure your app is as secure as it can be before pushing to production?
So, yeah, the textbook answer is yes. We're supposed to have if anything goes to production, we have kind of like a robust questionnaire of all things, not just security. But in reality, if you're fixing bugs or things, you're not going to consider all this every time. And so for a checklist, I would say a checklist isn't going to benefit you if you don't have like a culture of security awareness where you are, because you might just check it off assuming that it's right anyway. So
make a commit. There's my proof.
Yeah. So the code review process is really important for this, to make sure that we don't commit anything vulnerable, and just kind of having a culture and an understanding of it is the best. So
awesome. All right. Well, great. Thank you, Jayton. And I think Anna will be joining us. Great. Hello, Anna.
I'm here. I just was talking in our team chat that I really loved your topic, and unfortunately, just because of your time zone, I was worrying will people watch or not, because it's literally last topic, and it's after 8 hours of conference, and people were literally sitting and watching us 8 hours. And I can say that it's really good numbers we have now, and I can say that definitely it's a good presentation, and I'll share feedbacks from our audience as well with you.
Thanks.
So thank you for your presentation. Preston, thank you so much for your moderation. Next time, definitely, I hope I will know. Now I know you, so you can submit a topic before the deadline, and we can figure out something. So guys, thank you so much for being with us. Thank you everyone for listening these 8.5 hours of long presentation and a lot of content. Also, I have to mention that we have next React Global Online Summit this year in November. So please, definitely we'll send you an email, don't worry. We will remind you about that, but also keep in mind that we will have another React Global Online Summit 23 volume 2. So yes, I hope to see everyone there as well. I wish amazing evening, day, night, whatever you guys have, and hope to see you tomorrow as well for our senior talk.
Cool. Thanks.
Bye, everyone.
Thank you, everyone, and see you soon.
Thanks.